everyone, welcome to Blockchain Full Course 2024 by Intellipaat. You must have heard and traded in cryptocurrencies such as Bitcoin, Ethereum and Litecoin. And for all of these cryptocurrencies, blockchain is driving force. Currently, there are over 85 million blockchain wallet accounts. The oldest cryptocurrency Bitcoin is valued as $125 million. This tells us how quickly this blockchain technology has grown and how fast people have adopted it. Blockchain is not just limited to digital currencies. It can help across multiple industries such as supply chain management, healthcare, food delivery system, voting system, etc. On Naukri.com, there are almost 23,000 blockchain developer jobs available across the India. CoinCubes reports that more than 40,000 blockchain-related jobs available in USA. The salaries offered in this role are attractive as well. In India, blockchain developer can earn between 6 lakh to 22 lakh. Whereas in USA, they can earn between $89,000 to $200,000. Companies are always on lookout for skilled blockchain expert who can develop decentralized system for them. So, if you like the concept of DeFi and want to make a positive impact on business, it's time you start learning blockchain skills. And to help you with that, we bring you a free blockchain full course. This blockchain course has been taught by top industry experts from companies like PayPal, IBM, Coronado, etc. and aims to make you job ready. This blockchain tutorial for beginners is curated to get you job. We have strictly aligned all the topics in this course to blockchain developer job description. Towards the end, we will also take you through the important and most commonly asked blockchain developer job interview questions. But before we get started, make sure to hit the subscribe button and click on the bell icon for Intellipaat YouTube channel to never miss out on any updates coming from us. Now, let me take you guys through the agenda for this session. We will start with introduction to blockchain, then we will move ahead to blockchain and Bitcoin. Then we will understand Bitcoin mining and Ethereum and working with the smart contracts. Then we will see how to set up a private blockchain environment. Moving ahead, we have Hyperledger and Hyperledger Composer. After that, we will start with creating a private blockchain with MultiChain. We will conclude this particular session with blockchain interview questions.
What is blockchain? Blockchain technology is a way of recording and storing information in a secure and decentralized manner. It is a digital ledger of transactions that is maintained and updated by a network of computers rather than a single centralized authority. Think of it like a digital ledger that keeps track of all the transactions made in a certain network. Each time a transaction is made, a block is added to the end of the ledger and a record of that transaction is stored on it. This block is then linked to the previous block in the chain, hence the name blockchain. How does it work? In a blockchain network, transactions are verified by a group of computers called nodes. When a transaction is made, it is broadcasted to the entire network, and the nodes work together to validate the transaction and add it to the next block in the chain. Once a block is added to the chain, it is extremely difficult to alter or tamper with the information stored on it. This is because every block in the chain contains a unique code called a hash that is generated based on the information stored in the previous block. If someone tries to alter the information stored in one block, it will change the hash of that block, making it easily noticeable by the other nodes in the network. Benefits of blockchain technology. One of the key benefits of blockchain technology is its security. Because it is decentralized and each block in the chain is linked to the previous one, it is extremely difficult for anyone to tamper with the information stored on it. Another benefit is transparency. In a blockchain network, all transactions are recorded and stored on the ledger for everyone to see. This makes it easy for anyone to view the history of transactions and verify that they are accurate. Finally, blockchain technology also has the potential to increase efficiency and reduce costs. By eliminating the need for intermediaries such as banks in transactions, blockchain technology can speed up the process and reduce the fee associated with traditional transactions. Applications of blockchain technology. Blockchain technology has a wide range of potential applications. It can be used in finance, healthcare, supply chain management, and even voting. For example, in finance, blockchain technology can be used to make cross-border transactions faster, cheaper, and more secure. In healthcare, it can be used to securely store and share patient information. In supply chain management, it can be used to track the movement of goods and ensure their authenticity. Conclusively speaking, Blockchain technology is a revolutionary way of storing and recording information that has the potential to transform many industries. By providing a secure and transparent ledger of transactions, it has the potential to increase efficiency, reduce costs, and increase trust in the digital world. Whether it will live up to its potential remains to be seen, but it is a technology that is worth paying attention to in the coming years.
Transformation in the trading unit. So, of course, everybody knows this that from the ancient times we have not been using fiat currency or the paper money. Initially, that there was barter system, then came gold coins or copper coins, something like that. And after so many things, then we evolved to get printing money or considering paper money as the mode of payment or trading. Then after a long time when internet came into picture, then we moved into online banking or digital representation of money. Then came certain type of tokens called digital money. And then we have the recent one is decentralized digital money. And that is what is called is Bitcoin. Okay, so now Bitcoin is one of the cryptocurrencies, or you can say it is first cryptocurrency, and it is also called as decentralized digital money. So now we will see what Bitcoin is, why it is decentralized, and why was it introduced. So what is Bitcoin? So the brief definition about Bitcoin is that Bitcoin is a type of cryptocurrency which is nothing but a digital money. So it is called as cryptocurrency and it is nothing but a virtual money or digital money. And the underlying technology that enables the moving of digital coins or assets among individuals is blockchain. So Bitcoin is the first application of the underlying technology that is blockchain. So it is the first cryptocurrency application of under which this technology was based on, that is blockchain. Okay, so I think by now everybody knows that Bitcoin is the first most popular cryptocurrency, and the technology that is built on is called as blockchain. Earlier, a lot of people tend to mix up these two, that Bitcoin, blockchain, or same thing. But it's not. Bitcoin is the application, and the technology underneath that application is blockchain. So that is all we need to understand. So what is blockchain? So blockchain is an incorruptible digital ledger of economic transactions that can be programmed to record not just financial transactions but virtually everything that has a value. So a blockchain, as it is said here, that incorruptible or tamper proof or immutable. So these words when you hear, or you cannot modify, not modifiable. Ledger. Ledger means a book of records or a way to keep your records. Records as in transaction could be anything, any records. So so blockchain is nothing but a non-modifiable ledger of economic transactions that can be programmed to record not just financial but anything that has a value, or we can call it asset information. Asset means that which has a value. So that is blockchain. All right. So it is immutable digital ledger of transactions that can be programmed to record not just uh, programmed to record any anything that has a value. So that is the basic definition of blockchain. Okay, it's tamper proof, it's a digital ledger, and it can store anything that has a value. So this is what is said here. So we will see more stuff, more things about blockchain in the further slides. So now it's like broken down to many definitions that blockchain has. Okay, so we will see each. It is simply a data structure where each block is linked to another block in a timestamp chronological manner. So here, if you see, these are blocks, right? There is block 1, block 2, block 3, block 4. So basically what it is saying is it is linked, like it's a data structure. The structure is of block and they are linked together and they are created in a sequential manner with a, it's like on in a chronological order with a timestamp. So what the time at which they are created, it is stamped onto this block, and that's how in a sequential order they are created, and that's how they are linked with each other. So this linking, how they are linked, we have not spoken yet, but they are saying in the definition that they are linked blocks with timestamp. Okay. So this is what they are saying. Each block is linked to another block in a timestamp sequential manner, right? That is clear. Now we move on to the next part, that is, it is a distributed digital ledger of an immutable public record of digital transaction. So as I mentioned, it is immutable. You cannot modify the records inside those blocks or inside the blockchain. And the ledger which we speak is distributed. So it's not just one person who has the ledger. There are people, various people could be part of this blockchain network, and that's how the ledger is distributed. So like maybe for example in a office there are many people in the office, let's say 10 people, and whatever accounts any ledger is, accounting ledger is that your accounts, what company is doing and everything. So any financial transactions. So it's like no one person can hold it in the blockchain. Everybody, those 10 people in the office will have that same ledger with them. They can check how many transactions are being done, or already that transaction has been done. If somebody is trying to modify it, they cannot, because 10 people are there in the network to check whether the transactions are intact or not. So you cannot just modify one copy because everybody will know that you are modifying. So something on this line. So ledger is distributed among people who are part of that network, and it stores digital transactions. So whenever we speak about blockchain and Bitcoin, so these are all digital transactions, right? There are no physical transactions, all are digital transactions. So every new record is validated across the distributed network before it is stored in a block. So this information or the transactions that we speak about, how are they stored in this blockchain ecosystem? So these transactions are stored inside these blocks. Okay. So these blocks hold the certain number of transactions based on some things which we will see later. So for now, these transactions are stored inside these blocks, and before storing them in the block, they are validated. So these transactions are checked across the network or the blockchain ecosystem by the people who are part of this blockchain network, they check the transactions first, and after validating it, they store it in a block. Okay, so these blocks hold certain number of transactions inside them, and these transactions are stored after validating it. Okay, how it validates, who validates, that is something that we will see. So all information once stored on the ledger is verifiable and auditable, but not editable. So whatever the transactions we store in the block, right? So they are verifiable, you can audit it, but you cannot edit it. So once they are stored inside the block, then you cannot modify the details of those transactions. Okay, so that is one thing which is the fundamental of blockchain, that is it is immutable, right? In the second point we speak about this, that it is an immutable public record of transactions. So this is what it is saying. You can check what is there, but you cannot change it. So each block is identified by its cryptographic signature. So each block has a cryptographic signature through which you can identify that block. So this signature is something like block ID, an identifier of the block using which you can identify the block. Okay, so and the first block of the blockchain is known as the Genesis block. So whenever a blockchain network is created, so ultimately the transactions are done and they are stored in the block. But firstly, there is one configuration block that is called as Genesis block, where the configuration of the entire blockchain is stored. So it is the first block in the blockchain. It is also known as the 0th block, which means the entire blockchain is based on this block and the information inside it. It is a configuration block and it is called as Genesis block. So in this slide, we can define blockchain again, that it is a data structure where each block is linked to another block with a time-stamped chronological manner. It is also an immutable distributed public ledger. Yes. No, a new record will be stored as a new record. It will not overwrite the old record. If you are doing the same transaction now that depends. Okay, there can be various cases. Now, if we talk about purely financial transactions of sending some amount from one person to another, then it will be, if you are trying to do the same transaction again, then it will not happen. But the new transaction, what you are saying, it can be stored as a new record. It will not overwrite the old record. And Genesis block does not have the transaction. It has just the configuration of the blockchain. The transactions or the record go into another subsequent blocks which are created based on Genesis block. Timestamped means it has date and time, the date and time at which the block is created. Okay, if my block is created now at 8:29, so if my transactions are there validated and I put them inside the block will have the timestamp of 8:29, which means I will get to know when the block is created. And chronological means sequentially. So if this block is created. So now at 8:29, I have sent the block to uh, to be a part of the blockchain. And if the 8:30 another block comes to be a part of the blockchain, the my block will be the first 8:29 wala block will be in the blockchain first, then the subsequent block will be attached to the blockchain whenever after 8:29. It will check the seconds and everything. So that's why it is time stamped. Time stamping is date, time, seconds, everything, and sequentially it is then stored. No, it will not be considered as a duplicate transaction. It will be entirely new record. So yeah, so it will be a new record. It is not a duplicate record. What happens here is, so now this can be confusion later. So different frameworks function in a different manner. So now if we are talking about Bitcoin, so Bitcoin may there is just coin transfer, right? Bitcoin transfer, and each coin is traceable. So if you are trying to spend the same coin twice, then that is not possible, as Bitcoin avoids double spending. So it will check the coin's identification and it will not allow the record to be overwritten, or to it will make sure that your transaction fails. But what happens is, if you are modifying certain details now in Bitcoin, you cannot modify it, as we are just doing transfer of coin, right? If we are in, there is another blockchain framework where we are storing some information or data, and if I want to modify it, I can update it, and it will be stored as a new record in the blockchain. Older record will be there. The information of that old record will be there, but the updated one will be added as a newer record. Yeah, so data redundancy is can be, so here the data is stored not in the directly, but it is stored in the hash format. So they are in the form of hashes. So so that is very a good way to store. So data is hashed. So there is not like your normal database, your SQL, your data is stored, or by no SQL, the data is stored in a JSON format. So here it is stored in a hash. So that's why the redundancy is avoided. So you see here, so we have our block one as Genesis block. We have the subsequent blocks, and inside the block we have transactions, and the way that these blocks are linked together is using previous block ID or previous block information. So as I said, every block has a or a cryptographic signature, that is block hash or block ID. And what happens here is, this block will have block ID of this previous block. This block 3 will have block ID of previous block 2, and block 4 will have the previous block ID, and that's so on and so forth. That's how they are linked together. And so if you try, so every block will have different ID, right? And the transaction, so this block ID and block hash, okay, so why they are like this? What is the purpose of having this block hash, this block hash of the previous block, and that's the linking is happening on the previous block hashes. The reason behind it, we will discuss that later, but for now you just see that Every block is linked with the previous block hash, and every block has the transactions. To access data of the first ever created block, you have to decode it from the last block created to the first block. So to access data of the first block, so that you have to traverse through the blockchain from the last block to the first block. So here there is no data as such in this Genesis block. There are no transactions, but some information is there, metadata. But if you want to access information of the previous block, then it will traverse through the blocks from the last to whichever block you want to access or wherever the information is there. So that's what it means. Okay. Okay. So blockchain tectonic shift in 2017, the venture capital flows around $10 billion were invested in blockchain. Then in 2023, that is now, the development phase is going on. The age of consortium, alliance, and governance, 10 next platforms, product launches. So that was planned, so predicted to be happening in 2023. Then in next year, there will be blockchain inflection point attain critical mass. And then in 2025, point of no return, blockchain being used. Sorry, blockchain will be used by 85% of global technology. So these are blockchain tipping points and how it will impact the society. So in 2023, the tax collected by the government, so 1 trillion sensors connected to the internet, digital transformation outreaches 80% of the population, sharing economy 2.0, peer-to-peer or P2P economy maturity, 2026 smart city fully operational, and in 2027, 10% of the world GDP will be on blockchain technology. So this is through some of the uh, articles from Gartner, maybe. Yeah, so this data is taken from there. Okay. So we will see now how the current system work and ultimately what uh, we can do about changing it using blockchain. Do we really need to change, or why do we need blockchain in the current system? So before going into the details of blockchain, let's see how our current system works. So how does trading happening in the current using the current system? So a trade is recorded in the bookkeeping and offline ledger where the transactions details are stored. Bookkeeping is isolated and closed to public. For this reason, we use trusted third parties or middlemen to facilitate and approve our transactions. So problems with our current system is the banks and the third parties take fee for transferring money. Mediating cost increases transaction cost. Minimum practical transaction size is limited, cutting off the possibility for small casual transactions. Financial exchanges are slow checking and low cost wire services take days to complete. System is opaque and lacks transparency and fairness. Also, the central authority in control can overuse the power and create money as per their own will. So, in today's current today's system, we have banks who we can consider as a third party or intermediaries who settle, not settle, who help us to do our transactions, be it mainly financial transactions. So in that process, they have a fee to cut when they are doing helping us to do the transactions. Mainly, if you can see, if you do IMPS transactions, they have a fee to do that. They cut a fee to do your IMPS transactions, or so this mediating cost increases the transaction cost. Then the system here is opaque, so there is no transparency of what you cannot trace your money which has been put in the saving account, maybe. So it is shown is in the saving account, but maybe the bank is what they are actually doing. We do not know. You cannot trace your every penny. This banks are also the central authority, or the RBI can be the central authority, which ultimately holds the power to print the money and do whatever as per their own will. So this is what we think as some of the problems in the current system, and that could be changed using the blockchain technology. So here what we propose is of having a system wherein we eliminate this central authority or third party or intermediary, making transaction cost nil or negligible. It enhances the transaction execution speed and can facilitate instant reconciliation. So this distributed system will increase the transaction speed and also the faster transaction finality or the reconciliation that your transaction has happened. So this process will be much faster, can be much faster. Is transparent, so this will be more transparent and tamper resistance in order to avoid manipulation or misuse. So more transparency will come as it will be stored in a public distributed ledger which is shared with everyone. Ensures that currency creation is not in control of any central authority. So this will also ensure that we are not printing anything, or so the currency creation is not in control of just one authority or just one person. It could be done with the consensus of the people who are part of the network. And it is regulated to maintain the value of currency. So we require a system which is as regulated as the current system is to maintain the value of currency. So we need to eliminate the middleman. So using our solution, which will enhance the transaction execution speed and a faster reconciliation. It is more transparent and system which is tamper resistant, which will not allow any one person to have authority to create currency, and it has to be regulated to maintain the value of the currency. Okay, so this is what is proposed solution, and what we call this solution is a distributed system. So the distributed system enables a network of computers to maintain a collective bookkeeping via the internet. This is open and is not in control of any one party, and it is available in one ledger which is fully distributed across the network. So in this distributed system is nothing but a network of computers which will maintain a books or maintain the ledger, and they are connected via internet. This is open and is not controlled by any one party. So this is open. Anybody in this world can join this distributed system anytime, and there is nobody who is asking for permission, or there is no one to control the admission of any person in this network. And it is available in one ledger which is fully distributed. So there is just one book. So book is there, but it is distributed among all the people who are part of the network or this distributed system. So this brings the sharing of ledger, brings the transparency. The there is because there are multiple people and they equally have opportunity to maintain the network. So there is no central authority. There is no control over this network by any one party, and this having such system will make our transactions faster. Yeah, so what will happen is now you will see some words and some concept or some things that I say which we have not come across in these slides, but eventually everything will be clear as we will uh, what pick up each concept and deep dive into it, and then ultimately we connect everything, then it will be like clear. Now of course I say there are so many terminologies here where the concept of what is happening and what is uh, actually is there, that is important. Yeah. Second point, this one, this is open and is not in the control of any one party. This point, okay. So this network or this distributed system that I'm talking about is open, meaning it is anybody can join this system or be a part of this network. So if I talk about Bitcoin, okay, so how do we become a part of Bitcoin network? So what do we do is a separate part, but how do we become part of the Bitcoin network? It's just that you download one software, and there has to be certain things, and you become part of that network. So anybody can download the software. You don't require any permission or any, only I think some hardware configuration. That is the need. So you can buy that or you can upgrade your laptop. You can do that. So anybody can become part of the Bitcoin network, or for that matter, any public blockchain network. Any person can be a part of that network. So being part, what you do, what is benefit, that is a different thing. Okay, that I'm not talking here. But you can be, or I can be right now, can be a part of Bitcoin network. Whatever we are doing, but we can be part of it. So that is why they are called open or public. And it is not in the control of any one party, means there is no there is no one person sitting allowing us to enter the network. No, there is no control of any one person to do that. So it's your choice if you want to join the network or not. So anybody can join without, and as in there is no control of any one person or any central authority. Yeah, to be the software, it is open source. Yeah, it is open source. So you can be part of that community. And yeah, so basically that. But I was talking in terms of proper network, as this second line suggests, or this topic suggests, that being part of the system. Okay, so right now, currently, at this point of time, I cannot be a part of any bank. I have to actually study about banking and answer a few exams maybe, and then join a bank to see the particular bank's transactions or whatever the job, whatever I'm doing. But here, anybody can join into this system and see all the transactions that are being done in this Bitcoin network or any public network. That is the point. Blockchain depends on any company's project. What can you elaborate it? Could you please elaborate more on this? Blockchain depends on any company's project meaning? You mean blockchain network are created by any company? Is that what you mean? Okay. But what is the dependency you are talking about? I got the IT projects in the company, okay. But what dependency of blockchain you are talking about? So it so okay. So does that mean the which blockchain to use, that depends on the projects in the company, or whatever blockchain we want to use has relation or depends on the company, that project being worked on by the company? Is database important in your software application or web based application, whatever projects you are doing? Is database important? You need databases. Has anybody worked on database? There is database for the projects, right? So blockchain is nothing but a database where you store your data in certain manner, and it is more secure than your current databases. So the think about the concept that we spoke. So they are transactions being stored. So storing of your information, that is, you directly equate it to your databases. So at one point we will discuss what are the traditional databases and why blockchain. So this we will talk in further sessions. But so blockchain is necessary or can be used. So that depends on the company and the blockchain uh, skill. The skill, if company there are resources for it. It depends on that. But as I said in one of the slides previously, 85% of the global companies will adopt blockchain technology in their projects. So one second, give me a moment. So this registration is not really required in the what I'm talking about. Yes, registration when the companies do project. So there is this main differentiation of public blockchain and private blockchain. So they work in a separate manner. In public blockchain, you don't need registration and anything. You just need to download some software and then you can be part of it. That is it. There is no registration process. Okay, but yes, in other permission blockchain or private blockchain, there is proper whatever you are saying, the system access to register and all, a registration for system access that works there in private blockchain networks. So blockchain consultant, what it does, so to understand, firstly, of course, the blockchain fundamentals has to be clear. Then whatever the framework that you choose, you have to be clearer on those, how that that framework functions and whatever the features that are there in that framework. Okay, so fundamentals are of course there, but the features of that particular framework, or maybe all the popular frameworks like Ethereum, Hyperledger, R3 Corda, or if we talk about the public blockchains like Solana, Polygon, uh, Optimism. So, and the concepts that are there like zero knowledge proof, the consensus mechanisms. So that is like a big, uh, very vast space. So right now it is not just about right now the current condition as per my research and experience, uh, that 2 3 years back only few things if you understand about blockchain, then it will be like okay for that, but now you need to understand more. So this training session will cover the uh, the main things on which the other things are based on. So Ethereum is a public blockchain where the Polygon and other frameworks are based on. So if you get this idea, then features are keep on adding or keep on removing. That will happen day to day. So that you will have to be updated about it. But the fundamentals of all the things that will be covered in this session for sure. Blockchain is like a database which stores cryptocurrency transactions. That is correct. And but the important is for now it is we are on a part that Bitcoin and something cryptocurrency related. It stores cryptocurrency transactions, but it stores something that has value or information of certain assets as well. But that is not important. Important is how it is storing. That is important. The security that blockchain brings, that is important, and why it is better than traditional database and why we use it. That is important. So yeah, so that is what we will cover.
So also, since blockchain doesn't have any kind of central authority, this is actually a current problem with the system, that there is a central authority in control, and it can overuse its power to its own benefit. And we have seen many examples in this world that, okay, some kind of scam happened because of one kind of vice president didn't want the transaction to flow. Like that is a level of things that can, uh, make the system work in their own good. And so blockchain doesn't actually has this problems in being it on a distributed network itself. So we'll also be seeing solutions to it, like what kind of system we need. We need a system which would actually eliminate the middlemen or the third parties, thereby making the transaction cost nil or negligible. So technologies like blockchain can be one of the most important thing here. It will enhance the transaction execution speed and can facilitate instant reconciliation. So transaction speed is actually one of the most important things that you, like, say suppose if you want one thing to be sent to the other person, so it should be done in like a nanoseconds or seconds. Then only it will be a, a good form of transaction being done amongst the network. Otherwise it will take, like, say suppose I wanted to buy a TV, so I'm in the net, I've gone through this store itself, but if I try to buy that good, and if it takes, like, say suppose 5 days or maybe like 30 minutes to transfer the amount to that particular vendor, then it will actually be a big problem for me. I have to wait for, like, waste their 30 minutes. And if I'll have some kind of solution for it, if that can be done in seconds, so that will be a great thing. So that is what blockchain will be doing. It will decrease the transaction speed, execution speed, and can facilitate instant reconciliation, is what we are trying to say here. It is transparent and tamper resistant in order to avoid manipulation of misuse. We have already seen that the transactions are actually visible for any address, any one who has done the transaction, but it is also anonymous at the same time because it is not linked to a particular person. So anyone could generate an address and just start to do the transaction. You don't need any kind of KYC or any kind of AMLs that will be in between to uh, in between to make an obstacle for you. You can just do it with just an address by creating one in just like few seconds. So it ensures that the currency creation is not in the control of any central authority. That is also a point. Actually, being a distributed system, every node is connected to a software, and everyone who's connected with nodes is connected with other different nodes as well. So any peer on the network is actually connected to them. So it tr- uh, circulates the information in the form of gossip. And so it's like one node that I'm connected to is actually telling the other node, and the other node is telling to other node, and in the same way it is getting all the information gets circulated in the form of distribution itself. So there's no central authority who will be just bringing it to a notice that okay, this particular thing has happened or not. So that is one of the main thing for the solution of it that we require. So the other point is it is regulated to maintain the value of the currency itself. So yeah, that is also a solution for the problem that we are facing with the current system itself. So a distributed system to solve the problem. The distributed system enables a network of computers to maintain collective bookkeeping in the via the internet. So as we have seen here itself, so the bookkeeping is actually done on top of the blockchain explorer itself. So everything that you want to see can be seen or can be viewed with the help of this blockchain.com explorer. You see, this is the explorer itself. Any kind of transaction you want to see, you can just search it here. Any kind of address you want to see, you can just search it here, and you'll be able to find its current uh, transactions, what has happened on it, and what is done. So if you can see here, transaction, it's not adding some mind as of now. That might be a reason for it, but you get the idea of seeing the transactions into it. Yeah, these are different other aspects of it, how many confirmations are done, and everything is actually can be seen on this particular uh, system itself. So what is a distributed system? Distribute a system where two or more nodes work together in a coordinated fashion to achieve a common outcome. So that is what a distributed system is, connecting to each other with no particular thing. So like this peer is actually connected to immediately to this and this peer, but this peer is connected to this peer and this peer. So information is circulated in such a way itself, and everything is actually modeled that the end users will see it in a single logical platform itself, which is one software for all. So what is a node? Node is anything, maybe a computer or a thing that is connected with the software to that particular network itself. A node can be defined as an individual processing unit in a distributed system. Yeah, as you can see, every computer, this is a node, this is a node, this is a node. Everything here is a node itself. All nodes are capable of sending and receiving messages to and from each other. So yeah, so as soon as you have connected to the network, there is no restrictions for you that you cannot send a message or maybe a transaction. As soon as you're connected to it, you can do whatever you want to do on the network itself in case of sending and receiving. As we just learned earlier, that what is a node? A node is anything, any computer who is connected to the software is actually termed as a node. There are different types of node as well. One is a node that is just there to do the sending and receiving and the transaction. One node is there to mine the network and audit it and make it as a mine the transaction, make it as a validating thing, that everything it will validates whatever transaction happens on the network, and in return for it they get tokens in return, which just we learned as it is called the gas fee itself. So whatever if you provide some kind of services like validating and auditing, then you'll be getting something in return, and that is what miner does in the network itself. And we'll see like what distributed technology, what are different distributed technologies in the this landscape itself, and what they are doing. So there are different in blockchains, like Hyperledger is one through which you can create your own blockchain and system organization on top of blockchain itself. We have R3 Coda, we have PTDL, who is also doing this particular swap reporting and record keeping on top of to help you create the blockchain itself. So what is Hyperledger? Hyperledger is actually a tool, and we have different technologies under it, or tools under it, called Fabric, Sawtooth, and in Indie and Aries, to help you create a blockchain or a network wherein you can just do some kind of transaction in a closed group itself. So it is kind of a private blockchain, and it is not available to any person who wants to view it. Only you can view it if you have a particular invite or certification or certificates to log into this network and do the transaction itself. So that is what Hyperledger is, helping you to create private blockchains. And why is it used? We use basically for finance and commercial payments, or maybe healthcare industries, where in we have the sensitive information and we don't want anyone to just come and view it. So we use these kind of solutions to have we use these kinds of solutions so that people could maintain or maintain privacy, as also in the same time it stores the uh, uh, feature of immutability and security itself. So yeah, that is one part of it, of creating a solution on top of Hyperledger. We have R3 code as also, which is also more or less similar, but it is specifically for finance solutions. And you can create different types of cryptocurrencies and accounting and assurance on top of it. We have the PTDL group itself, so which is also helps us to create these smart contracts and do the straight uh, trade settlements on top of it, and records keeping on top of it. So these type of solutions differ like very minutely, and is only different in the form of their functioning, like what all consensus mechanisms they use, what all what all flow they have, how they store the transaction is what the difference is. Otherwise, more or less, these are the same things that can be used for creating a solution for your uh, network itself. So as you can see, this is a consensus algorithm that they use. There is one called leader based, one is called proprietary distributed ledger consensus infiltrated. One there also is a PBFT or raft, which is like a Bison fault tolerance, and raft is like the same thing as what is we have in the database itself. The R3 has these node to node as a consensus algorithm, proof of work, proof of stake, and different proof of authority as well. So these can be plug in, these blockchains can be plug and play and can be used with different consensus algorithm as you wish and as you require for deriving your own solutions. For the PTDL group, you have the delegated proof of stake and round robin and PBFT. So these all things are actually the consensus algorithm which help us to come to a mutual agreement that particular transaction has happened open the network, and these transaction is getting validated with the help of these consensus algorithms.
Let's have a quick question, guys. And the question is, what makes a blockchain different from a traditional database? Option A, it uses a decentralized network instead of a central server. Option B, it is immutable, meaning records cannot be altered once added. Option C, it relies on cryptography for secure data verification and storage. Or option D, all of the above.
Just a quick info, guys. Intellipaat offers you a blockchain certification course which will help you become an expert in distributed ledger technology, Ethereum, Solidity program, and many more. Through this course, you will also receive additional courses co-created with IBM, namely IBM Blockchain Foundational Developer, and deploy a web-based blockchain insurance application. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description. Without a doubt, this course can set your careers to a new height. So visit the course page link given in the description below and take the first step towards career growth with the blockchain tech stack.
Itself, which is used by the miners then again to validate it on top of this network itself. So what all platform and technology and providers are using these? So you can see Nasdaq, Settle, and Intel Sawtooth is one of the users or providers who will be providing solutions for it. Ripple is again another form of organization who helps you to build around a blockchain around your solution itself. And these can be like CBDCs, which is again a banking solutions or fintech solutions for your traditional problems. We have our three quotas for the private consortiums, and the Senetal is one, and Coda is one for just R3CEV itself. MultiChain and Hyperledger Fabric is also one kind of a tool to create your own solutions on top of blockchain itself. And this PTDL group will again then be having this Ethereum, Bitcoin, and Coin Prism as a top, which is like a open blockchain, public blockchain, which is viewed to everyone, and everyone could see what is happening into it. So these are the actually the providers and the basic technology providers who help you to build around blockchain with their predefined solutions on they have. So this can be built on the blockchains are usually built on top of these cloud platforms called Azure, Google Clouds, AWS, and to have a network to create your own network, and which will be acting as a nodes and connecting and providing their contribution to the network itself. Or you can have your own in-house system or your laptops or data centers if you want to connect to your infrastructure with these blockchain itself. These are also there are different kinds of services in this era, like Amazon Web Services providing their own blockchain solutions. Google is also into it. IBM Bluemix is one which provides like Hyperledger solutions for Fabric and Composer itself. And this Microsoft Azure is also having one certain kind of solutions for itself. Okay, so moving ahead, transaction in a distributed network. So how transactions happen in a distributed network is what we are going to see. Till now, you have, I hope you have understood what distributed system is. And if you have any doubts, please do let me know so that I can clarify it. So how does a transaction happens in a network? If happens in a network in a distributed network. So we have a scenario wherein we can say that, let's say James wants to transfer money to his friend Kevin. So here is James who wants to transfer the money to Kevin. So how will it happen? Since there is no central authority in the system, there can be certain questions that might cross your mind. are like how to verify from where the transaction is going to initiate, who will how it will reach to Kevin itself, how is the transaction faster than the present system, how is currency generated, and who is validating these transactions is actually the general question that comes into a person's mind if it comes to distributed technologies, distributed network. And encountering your curiosity is uh, to satisfy your curiosity first. Let's see how the transaction is initiated in a distributed network. So let's say to initiate a transaction, James uses two pieces of information: private key and public key. So that these are the keys when you create your own wallet itself on top of blockchain network. As soon as you create your own wallet, you will be having these public and private keys with you, and these are like your let's say you have account on a Facebook, and these what is a public key will be representing your email ID, which is or your username, which is accessible to all, and anyone could find you with your address, your username. So this is what it will be denoting to the public key, and your private key is your password. So that is like a thing that you keep it safe with yourself and you don't share it with others. And this is actually used these two actually things are used to help you communicate in the network itself. So if you want to transfer your money, you need these two items itself: the private key and the public key. And here is James saying that he will be paying you $500. And what happens is, as soon as he tries to send an initiate a transaction, he will sign the particular uh, a digital transaction with these private keys, making it encrypt so that no one could hack it. And once it's encrypted, it will be sent to Kevin itself, which he can then decrypt his particular information with his own keys, and receive the amount that has been initiated by James and received by Kevin itself. So this is the concept of public key cryptography, wherein that plays a major role in actually the blockchain itself. Wherein what happens in public key cryptography is like some kind of text you want to send is like in human readable. It will convert it with its keys into encryption format, which is non-readable and can be only decrypted with the keys itself, and will be particular things we use to transfer the particular assets safely from one person to another person over the distributed network itself. So what approaches it involves is like two different keys. One key is purposely kept private, as I told you earlier. Also, private keys are like passwords, which is not to be shared by to anyone. Otherwise, it will be hacked. And mostly, the hacks that have happened in the blockchain technology was not because the technology has some flaws, but people tend to share their private keys or might keep it somewhere where the hackers have access to that particular key, and they open it and swipe all the funds inside their wallet itself. So that is actually the private key's purpose, to actually keep it safe so that no one can hack it, because the technology doesn't have the flaw. The flaw is actually with the humans, how they save it. But if we practice the safe things, so we might be able to eradicate all these problems of hacking, and we can enjoy the benefits of distributed network itself. And the other is actually the public key, as we have earlier also discussed, which is the username itself. And anyone could see this and if they want to communicate with you, they can use communicate like find you with this public key and communicate with your particular node or wallet, whatever it is. If you use private key to encrypt, then public key can decrypt it. So like if say suppose James wanted to send the money to it, so money is nothing but a digital form of message, which is actually get encrypted with the help of these private keys. And once it has been sent, this particular key of this particular key, public key, James public key, will be used to decrypt. No, sorry, Kevin's public key will be used to decrypt that particular information, and it will get the whatever the digital message has been sent by James itself. So yeah, that is how the public key cryptography will work, and this is how the whole process will work. And the whole what this whole process is called, actually the asymmetric encryption that is happening over the network itself. So how do you store your keys? So this is actually a very critical question. Where are the keys stored when James transferred the money to his friends in Kevin's? So these keys are stored in James' wallet itself. So it won't be seen by Kevin, but it will be stored within the James wallet, who has created on with the help of the software of the network on the blockchain itself. So, and these keys are also, as I mentioned earlier, these keys have to be stored somewhere secure, wherein no one could access but you guys itself. So that is one thing that you need to make sure, that the keys are safe within your reach and no one else could access it. Bitcoin address and wallet. So this is what a Bitcoin address would look like. It will also create a QR on it. You can just scan it, and this will be representing this particular address itself. And this is what an identifier. What Bitcoin addresses are the identifier of 26 to 35 alphanumeric characters. It won't be making a sense, but it will be alphanumeric random generated characters, which will be in the length of 26 to 35, and the beginning of it will be 1 or 3 itself. It won't be different. So like if it is 1, it is a valid Bitcoin address. If it is a 3, it is starting with the 3, then it will be a valid Bitcoin address. And this Bitcoin address can be of two types also, like Bitcoin mainnet and Bitcoin testnet. So what we are seeing is 1031 is of actually the mainnet itself, which is the one having the value of the particular Bitcoin itself. And when we talk about testnet, it will start with either M or N, and that particular Bitcoin network doesn't have any value. So if you have to be cautious, also that if you are in future trying to do this cryptocurrency exchanges or maybe trading, people tend to have fraud other people by telling them that this particular transaction has been sent to you on testnet and then will be later on uh, converting into mainnet itself. So that is actually a scam. Please don't fall for it, and make sure that you whatever the transactions you are trying to do, that is on mainnet itself, which actually has the value of particular bitcoins that will be given to you. Otherwise it will be null and validated, and you will be a part of not a you will be uh, fall for this scam itself. So please do make sure that it is actually a transaction which is on mainnet itself, and the address starts from either 1 or 3. It represents a possible destination of Bitcoin payment. Yeah, that is what is being used for sending out the payment. So it's just like if you have these UPI IDs. So let's say suppose on the Paytm part, you can see that the Paytm part has your phone number to it, and in the suffix part it says @Paytm. That is what exactly it is. It is the ID to it, and the password will be like a random generated keys only, alphanumeric characters, but that is not to be stored or to be shown to everyone for the address part itself. So a wallet, as you learned previously also, is basically the Bitcoin equivalent to bank account. It's similar to what you have like a account, and through that account you can send or receive the transaction. It will allow you to receive the Bitcoin, store them, and send them to others. We have learned this previously as well. Once a Bitcoin wallet is installed on your computer or mobile device, it will generate your first Bitcoin addresses. So you can generate through the different softwares like Jack's paper wallet, maybe, or maybe through hardware wallets, which is like a pen drive, or maybe something that is not connected to the internet. Anywhere you can create your address, and you can start to send and receive the transactions. Each address has its own balance of Bitcoin. So yes, so every it won't be pre-configured or like given to you. Like you can create an address with zero amount, and you can then start to buy them from either these exchanges or anyone you could know. You can just pay out to them and buy those bitcoins for yourself, and you can how once you have bought it, they'll just transfer the particular equivalent amount of bitcoin to your wallet itself. However, the addresses can be changed whenever you want to. So you can create like n number of addresses through in your wallet itself, because we have those cryptographic algorithms which will actually be pointing towards your particular address itself. If you even create a new address to it, or maybe another form to it. So that is like a very technical part of it. We'll be learning further ahead, and yeah. We'll now be seeing what kind of types of wallet do we have. Bitcoin wallets and functions. So we have these software wallets called Bitcoin Armory. Is actually the most popular, stable, and secure software wallet. So we most of the people in the industry use these kind of wallet to uh, do some kind of trade for bitcoins, and actually it is secure. But the most secure part is actually the cold wallets, which are simply any kind of wallet that is not connected to the internet. So you might think, if it is not connected to the internet, then how it is getting transferred? So these we have some kind of softwares for it, actually, which will be connecting it to your particular machine, and then these machine will be able to be connected to that particular cold wallet. So these are the most secure form of wallets where you should store your bitcoins if you have them, or if you think that you need to purchase them for this in your future network. We have the other web wallets as well, which is like not secure as much, but these are some kind of wallets, and a level of convenience that the software wallets cannot, such as being able to access your frauds from any devices. So wallets like MetaMask is actually earlier. These are the wallets which are accessible on the web, and you can just it is a lot more convenient to have these wallets, as it is uh, on the go available on your devices itself. What is brain wallets? Brain wallets is like a computer makes up a passphrase of random words that the user commits to memory. So it's like, not sure what kind of wallet these are. This is a wallet, but these wallets are basically yeah, I won't recommend this. So brain wallets is like you memorize your wallets, password, keys, your passwords, and everything on your brain itself, and it won't be a good thing. But I would recommend not to use it. So it is some kind of wallet to store your bitcoins. But yeah. So what is hardware wallet? Hardware wallets are those that cannot be accessed by physical contact to the wallet. They have hit the scene this year. So hardware wallets is like your wallet, just that I showed you this. Ledger is like your hardware wallet that is applicable to people, and you can store it offline without the use of internet itself. So these are the hardware wallets, and this is the software wallet. So yeah, these are the types of wallets we have. Paper wallets is what we have here. Accessible to all this, like my Ether wallet is paper wallet. So this is the biggest example of what paper wallet is, and you can do your transactions on top of it. But this tend to be also have been had earlier, but this can be used for making a very small transactions to your network itself. So you can also go and check these. USB drive is more or less the same thing. The pen drives that you have, you can store that particular data on the pen drive. But if it gets corrupt, I think you won't be able to recover it, or if you can, then it will be good. But it is also a form where you can store your wallet, your particular tokens on the USB drive itself. This is actually a life cycle of a transaction on the distributed network itself. So life cycle of a transaction is a transaction you can request it through your software wallets or maybe your hardware wallets or exchanges, and these exchanges will actually initiate a transaction for you or the particular person you want to send to. A block that represents a transaction will then be sent to the network or distributed network, and that particular transaction will then be stored in a block itself. What is block is actually the uh, uh, collection of transaction data into it, which is then being stored on the network. And what will block consist of? The transaction is one, the previous hash to the other block is one, the timestamp is actually one of the components in the block that will be required. And yeah, so these are the things that will be there inside a block, which is then mined by a miner to store your transactions on to validate and audit that this particular transaction has been sent over the network, and there is no amount of money either deducted properly from A person's account and being credited to B person's account. This is actually what is the job of miner and the transaction that will be happening on the network. Once the block is sent to every node in the network, yeah, so then as soon as this particular thing has been updated, miner has mined the network, this particular information will be then circulated inside the network itself using different protocols, maybe gossip protocols or maybe other protocols to inform everyone that okay, this particular transaction ledger has been updated, and that particular ledger copy will be distributed amongst each and every node who is connected. So if I am in, say, suppose Kerala right now, and I'll be having one ledger that has been updated by let's say 5 rupees was transferred from me to Prabhu. So that particular transaction is actually being stored on the block, and the block is verified, and that particular information will be stored on the ledger itself, and that particular information will be shared with someone who's actually sitting in Seattle, that okay, this ledger has been updated, so everyone will be on updated and on the same page of the ledger uh, itself. So yeah, that's how the transaction will go, and it will actually get validated on the network. The nodes will receive a reward for the proof of work. This is what mining is. They'll use different types of machines who will actually solve the cryptographic algorithms to make sure that particular transaction is valid on the network and then will be stored. The block is added to the existing blockchain, the same thing that we just saw right now, and then the transaction is completed to whomsoever he has transferred. Transaction is broadcasted in the form of digital message, so it is nothing but a message that has been shared from one person to another, a transaction. Just like a signature provides the proof of ownership on the document, the digital signature provides the proof that the transaction is genuine. So every time you send a transaction, you sign a transaction with the help of your private key. So that private key is actually a digital signature that mentions that, okay, so Trijay has sent your Trijay has made this transaction, and this transaction is genuine because this has been verified with his private key and has been sent out from his wallet itself. Unlike a handwritten password, the digital signature is unique for every transaction. So it will not be same for every person. It will be different for each and every transaction that you initiate on the network itself. Transaction propagation. After a transaction is created, it propagates in a distributed network. How is the transaction faster than the present system is generally a question that comes into everyone's mind as soon as we discuss about the transaction part. So in a distributed architecture, a transaction is transmitted from peer to peer. The transmission of the transaction across the network takes around 1 to 2 seconds. Not it can take more than that for different blockchains, but usually the time is around 1 2 seconds to you know send out the transaction in the form of gossip or maybe some kind of ripple network through which the transaction is being processed to every node on the blockchain itself. So say suppose like we see a transaction propagation in a distributed network. Say suppose we have a scenario over here wherein a node A a node in the network finds the transaction. Kevin pay 5 coins to James. So they found that Kevin has paid 5 coins to James. So what will happen is node A will broadcast the transaction by signing it with his private key, and once it has been broadcasted to the peers B and C, which is the immediate person in the network, node A, B, and C check for the basic formats of the transaction and forward the transaction to the peers. So they will then again forward to them this person, this node, and similarly the B person will send to this person and this person. Like this, the transaction propagates rapidly across the network. So it's just like a gossip. So he tells it to this person, he tells it to this person, he tells it to this person, this will tell it to this person, and this person will test to this person. So that is how the communication is made amongst each and everyone. And say suppose some people also ask, what if the transaction has been communicated twice? So like he is connected to so this person is connected to B also, and this node is also connected to C also. So this information sent to him will also be communicated to him and him. So it will actually be verified that this particular uh, transaction is genuine, because same thing should happen. Same information should be transmitted from every node to in the network to other nodes. So that is also kind of an authentication that this transaction is genuine, and everyone will also be trusting to it, coming out to a consensus, which is a general agreement that okay, that Kevin has actually paid 5 coins to James, because we hear same things from each and every node. So that is how level of security is also maintained and trustability is also maintained inside a distributed network. So since we communicate in such a way, so it makes it faster and cost efficient, as there is no middleman. You see that no particular person is responsible or will be charging some kind of fee to send out this information. You are only you the only form of communication you are reliable on is actually with the immediate peers you are connected with. So that is how transaction propagation in a distributed network happens, and that is how everyone gets updated with the latest information that is happening over the network itself. So the validation part, who validates the transaction as there is no central authority, is actually a good question, because we have to trust some kind of uh, source to make sure that the transaction is actually genuine and has been done by is actually genuine and no one has tempered it to their own benefit. So there comes the people called miners. There are some special nodes in the network that verify the transaction and maintain the ledger. They are called miners, as I have also previously mentioned. There are some people who will validate all your transactions and audit it. Basically, it will be basically like miners are basically like auditors on the network itself. So let's see what is written here. Miners are special nodes that hold the copy of the ledger and verify the transactions happening in the network. They make sure that nothing is fraud and trying to uh, no one is trying to manipulate it. They use the this state of the art cryptographic algorithms, wherein they validate the transaction across the network itself. So they use like this proof of work, proof of stake is some kind of uh, consensus algorithms that is being used by the miners to make sure that the transactions are genuine, and they run this heavy systems called ant miners, or maybe other software. There's graphic cards with heavy part of it which will stall the computation algorithms to actually find out if the transaction is real or not. And if they find, as soon as someone finds it, they will be getting rewarded for that particular person for with a particular token. So a question that here arises is like, what if two-person tries to solve the same same this try to validate the same transaction, but how that will be distributed, the price will be distributed. So there's nothing else. At the same time, they will be checking out who has done the work for mining it, and who is actually correct with the correct with the solution, and it is actually measured in nanoseconds to eradicate these problems. And only one person will be allotted with the uh, the price, and the other one will not be getting this on the network itself. For a digital monetary system to work, miners must be able to confirm that. Yeah, so miners basically work for these uh, tokens that will they were getting in reward, and they this is how they will earn, because they are investing heavily in these softwares, not software but hardwares, like ant miners, or these graphic cards that will be able to run your system faster and to solve these particular things in jiffy. Yeah, so that is what is the role of miners, to just to validate the transaction. And as soon as they validated it, the network automatically becomes audited, and every information is you see on the network is actually audited and will be providing the correct information in like few seconds. That is what the gas is required for, to give out the incentives to the miners who are working with the machines to solve the uh, problem of auditing. So this is what the role of miners are. Okay, so verification. Now the question comes of how to verify from where the transaction is initiated and whom it is sent. So there are certain forms of verification to it on the network itself. If you see in this diagram, James wallet is actually, we have seen that it is transferring the money and it is sending out a digital message which is then encrypted with its keys. That is the private key, which is then make sure that it is sent on the network itself by encrypting with the different cryptographic algorithms like EDDS and ECS. This SHA-3, SHA-256 are also one of the algorithms that are make sure that it is impossible to break the what kind of message has been said by James, and it will be actually being sent to the network, and that particular information is shared as is. It won't be uh, encrypted by the network, but encrypted at the end of James itself. So James will be the one who will be getting the encrypted messages itself, digitally signed signature, and with the help of James' public key, this particular person, he'll be able to know that okay, this particular person has encrypted it, and public key will be required to open that particular message and will be sent. Will be getting using this decrypted keys, you will be able to understand that particular James has sent 5 BTC to initiate the transaction, and transaction message is actually authenticated using these James public key itself, right? So as soon as you encrypt it, it will be only be decrypted using that particular person's James keys itself, which will be then sent in the digital message itself, and it will be unlocking all the information for that particular person. Generate your Bitcoin addresses again and again, and you'll get to know what exactly this is. So this is, you can see, this is a donations address, which is actually a Bitcoin mainnet address. If you like the particular website, so you can just provide some kind of donations to him if required. Yeah. So we saw the Bitcoin wallet. We saw what is wallet, what different types of wallet we have. Sorry. So different types of wallet we saw, and we saw how the transactions are happening over the Bitcoin network itself, which will basically mimic what is happening on blockchain, most of the blockchains. But different blockchain might have some different architectures or the flows that might have that how the transaction is happening over that particular blockchain. So this might vary little bit, but mostly most of the concept is similar to what how Bitcoin is sending out the transactions. So we saw the transaction propagation, how what happens after the transaction it is created, and we saw like how much time does it take to get it to the complete system or a node, and this is exactly what we saw, how the transaction is floating around the distributed network using the gossip protocols. How the transactions are getting validated is also there, and who is actually authenticating it, and these are some nodes which are called as miners. And who are miners? Miners are some kind of nodes that are eventually like that are also called as validators, and how they are validating we'll see further ahead in the course itself. And this is just an idea of what miners are doing and how they and why do the miners mine the transaction in the network itself. We have also seen the how it is getting verified, where the transaction is initiated and who and to whom it is sent. It everything is gets verified on the blockchain network itself. And now we'll be starting with the storage part. So as you know, that blockchain is nothing but a group, like everything is just a chain of blocks, and inside the blocks we have different types of transactions, and everything on the blockchain is communicated through the transactions itself. So the data that is getting transferred to each and every one is shared through the transaction itself. So the storage is nothing but the transactions that are getting stored inside the block. So that is what is the storage. And where it is, so where the transactions are stored, the transactions are stored with each and every one's node's computer. Like say suppose I'm getting a copy of the ledger, so that particular ledger will have some kind of uh, what do you say a data attached to it, data memory attached to it, through which it is stored on your local computer itself. So a lot of memory is allocated to that particular chain, which eventually grows and grows and grows, and that is how the blockchain is actually storing the network with each and every individual who is connected to that particular chain. That means the storage is taken from a node who is uh, actually connected to the blockchain. So what does it say? Once the transaction is verified, it is stored in a shared ledger across the network itself. So the transaction gets verified by the miners, as we earlier saw, and then once it gets mined, that particular updated ledger is actually given to the nodes that are connected to the blockchain itself. So this is an example of a distributed ledger. Like say suppose this James is a miner, he updates it to the Kevin, and Kevin gives out the same thing to Paul and Robert. This is how it is getting uh, uh, you know uh, sent out to the network. So what is the order of the transaction? So the order of the transaction, since the transactions are passed from node to node, there is no actually guarantee that the order in which you receive them represents the order in which they are created. So like if you see in the previously in so there this actually represents on your latency of the network itself. So say suppose C's network is really fast, maybe it's having like 300 mbps or 400 mbps of uh, speed of the internet. So it will try to fetch all the data quite possibly faster than what B has. So say suppose B is working on 50 mbps of data. So there it all depends upon the latency, and it will not actually be sent out on immediate basis itself. So it all depends upon the latency, and it will be different from each and every user's node who are connected to the system. So that this is why we don't receive everything in sync, but we there's no guarantee if we'll receive everything in sync, but in a chronological manner, that is as and when it is happening. To agree about the order of the transaction is a challenge in a decentralized system, because we don't know if everything is there in the manner we have received. So this is a big challenge in the decentralized system, but we have different solutions for it as well, which we'll see further ahead. Therefore, the cryptocurrency system orders the transaction by placing them in groups called blocks and then linking them in a chain itself, which is the overall prospect of blockchain. So this is an overview of how miners are grouping the transactions inside a block. So miners group the transaction into block by running a different by solving these cryptographic algorithms, and this is like a mempool where the all the transactions are stored. Every time a transaction is happened, it directly goes into the memory pool of the blockchain, and from there the miners come and pick up the transaction and try to validate it and make sure the transaction is authenticated. As soon as they try to solve the cryptographic puzzle and find out the solution to it, then becomes then the transaction becomes validated, and other miners also verify it and send it to the and make a block out of it and send it to the updated copy of the ledger to the network. So that is what is happening inside the behind the scenes for the miner itself. So this is miners in the network are working on the existing blockchain itself, and every time they try to solve the puzzle, they'll create a new block and then propose it to the chain itself. So you can see this is a block proposed by Paul, and this is a block proposed by Lisa. And various miners are trying to construct the blocks on top of the existing blockchain itself. There could be several options to choose from, but the question is, how does the network decide which block should be next in the chain? So what if someone is actually proposing the block with different transactions, and whom to trust if that particular block has all the validated transaction itself, is what we are going to look further ahead. So whose block to consider? There can be number of miners constructing a block. Whose block will be chosen by the network is the real questions over here. So proof of work is the algorithm which determines that what are the like the number of work that has been done by the miner, which will actually be given as a proof that this particular miner has worked and solved the cryptographic puzzle to make sure that the transactions that are there are validated and it's correct. So what is proof of work? Proof of work is a piece of data which is difficult, like a costly and time consuming. I think some of you had asked the question earlier also that proof of work is actually cost and time consuming. Yes, it is costly and time consuming because you waste a lot of resources onto it to solve that particular cryptographic algorithm. And to produce, what does it say next? It says to produce but easy for others to verify and satisfy the certain requirements. To keep the coin distribution predictable, puzzles become increasingly difficult to solve as more and more people work on them. So what happens in proof of work is, as soon as you solve one cryptographic algorithm, the hash of it actually becomes difficult and difficult every time you try to mine the transaction. So as of now, mining Bitcoin hash rate. So this is according to which the total hash rate, which is actually considered as something through which the miners try to solve the problem, and they have to go like to guess. They have to guess like these much of hashes, like 32, if I'm not wrong, 26,345 hashes per second to actually try to solve and make sure that the transaction is validated. So as and when they are able to guess the correct hash of it, which will consist of block number, the timestamp, and some other components as well, they'll be considered as the correct person whose chain should be trusted, because this person miner will actually validate the transaction, create a block, and send it out to the other people as well, and these miners will then verify it and will then consider it as a updated ledger that is to be trusted. That is proof of work, and a part of Bitcoin solution is that each block must contain the answer to a special math problem. That is the algorithm's solution, and that is how the blocks keep on getting added to the chain itself. So you can see this is like a block which consists of a previous block hash, which is this, and inside it there will be different transactions, and it will also consider of nonce, which is like a random number, and we'll see in detail further ahead what exactly it is. And they are trying to find like a guess a number, which is actually the answer to like confirm that the transaction is uh, it will determine if the transaction or if the block is verified or not, like it's a legitimate one or not. So in a proof of work, inside a proof of work solution, there are three components which helps to achieve the solution. One is the nonce, which is a random number whose value is set so that the hash of the block will contain a run of leading zeros. So the rest of the fields may not be changed as they will have a defining number in it. So a nonce is like something generated by the blockchain, which is a random number, alphanumeric also, and so this number will be like a set in such a way that so that the hash of the block will contain the run of leading zeros. Since before it will have like a number of zeros and hash of it. What is hash? Hash is like a fixed length of number which results in a large unchanged data when read. So no matter what kind of input you provide, it will provide you with a hash which will has a fixed length to it. So if you say suppose I have given the input as a 64-bit 64-bit, it will provide me a fixed length of number. Even if it is small or big, it doesn't matter. It will provide me that particular length of output as well, which will be termed as hash. And what is this next thing is the transaction, which is the authentic transfers of Bitcoin ownership collected and recorded in the blockchains. Like whosoever has traded or sell or bought whatever it is, it will be termed as a transaction. It will be stored inside this particular solution itself. So this is like a new a graphical representation of it. A block number 845, which is the hash of it, is having the previous block hash, which we saw earlier as well. The number of transactions, there can be ample number of it, and a random number that is a nonce that is getting generated, and a miner has to guess this particular number or get close to this number to get his block verified as the block to be trusted throughout the chain of the network itself. And if he gets this, so he will be able to propose a new block, which is this, and which will contains the same property what has been earlier predefined as well. So it will have the block hash of this particular block, the new block hash again, which will is the fresh block of this particular block, and the transactions and the random number which is again generated by the blockchain itself. And now the miner is competing to guess this number, and this number will if guessed, he will be the person who will be generating or creating a new block in the blockchain itself. So finding the puzzle, why is it hard? So there are certain cryptographic algorithms running behind it. One of them is SHA-256. It is a one-way function, when hence it will cannot be brute force uh, to get the output value. So what is brute force? It's like a providing forcing the trying to calculate the answer for that particular value itself. So brute force can be like guessing the number. It's either 0, 1, 2, 3, 4, 5. So it cannot be done like this, because these SHA 256 make it very difficult and to guess that number, and hence it becomes like a one-way function to it, which is redundant to it was like a hackable proof for guessing the hash of it. So on an average, it takes like random guesses, takes many random guesses to find a solution, and thus the challenge is tough. So it keeps on guessing like if this is a solution or this is a solution. It is actually not possible, because these values are like in the form of 256 to the power of something of 1000 or something like that, to calculate the hash of the particular block. So that is that we saw that the network power of it, the theta hash per second, that is the exact thing which you need to have a power, which is like the power to calculate the block itself. So it's like for a miner, it takes around like 10 minutes to confirm, go through this whole process itself of calculating the nonce, finding out that particular nonce, and then getting it verified with other miners as well, to make it as the solution for the new block to be added to the chain itself. So this is how you get the a new block created after every 10 minutes in the Bitcoin network itself. So what are the security properties of hash functions? So it is collision free, it is able to hide the secret value easily, it is puzzle friendly. So what is collision free? Even if you given an input, it should be difficult to find the different input B such that the hash of A is equal to hash of B. So if you provide an input, it should be not easy for miners to calculate this particular hash itself. So these are the given one, and he needs to find the hash of B, which should be like a collision free thing inside the network to guess that particular nonce itself. Hiding. What does hiding mean? A hash function h is hiding if a secret value r is chosen from a probability distribution that has a high entropy. Then given h r concatenation of x, it is infeasible to find x in this particular formula, from this particular formula itself. So these two pipes means concatenation of two strings, which makes it like difficult, easy to hide the particular problem of that particular solution itself. What is puzzle friendly? Puzzle friendly is, it will be puzzle friendly when for all probable output value B, if M is chosen from the distribution with the high entropy, then it is infeasible to find X such that HM or HM is concatenated with X to find out that particular solution of B, which we just discussed here, in the time significantly less than 2 to the power of n. So there is also a certain time limit to it to find a solution. It's not like you can just keep on going on and on, but you have to find out that particular solution within the provided time to make sure that the block gets easily added to the network itself. Why do miners invest their resources in validation? As we all know that miners actually invest their resources because there is an incentive for successful solving of a block. So running all these different machines, the heavy machineries require a lot of time, resources which actually needs a monetary value to compensate them. So this can be like an earning for the miners on the network to solve this particular block, not guess the solution for that particular block to get it created on the network itself. Minus reward. What do they get this? Minus try to find the key to the complex puzzle as per the algorithm. So that particular key is the nonce itself. They are trying to constantly find out that particular key, and as in when they get it, they'll get the rewards to them. Search for this key is random. Hence, a miner needs to invest huge computational power and electricity. So that is the main thing that is required, computational power and the electricity to solve that cryptographic algorithms. And on the Bitcoin network, we have this machine called Bitmain, which actually is antminer, which actually is used to by the miners to solve that particular uh, cryptographic algorithms. So you see, this has like 151 tera hashes per second of capabilities. It will require 3247 watts, and yeah, there are different variants as well. If you want, you can just buy them and start your own mining farms. You can look into this. You'll see that what is the price of this. Earlier it was like way cheaper, around 2000, but I think these have upgraded models as of now, and it will give you the exact uh, values, how to solve it, and how much would you be able to earn it, which is like a calculator to help you understand what is the hash rate and how much can you earn if you provide the hash rate itself. Where will you find the hash rate? This is like an hash rate for it, and you can just go inside it and read certain all details. You'll be able to get its specifications and everything, and what all it will give you in return. The payment method is for the this particular machine, but it will return if you are trying to become a miner on particular blockchain. It will return you that particular token itself. So say suppose if you're doing it on BTC, so it will return you BTC token. If you're doing on Ethereum, it will give you ETH token as well. So these are the specifications for it. You can go through it and have an understanding of what these machines look like and how powerful they are. And this is a calculator to just understand like what electricity cost do you have. It's on the units number, the units amount, like rupees per unit you have in your uh, in your locality or in your area. The consumption it will take, you'll see, be able to see it. And the maintenance fees, again, you will be able to see it on the network itself to calculate the profit from here. Miners repeatedly guess new keys until the first key is found that matches with the puzzle. So this is the job of the miner, and he's trying to find the solution to that puzzle itself. Miners who finds the key publishes the block to the network. So the first one who will be able to find the solution, find the solutions to that puzzle will actually be the one who will be sharing their ledgers to the network itself. Other miners stop creating their blocks and take the published block, validate it, and add it to the ledger. So this is like the whole process of mining. The first one will create it, and others will validate it, and then it will added it, and the block will get added to the chain itself. So you see, this is the representation. This is a graphical representation of the blocks getting mined over the network itself. the reward. Since miners use their valuable resources to validate the block, they are given monetary rewards. What are the monetary rewards? The Bitcoin tokens. So as we all know, the Bitcoin tokens have certain value to it. Right now, I'm not, but Bitcoin price is around, I think so, in Indian rupees around 21,40,460 is the value in the INR as of now, and it keeps on increasing and decreasing as and if person is able to guess the particular puzzle, he'll be able to get certain rewards. Right now I think so the reward is around 6.25 Bitcoin to for solving one particular uh, puzzle to get that block verified, validated on the blockchain. Bitcoin mining reward. So yeah, it's 6.25 blocks. So you'll get around 6.25 block into 21 something is the reward that you'll be able to get if you are a Bitcoin miner with the help of those machines. And so in terms of Bitcoin, they get some newly created Bitcoin as a reward that we all know. If he's making it, validating it, then it will be given some kind of rewards. Exhausting resources to solve the puzzle means the miner has actually solved the puzzle, and which eventually means that it has the proof of work for solving that particular puzzle on top of the blockchain network. Currency generation. So how is the currency getting generated on the blockchain? How is currency getting generated? We see that to award the incentive to the miner, new bitcoins are generated and sent to the miner's address. So as and when the he becomes like the first one to solve that particular blocks puzzle, he'll be incentivized with some rewards to his address, whatever he has associated with the network, to become a miner. A predefined schedule limits of total number of bitcoins that can be earned, so that they gradually approach to a total of 21 million. So what does that mean is uh, uh, there are like 21 million bitcoins that will actually exist in the in the ecosystem of blockchain. So as and when he solves and tries to solve that puzzle, he is exhausting that particular number of bitcoins. So in total, like in in circulation, if the block gets created in circulation, it will add 6.25 bitcoins again and again, and this happens over the net every 10 time frame of every 10 minutes. And every 10 minutes you any particular miner is actually creating 6.25 bitcoins. The limit of 21 million bitcoins at hardware, so it is actually hard coded on the genesis block of bitcoin, which is what is the genesis block. If we recall that genesis block is the first block which has all these values inside it, like how many bitcoins will ever get created and so on and so forth. And there will be no more bitcoins than this, unless of course if they update the protocol in the future, so which is nowhere seen to be like in the near future. But this is the number of bitcoin that will ever be created. And who will create these bitcoins? These bitcoins are generally created by the miners itself. So bitcoin is like 19 million has already been generated till now, and 15 I think around how many 1 million is 1 million 5,000, like 1.5 million is yet to be left. Bitcoin issued is around 92.762, 8% is only remaining, and every day 900 bitcoins get mined, and which is actually like 8 lakh 800,000 six bit Bitcoin blocks get generated every day. Yeah, so that is the calculation of the bitcoins that is getting generated every day, and of how many bitcoins blocks have been created as of now. So according to this, the hash is also like getting complexed, and it will be like generated till I think so 2100, uh, and it will be around 21 million itself. So it is built like that. So illustrating the proof of work, what exactly is the proof of work? So if you see, this is an existing blockchain, and these are like the blocks getting mined by a particular miner itself. So this is blocks that is following the solving and trying to following the longest chain rule. And what is the longest rule? Which longest chain rule is like something similar to a chain that is the longest, and it is the authenticated and validated chain itself. And you see, these are other blocks, also miners who are trying to generate the block but are not able to generate it. And yeah, so nodes in the block is this thing, and the blue thing is the blocks. The winning block is actually getting mined by the Bitcoin miner. He'll get the rewards. We saw this earlier. This is some kind of calculation. If x has more zeros, greater difficulty to find the proof itself. So leading number of zeros will validate that how difficult it is to calculate the nonce of the solution for that particular algorithm. Challenge for proof is something like this. If more blocks get solved at the same time, then what will happen? So if more blocks get solved at the same time, actually it is possible, but such a contradiction is solved by the consensus rules. What are the consensus rules? That same thing that will be happening in the proof of work. So consensus algorithms are the central to the function of any blockchain. Without it, the blockchain won't be able to function properly. When there is a contradiction among nodes about the blocks in the network, such contradiction is resolved by the consensus rules. So what are the consensus rules? We'll see further ahead. And what is consensus? Consensus is the task of getting all the process in a group to agree on a specific values based on the votes of each process. So everyone will agree that okay, this particular block has been mined by this particular miner. Everyone has to agree to it, otherwise it won't be coming out to a agreement that okay, this blockchain will run like this, and eventually will lead to a fork or some other consequences for that particular blockchain itself. With the consensus algorithm, we need to get unanimous agreements. So consensus actually means agreement itself, general agreement. So you have to have the unanimous agreement so that the blockchain can function as it is meant to be. Any algorithm that depends on multiple processes maintaining a common state relies on and attaining a consensus itself. So every blockchain has to come to a consensus with their defined rules inside their algorithms itself. Several branches. So there can be chances that several branches are created, although the problem is tough. There are chances that more than one block will be solved at that same time. Several branches of the blocks are responsible in such cases, and everyone should simply build the blocks on top of the block blocks of the first blocks that they receive. So they have to create on this block itself, but they can create more than one block at that same time itself. So you see, other nodes may have received the blocks in a different order. As we know, the blockchain works in a chronological way, so it will receive the blocks in different order itself. So they will be building on the block they receive first. So like say suppose this block is received to that particular person, and some this block is received to that particular person. He'll try to build on that particular block itself. So Paul's blockchain. Paul received the green block first, hence he builds the next block on top of the green block. So he's building on this. Robert is received the orange block first, so he builds on the next block on top of that particular orange block itself. And same way, the Lisa has received blue, this particular blue one, and she's building on top of blue block itself. What happens when the next block is solved? The tie gets broken actually. Whatever is here, the tie gets broken, and when someone solves the next block, because it is very rare, the situation doesn't happen very often. This situation is rare for this situation to happen multiple times in a row. So it might happen like once or maybe in a blue moon, but it is like very difficult to happen that this particular everyone is creating their own block on different blocks itself. Mostly it gets synced for most of the nodes itself. Blockchain quickly stabilized the situation through the longest chain rule that we were discussing earlier. And whoever is trying has the longest chain with the blockchain itself, that chain will be considered as the most validated chain, and everyone will follow that uh, ch- uh, particular ledger itself with them, and the rest of them will be considered as the orphan blocks, and which will remain inside the network, but the transaction then again gets inside the mempool and becomes in like, then again miners need to mine that block to confirm that particular transaction itself. So this is a graphical representation of the longest chain. Paul's blockchain is one of these things. He has been building upon. Roberts will be one. It will be seeing all the longest chain who has been building properly, and that particular person will be considered as the miner who has validated the blocks and will get the this rewards itself. Blockchain quickly stabilizes. Every node comes in an agreement with the current state of the ledger is the solution for that particular problem. Transaction in short branches. What happens to transactions which find themselves in short branches? So the transactions are legitimate. So even if they end up in getting the inside a block which has been inside the short branches, what will happen to them? Transactions in short branches will go back to the pool, as I was just telling, of unconfirmed transaction, which is the mempool itself, and will be picked up later in the block by the miners. And then again, it will be given to the miners to solve that particular problem and get these transactions confirmed and validated inside a block itself. Okay, transaction in the shorter branches lose its place in the longer chain, and then again inside the mempool, and then shorter branches go back to the unconfirmed transaction part and will be included later in the block itself. What if a miner tries to cheat the system? So since we have like monetary gains to mining this blockchain itself, actually some of the miners can manipulate it to get more rewards, or like make it in like for their own good, and cheat the system. So what will happen in that case? Since there is a reward for solving a block, there are chances that miners might give a wrong solution to the block, or they might give out like, okay, I have solved the block, and please give me my reward. So to eradicate the problem, what can be done? So after creating a block, a miner has to publish the block with a proof of work to the network. So it has to authenticate that, okay, he has tried this with this much uh, proof, that he has tried this much rounds of to solve that particular algorithm solution. on the network. Otherwise, it won't be considered as the genuine one. Others miners will validate the block to ensure the authenticity. So as soon as he provide the solution, it will be given to other miners to validate. Yes, it is getting confirmed. And if you go to the transactions, you see these block confirmation. These block confirmation like increases by time, and it can be like 10-15 block confirmation is actually considered as the blocks that are like properly confirmed on the blockchain itself. Otherwise it won't be considered as a confirmed block and might get rejected by the networks if it finds something malicious on this particular while resolving that particular proof of work given to the network itself. So this is fine for blockchain. We can see on Blockchain Explorer as well. I'm not able to go to the previous blog to show you where are the confirmations here, because that is very important for to consider that the particular transaction is successfully going to be credited to your account or not. Because if you like see get the transactions uh, before the confirmations, then it might be that certain times the transaction of the blocks don't get verified and the transactions get stuck on the network itself. So it is just make sure that you have certain amount of confirmations on the Explorer uh, to get that to ensure that you will receive the transaction after 10 minutes on your particular address itself. That is the uh, way to check if the transactions will get successfully through on the network or not. So if the proof of work is provided wrong, the block is considered to be invalid, and yeah, as a result, the miner ends up exhausting his or her resources without getting any reward. So if he tries to make any malicious move, he will not be able to get any reward, and hence it will be all waste for his time and effort that he has provided to solve that particular algorithm, the particular solution. Therefore, the consensus algorithm does not allow anyone to cheat the system. So consensus is very important inside blockchain to make that blockchain work smoothly. So what is this? This is like mining, how mining is happening with a graphical representation. This is like a miner comes to show their work that he's trying to mine the transaction, the blocks. That what is a block? Block is nothing but a bundle of transactions that is given somewhere, and he picks up these bundle of blocks, show that verify if the transactions are valid, starts to work. This is the work that he is doing. Select the header of the most recent block and insert it into the new block as a hash. So as we see that it takes like a previous hash of block and then create a new header, and inside that it adds the hash and everything, and then try to solve the proof of work problem. And as soon as he has the solution to it, the new block is added to the local blockchain and propagated to the network. It will be sent to the network itself, a copy of it. What if someone tries to hack the system? So it is basically impossible to hack the system, because once a block is solved through the cryptographic once a block is solved, the cryptographic hash output becomes the identifier of that particular block. So if someone is actually trying to hack it, he has to change the all the hashes of the previous blocks right till the genesis block, to make sure that the chain is actually the network is actually following the longest chain rule. And to do that, it might require like, I don't know, like even if it's that is countable, but it would require a lot of computation power to make sure that he is able to hack the system or cheat the system to his own benefit. So if someone tries to alter any transaction in any of the blocks, the hash of block changes. So we just read that we have these hashes also inside that particular proof of work component. If someone tries to change anything, so the hash changes. Uh, and he has to convince everyone in the network that particular hash has been changed, and has to follow that longest chain rule itself to make sure that the hack has been successfully implemented on the Bitcoin blockchain or maybe another blockchain in that part. Consequently, hash of every block changes. So since every block is pointing to the previous block hash, it will change that particular hash as well. Nodes will not arrive at a consensus, and hence the fraud can easily be detected. So if he tries to, like, this particular person is malicious, he tries to change the hash of this particular block, it will change the hash of each block, this block, this block, this block, and which will actually be detectable by other peers because they will have a copy of it, right? And if the copy doesn't match, then if this thing, whatever he has proposed, will be becoming obsolete and will be uh, banned from the network, or maybe will be obsolete from the chain itself. There's no way to alter the system. If you want to alter that any transaction in the blockchain, you have to outrun the whole network. As I was telling you, if you need to change one hash of the block, you need to change all the hashes of the block right to the genesis block. So it would be like very difficult, and at the same time you need to keep on updating the new block hashes itself to make it show that it is legitimate chain on the network. Is it possible for someone with an extremely fast computer to outspace the other node? So there doesn't exist any kind of a computer that will be that fast to outspace the other node itself. It is highly unlikely that someone can do that even with the thousands of computers. Yeah, so it is that complex to, change anything on top of Bitcoin blockchain itself, or maybe on a blockchain part itself. Transactions are protected by a race. It would require more than 50% of the total computational power of the entire system to have a probability of solving 50% of the blocks faster than someone else. So it's all about the race, and it is highly unlikely to have such a computing power which is stronger than the entire system, that is around some millions of theta hashes per second that needs to be solved with one particular machine itself. So if you have that much power, then only you'll be able to hack that particular Bitcoin blockchain to your own good. Otherwise, it is nearly not possible. The transactions are thus protected by the mathematical race itself. That is the problem given to the miners, and you have to solve that particular mathematical race to, have a block mined on top of the network itself. Moving here, to sum up, in a distributed system, a transaction, it is encrypted by asymmetric cryptography, which we learned earlier. The public key cryptography is also called as asymmetric cryptography. Propagates to peer-to-peer, is stored in a public ledger, is authenticated by the miners or validators of the node, is secured by the consensus algorithm. So these are the various aspects of what a blockchain is, and all these concepts constitute to the making of one particular blockchain technology. So till now, I think so we have have little bit of idea what exactly a blockchain is and how it works, and now we'll learn about what exactly are the benefits of blockchain. So benefits of blockchain technology in cryptocurrency is removing the reliance on a trusted third party to maintain a central ledger has the following benefit. So there is no reliability on any third party to maintain one ledger, and that there are five of them given here. The first is settlement is in real time. We don't have to wait for any third party to just solve it for like maybe uh, days or months or years. Uh, Everything is in real time. We are saving the cost. We are not saving the cost on the consensus, but we are saving the cost of actually getting it done in like very fast manner, and everyone is connected in a distributed network, so that is actually like a community which is solving the helping the blockchain to function easily, so everyone is providing that input to it, so it is basically saving the cost. Security and resilience. So since we have these cryptographic algorithms, so it basically makes it impossible for other people to hack it, so everyone is like can attain the part of security on blockchain itself. Immutability, so we know that it becomes immutable since it cannot be hacked, it cannot be changed, so every data on top of blockchain is actually genuine, and it is not something that can be easily getting tampered with. And you in the last, you maintain a user pseudonymity. So what does that mean? And we are represented by the addresses. We are not represented by the names on blockchain. So there is no way that a person can know that, oh, okay, this is whose address is this, and who is interacting with like it is representing to either me, or maybe Prabhu, or maybe another person inside the network itself. In a nutshell, access to shared single source of truth is this: the use of mathematics to create a secure ledger that enables transaction without the need for the third parties is actually the more like in a nutshell to understand what blockchain is. Anonymity and pseudonymity in cryptocurrency. So cryptocurrency has like two types of it: anonymous and pseudonymous. And this anonymity, when it comes to anonymity, it is like the state or quality of being anonymous on top of the network. As I told you that there's no name to it, like, so there's no there's no name to it, so there won't be any identity on the network besides the address, until unless you know that this particular address belongs to that person, it is impossible to guess who that particular person is. An anonymous person is non-identifiable, unreachable, untraceable. That is what anonymity means. Not bound or linked to any entity is another thing. Examples of anonymous dealings is an unidentified individual telephoning an app entity to inquire generally about its good or services, and an individual completing a retail transaction and paying for a goods in cash. So that can be a good example to understand what anonymous dealing is. And these are the few examples of anonymity. There are few questions and sites. Is this FormSpring? You have WordPress for blogging and posting. And if you want to talk to strangers, it's Omegle, and for networking. And there are various examples as well, but these are the few that uh, maintains that anonymity on the internet itself. Being anonymous on a cryptocurrency network. Being anonymous has its own rewards, but invisible exchanges or value double-edged sword is something that is also anonymous part. So, but extremely valuable examples of some these are forms of truly anonymous communication, such as political speech, are considered as valuable. And electronic harassment into trade and business. This forms of anonymity has exceptional potential for illegal acts, being messages sent because messages senders cannot be held accountable for these actions. So anyone can do anything, and which is actually dangerous. And it's actually, since being there's no control over it, people can go haywire if not put a control on top of it. And being anonymous makes it harder to trace that particular transactions and give higher level of privacy, so that makes it like easy to launder money or maybe do some kind of activities that is not permittable or considered as illegal in the society as well. And these are the anonymous cryptocurrencies like Zcash, Bitcoin, this one, and Monero is are the some of the examples of anonymous cryptocurrencies. Discussing anonymous cryptocurrency, first one is a Zcash. So Zcash is somewhat similar to Bitcoin, but it is totally anonymous cryptocurrency, providing complete anonymity solution, hiding all knowledge about the transaction. So you won't be able to figure out who is sending you the transaction or who are you communicating with on top of Zcash. But you have to, if you are aware about who to send and receive, yeah, it that is between you guys itself. Otherwise, no one in the network will be able to identify who that particular person is sending and receiving to. It is a concealed value exchange. It provides a user with a private access control to their financial information. So it is really between you or the other person or who you are sending to will be able to identify. Otherwise, even if you send it to like previous person, will not be able to guess whom you are going to send the money to if that person is not address is not familiar to him. It is an application of ZK Snarks cryptography. It is then again a form of cryptography where ZK Snarks is considered as zero knowledge Snarks, wherein no one has any knowledge about who the other person is and which maintains a complete anonymity over the network itself. Its content can be seen only those with the correct view key itself. So yeah, as I just mentioned, like the person whom you are interactive with is the only one who will be able to see the content of it. Otherwise, it will be difficult to see it, and these network will consider them as zero knowledge, who will not be able to give out any knowledge to any third person if they wanted to. Its user can provide a view at their discretion. So anyone can view that particular transaction at their discretion itself. No one needs to know about it. Zcash is a very interesting technology provided the security is not being compromised. So these technology are like very high level technology, and you can easily trust that these technology will not be compromised in near future or today itself. Pseudonymity. What is pseudonymity? Is using a pseudonym is like to establish a long-term relationship with some other entity without disclosing personal identity to that identity. So it's like you know that particular person, but if you they are like stand out in the public, it will be difficult to identify who that particular person is. So if you can see, I can't in the network itself, I can't identify you, but I will single you out. Like you have an information, but that's not completely there with you. A pseudonym is a unique identifier. Example: nicknames, credit card numbers, student numbers, bank accounts, etc. Some of the identifiers. Using a pseudonym is the entity links different messages from the same person. Pseudonyms are widely used in social network and other virtual communication. So it's like you come out with the wrong, like not exactly your name. Like say, suppose it's like you identify as yourself as 210 James. So you are not coming out as your own name, but some other person. Importance pseudonymity in cryptocurrency. All the transactions in a pseudonymous network are open and visible to all, and thus it is widely acceptable. So that is why it is important. Transactions have an origin and destination address, and hence the flow of money can be observed. You can see that particular transaction happening over the network. Illegal use of cryptocurrencies can be tracked by careful analysis of the metadata. So some people who don't like, maybe the government agencies don't want or maybe want to trace some people who might use it for maybe drugs or maybe other terrorist activities, they can do it by carefully doing an analysis on that particular metadata itself. So if you can see, there are three steps written over here, wherein A sends 4 bitcoins to B with this particular address, and this is the address. This is the balance of it, and A's address is pseudonym. You know he is that particular person, but he is with another identity itself. Network verifies the transaction and stores it inside the memory pool, and B receives that particular amount that he has sent from that A has sent to B with the with by confirming his address that they know in the network itself. Programmable money. So cryptocurrency is actually programmable. Without programming it, it won't, like Bitcoin is completely programmable. Otherwise, it won't be able to function over the digital network. You can write out different codes to make your cryptocurrency over your network. In Ethereum, there is a lot of hype in 2018 for creating such cryptocurrencies over the network itself, and that was all nothing but a few smart contracts which was generating the cryptocurrency and creating out few blocks on top of Ethereum itself, and you can have your own cryptocurrency with you on the network. Each unit is individually identifiable and programmable. You can customize it however you want. Users can assign properties to each unit. So, as we discussed, is completely customizable. You can design however you want, and you can assign properties to each unit and whatever, however you want to do it. Users can program a unit to represent a euro cent or a share in a company, a kilowatt of energy. So you can associate it to anything or maybe peg it to anything you want. So if you say, suppose we have one cryptocurrency called USDT, so that is like pegged to the USD, so its value always remain to whatever the value of USD is. So it's has to be one USDT will represent equals to one USD itself. So that is how, like, you can peg it and you can program it in such a way that it won't go higher or lower than that particular value itself. Because of all these, cryptocurrencies much more than simply being money or a way of payment. So you can basically say that every cryptocurrency has some business prospect to it, and according to that business prospect, people tend to invest in your cryptocurrency or buy your cryptocurrency if they find that solution feasible, or maybe future a solution that is future proof and will be used by other people as well. So in that way you can program it, raise money, or maybe uh, do anything with it if you want, with writing such programs on top of this technology itself. So if you want to build on Bitcoin, you need to have something idea about this C++ and Rust itself. How cryptocurrencies can be programmed. For a single transaction between two parties, programmable money can give the payer and the payee a vastly greater range of parameters to use when exchanging the value. So everything can be done by calling out the functions, and whatever there are predefined functions within the network itself, it will actually be considered as the program between the blockchain network itself. It also enables a huge array of different valuables to be exchanged, far more than conventional money. Time, contracts, expertise, goods, services, and more can all be traded on top of cryptocurrency as well. So it is what how you program it and how you define it, according to which you can derive a solution and sell out your cryptocurrencies to raise money or maybe a project you want to do. Example: Alice buys a car online from Bob. The payment will only be executed after the car has been delivered and passes an emission test. So you can define out a contract on the network itself, which will state that only transfer money if the car has been delivered successfully and pass an emission test. And who will do that? It will be a contract between Bob and Alice. And Bob will be like a car owner who should get this emission test done and give to Alice. And once Alice sees it and it makes sure that it has received and checks all the tests, then only it will be able to confirm that uh, uh, the contract is verifiable and will give the permissions, and then the money will be the money that will is holding it in Alice's wallet will be then be transferred to Bob's wallet. The term verification is completely completed by the shipping agent that we were just discussing, and the emission test agent. When both are completed, the transaction is authorized and the money changes hands. So that is completely programmable on the blockchain network itself. Is there any other implementation of blockchain? Yes, there is. There are various ways in which blockchain can be implemented, and we'll see further ahead. Bitcoin is actually the very first implementation of blockchain, and blockchain's foremost implementation. However, there are various ways in which the technology can be implemented, like healthcare, maybe supply chain, or any others like cross-border payment verification. As few of the examples, but Bitcoin was amongst the first that was very famous. Actually, the blockchain was around since 1917s, and everyone was trying to implement a solution on top of it, but they weren't very famous, unlike Bitcoin, which was also not very famous. But gradually, with time, they saw the potential into it and the features and security aspects into it, which makes it famous, and that holds now the certain value of that particular asset, which is around 21 lakh rupees. Blockchain is something that is beyond Bitcoin. Bitcoin can be like one of the use case on top of blockchain, but it does not entirely sums up what blockchain does. So blockchain can be considered as a database. It can be considered as like various things on the various solution use cases. The monetary aspect is just like a tip of the iceberg of the blockchain technology, and blockchain is a groundbreaking technology for which money is merely one of the possible applications uh, as we consider. So potential applications of blockchain here we have industry flows, like one of the settlements, change of supplier, meter data, real-time capacity matching, a few of the flows, and potential applications, autonomous network configuration, self-server maintenance, asset and inventory tracking, cross-asset industry and data sharing, identity management. You can do fraud detection, also loyalty schemes, also eligibility of social tariffs, safety and authorizations, and a few of the smart contracts you can also write on top of blockchain, where you can define certain aspects like EV charging, how many watts do you want, and how much money you'll be giving out can be logged inside a smart contract, and you can uh, put it in the money, which will act as an escrow. And once you approve it that EV charging has been done, then that smart contract execution can be termed as completed, and that can also be used as an aspect of potential application of blockchain. Database overview. So I think so everyone here is well versed with what a database is. So imagine a world or a application where we don't have an database. So it will be like an high value application, but with no memory of what has happened previously and what uh, certain of information we are working with. So it will be like nearly impossible if we don't have the databases to give out the correct information. It will be just gibberish words, and everything will be like haywire. So uh, what will we do? What if we don't have databases? Did you know there exist an immutable and non-temperable databases? Does anyone have any idea about that? Uh, that is actually the blockchain itself. So, how did blockchain get started? In 2008, Satoshi Nakamoto, an anonymous person or person, so we don't have any information about that. Who is that person? Gestated the and implemented the first blockchain database as infrastructure for Bitcoin, the first cryptocurrency ever created and the most successful of all time. So it is like everyone when they like it is much more famous than blockchain. So people tend to think that Bitcoin is the blockchain and that is the only aspect or use case to it, but that is not indeed a fact because blockchain is just a very overwhelming technology, and blockchain consists of different use cases which can be implemented in the healthcare sector, education sector, and supply chain management sector as well, and various other sectors. Mostly every sector is trying to implement a solution on top of blockchain, but on top of blockchain, but most successful one is actually Bitcoin, and it is also a very first one which was introduced to the world in 2008. How did blockchain get started? So Satoshi Nakamoto uses the words block and chain separately in his paper in October 2008. Okay, so how did blockchain evolve? So initially, when blockchain was introduced with Bitcoin, it was just a cryptocurrencies and payment network, which was a blockchain 1.0. That was the most, mm, the blockchain was in very initial stages, and they just had these use cases of cryptocurrencies only. Later on, we were introduced with the concept of another blockchain called Ethereum, which actually introduces us to the concept of smart contract and asset management, and wherein people could program these blockchains to work in certain way that it can be termed as an escrow accounts, or maybe create some other aspects to it as well, to uh, make it in such a way that it becomes much more easier and convenient for us to use this blockchain technology. We had this 2.5 version as well, where we had these other distributed ledger data layers, blockchain bridges, and vehicle currencies as well. Now we are in the world of Web3, which is where you can see we have different smart contracts on different chains which can actually communicate with each other with various technologies and other tools as well. So nowadays you can just create a blockchain with plug and play, and or maybe with different tools as well, like AWS blockchain as a service, wherein you can just create a blockchain with few steps, few clicks. Yeah. So what does the note say? Note says that smart contracts are unable to access external data or events based on time and market conditions. So earlier, smart contracts were very difficult to work with, and they were not able to access the external data or event based on time. But today we can do it by different means, and add like smart contracts has been evolved, and now we can use current market data with the fetch of the now API, just making few calls from the smart contract itself. Calling code or data outside a smart contract or blockchain breaks the general trust barrier and authenticity of transaction. So yeah, nowadays like it has been improved, and the data outside of smart contract can be called in Web 3.0. Earlier it was not possible. So what is a flow of how flow inside a blockchain, how transaction happens? So if you see individual try to make a transaction, which is basically an event. And what is an event? Event is anything that is occurred on top of the network itself. So whatever kind of action you make is actually recorded in the blockchain in the form of transaction, which we learned earlier. And inside blockchain, we have earlier also learned that the transaction, once signed, will be sent to an memory pool where all the unsigned transactions are kept. These instant transactions are then picked up by the miners, which will then compile them into a block, and the block will have certain information like block hashes of a block ID and block hash to previous block, a certain timestamp, a value of nonce, which has leading zeros, and certain other components as well. And once these miners create a block, which are then run by guessing out a particular cryptographic s- s- key, which needs to be guessed by people by showing them a proof of work, by keep on guessing the that particular key itself. Once they are able to get that key, uh, guess that key, they will be able to mine that transaction and send it to the blockchain. The other miners will actually also be competing, and if someone tries to uh, share that particular block on the network, the other miners will actually validate to make sure that the blockchain will have an authentic block and with a certain proof of work. And once it has been verified, that particular person's block will be added to the chain. And yeah, so the once it is added to the chain, it will receive its rewards that he has earned by investing its resources on the network itself. So if you see, new blocks of a transaction includes a security hash of a previous block is once the transaction has been generated, and then the blockchain new blocks are added approximately every 10 minutes. But this is actually in case of Bitcoin blockchain itself. For other blockchains, it will be it can be, the time can vary upon how they have programmed it. For some, they have like 4 minutes. For some, like the fastest is like, I think so, a minute or two, where every blocks are added to the network in like a minute or two by every nodes on the network itself. Multiple computer mining servers check the validity of the blocks in the chain. The quickest to check latest block gets the payment is actually the role of these resources that are invested by the miners. These are the rigs that are used to solve that cryptographic puzzles. And once a transaction has been sent, all these blocks will be chained together, and block validated as honest part of the chain are added to the network. Otherwise, it will be rejected and sent back to the transaction pool, unsigned transaction pool. Sorry, memory pool, and then it will again start to work from step one. All these transactions. So this was the flow of how blockchain functions. And moving ahead, we'll look into the innovations. So starting from 2008, where Bitcoin was introduced to Earth, uh, and the persons who designed Bitcoin as a part of the implementation. He also devised the first blockchain database to be used. And is the most successful till date. So since it has not been, I think so, it has been like how many years? To around 15 years, and this Bitcoin is still not has been hacked. Whatever the reasons were there that people we saw in the news that Bitcoin was stolen from their wallets was a hack because of the uh, cryptocurrency exchanges and the human error. So that is how the bitcoins were actually stolen. Otherwise, has been no vulnerabilities detected on the Bitcoin network till date. and it is working smoothly till now. And yeah, moving ahead, blockchain as an application was the second innovation. So we had certain other aspects wherein blockchain was seen as an application as well. It was essentially the realization that underlying technology used by Bitcoin could be separated and used for other operations also. So they realized that okay, it is not just for fintech, it can be also not used for only trading, but it can also be used for storing out your digital assets, transferring all their digital assets, maintaining a record of what where all the digital assets has been, so that you have the authenticity of that product, which is just like tracing your supply chain management. uh, and it could be like an example wherein you track a product called maybe an apple from farmers land to the shop itself, retail stores like Reliance and everything. You can trace that using the blockchain as well. That can also be in prospect to wherein the blockchain can be used. The third was the most smart contract embodied in a blockchain 2.0 system with the introduction to Ethereum. Yeah, so with the introduction of Ethereum, we had these smart contracts, which are nothing but a few certain conditions which are written by the developers, and the developers tend to provide all the certain steps, which is followed by every uh, peer who is trying to interact with them, and it will be same certain steps. And yeah, it is just like a little built computer programs directly into blockchain that allowed financial instruments. So you can create. This was the time, actually, the era of ICOs in I think so 2017-18, where people try to build certain business applications to raise fundings by listing out their tokens. And yeah, a few of them were working very smoothly, but few of them were also turned out to be a scam and people were ripped out of them. So it is very important for you guys to actually, before investing, just learn what person is doing and if it is a legitimate business or not. So that was the era of smart contract, where people try to create their own smart contracts on Ethereum network and try to run their organizations uh, in in the way they want to, and also program it in a certain functions. The fourth critical innovation is the proof of stake. So proof of stake is like current generation is secured by proof of stake. The Ethereum network is actually being uh, secured by proof of stake. What does it mean is it is a consensus algorithm, the one which we were discussing earlier. It is the it was the expensive actually consistent algorithm, because people tend to invest a lot and were competing with thousands of miner at once. So the person will the most powerful resource or most powerful mining farms or rigs will be the one who will be out overpowering the other miners, and they are competing each other to reach that particular key. And once they're able to identify that key, they'll be able to get that rewards. They are competing with that. So to avoid that, we came to this proof of stake to reduce the power consumption and the resources part. Now the proof of stake is like, basically you stake some amount of money to confirm yourself as a validator over the network, and the more the money you invest, the more reliable validator you will consider, and you will be given out the money to uh, you'll be given not money, but you'll be given out a chance to validate the block over the blockchain itself and earn the rewards, whatever the amount is as on the blockchain itself. So current generation is secured by proof of work. The new system is replacing them with the complex financial instruments for similar or higher degree of security. So what is the Blockchain versus traditional databases. Let's understand more about blockchain, see how it differs from the traditional databases, and then later we can discuss about the distributed ledger technology. So this is the difference tabular representation, where we have one row as characteristic, one as blockchain, one as legacy database. So the data ownership, the first characteristic is the data ownership, and maintained through in blockchain, it is actually maintained through cryptographic key pairs and native cryptographic algorithms. Where in the legacy database, it is established via central authority. Only one person is actually creating it and will be the owner of it, and certain other roles can be declared over there, but only one certain central authority will be there who will be handling all that database itself. But in blockchain, every peer is responsible, and which is then again maintained through this cryptographic key pairs and native cryptographic algorithms like SHA 256, SHA 3, elective crypto elective ECDS algorithm, elective curve cryptography algorithm, are certain examples of these running in the blockchain network itself. Privacy and security. So we have cryptographic authentication in blockchains. Like there are a number of cryptographic algorithms running behind the blockchain to make it secure, and tamper-proof, make it easy, immutable. Wherein a legacy database configuring each row based on enforcement from a central authority. So every the configuration is done on the base of enforcement from the central authorities. From the is how the privacy and security maintained in the legacy databases. Access control inherently identical for all permissioned nodes. So there's no some kind of access. So everyone will have certain same access it only. Wherein the access control in legacy database is centrally administered, and only one particular person will be responsible for it, distributing the access to other people who wants to interact with that particular database. The trust factor, native via immutable records. So it is maintaining its immutability by just adding up and making it like an append only, and nothing can be uh, you know changed once it is stored on blockchain. And then again, the trust is established via the central authority itself. So if central authority says it's the certain function works in certain way, then we have to trust that. We have no other options. But in uh, blockchain, we have everything on the internet itself, and you can check it on the explorer what exactly the truth is, and so that maintains the trustable factors of the blockchain. Data quality, so immutable records with automatic conflict resolution through consensus for transactions. So everyone comes to the same page via this consensus algorithms, and on this legacy databases, we have complex conflict resolution processes, and it requires actually the manual intervention, and wherein people tend to come in and only one person or maybe a group of individuals will be responsible to maintain the quality of the data, and to help people understand that this is the actual source of truth. For this database validity is actually maintained constantly. So every 10 minutes, since miners are adding the blocks to the network, it's actually providing the validity that these transactions are correct, and it is actually continuous process throughout the journey of a transaction over the network, or like a journey of a block over a network. And on traditional legacy databases, it is provided only for single instances and time. So it will be like done once in a month, maybe, or thrice in a month, twice, like once in a quarter, so on and so forth. You can just decide how the database validity has to be done. So yeah, So next comes the data propagation. So quick propagation all over the network node. So everyone is given the propagation of data at once across all the networks by the gossip protocol itself. But on a legacy database, the managed through multi-version currency control (MVCC) and through custom synchronization. So we have different scripts for this to make sure that the data is propagated properly. Enforced data transformation built into data logic layer. So the data is transformed inside the data logic layer logic. It has none as such. So there's no part that is existing for the enforced data transformation in legacy databases. Concurrency and synchronization. So consensus identical copies, and that identical copies is shared with everyone over the network, so that consensus is maintained over the network itself. In the legacy databases, it will involve complex checking between the central databases and the user databases to ensure agreement. So every database has to be similar to what centrally information has been provided on the central database, and the user database has the same information to ensure an agreement on the legacy databases. So it is kind of an actually hackable process, and also not a trustable process when it comes to legacy databases. Reliability and availability. So peer-to-peer networking for distributed data replication across all nodes, since we know the ledger is actually distributed with each and every node. So the reliability and availability is like 24 hours, and it is actually a reliable source of information that whatever happens on the network is actually same, which is same on my other peer who are connected to the network as well. So everyone is on has one source of truth only. Wherein the reliability and availability on legacy databases is like potential single point failure. So if the central database goes down, everything is like collapse. So if on a production site you're working upon, and if you by mistake do working with one command that drops the central databases, it is actually of sorry it is actually a point of failure which cannot be retrieved then, and everything will be collapsed. So yeah, that is uh, one of the disadvantages of legacy databases. And we have the stored procedures as well. So stored procedures is nothing but some kind of rules and regulations you provide to store the data or to manipulate the data. In blockchain, we use smart contracts for that. In legacy databases, I think so. There are few available in MariaDB. It's not currently not available, but there are some kind of stored procedures that we work with uh, in legacy databases as well, which will just manipulate the data however you want. You just call those stored procedures from the functions, and you'll be able to manage all the data you want from the database itself. Transaction creations available to all permission parties. So whoever is connected to the network is actually eligible for creating or doing a transaction over the network in blockchains. And the legacy databases, whoever has the permission to append or read or maybe write, so that is the person who will be eligible to create a transaction on legacy database. Otherwise the person can just either view it or maybe have no permissions as well. So fraudulent and malicious changes. Immutability through reliance of previous blocks, since it is being a previously linked chain. Everything is actually linked with each other, maintaining it uh, immutability state on the chain itself, wherein the legacy databases is not available, where current keys and check constraints remain like insufficient. So it is like a little bit of not a little bit of big threat in that case, because you do not have the uh, proof that the data provided inside it is actually genuine or not, because you don't have that particular capability in legacy databases. So we move to distributed ledger technology, DLT. People think blockchain technology and distributed technology as one of the same. So interestingly enough, it is actually not true. Let's show you the difference actually. These are the properties of distributed ledger technology. Distributed is all network participants have a full copy of ledger for a full transparency. It is anonymous. The identities of participant is either pseudonymous or anonymous. Timestamp transaction and timestamp is recorded in a block. So there you won't see any instance in a blockchain that is without a timestamp. So everything is maintained with a timestamp, and you know when it was incurred over the network. Unanimous, everyone is agreeing on one particular decision. So all network participants agree the validity of each of the records. No, there will be no node which is working on different record, because because that won't be achieving the consensus and it will be discarded from the network itself. Immutable, any validated records are irreversible and cannot be changed, since we know it is just like append only. So everything you see on blockchain is you can add on top of it, but you cannot rewrite or change what previously has been stored on the blockchain. So it makes it like an immutable form of source on blockchain. Secure, since it has been encrypted with the different cryptographic algorithms. It makes it so secure that no one has been able to hack it till yet. We don't know about the future, but it is actually not possible to do it in the future as well. But yeah, till now the security has been maintained, and I think so it will be maintained in the future as well. Programmable, so blockchains are actually now very programmable with the help of smart contracts. So you can create different smart contracts to process the data or to function the organization in such a way that it is able to achieve what the business targets are, making it programmable and easy to work with. So all blockchains, it is said that all blockchains are distributed ledgers, but all distributed ledgers are not blockchains. And yeah, that is how it is different. And we can see for the distributed ledger technology, it is actually globally distributed with almost zero barriers for transacting goods and services. Online payments and currencies are among the first use cases of this blockchain itself. A range of industries use cases, banking, automotive, insurance, healthcare, life science, manufacturing, retail, and telecom are uh, you know use case of it. Highly secure cryptographic implementation is a part of blockchain, and 100% digital and programmable. These blockchains, game changer in IoT, because it can be storing the data inside that all the data generated by IoT can be stored inside the IoT. There's a blockchain itself, and peer-to-peer network with no central authority makes it like a trustable source of data, and completely transparent and auditable scan, so that it can be seen on the network itself. So it becomes like a transparent source of uh, data itself to be consumed by the networks itself. Comparing popular blockchain frameworks. So characteristics, we have these three important blockchain tools. One of them is Ethereum, which is a generic public platform, and Hyperledger is actually a modular blockchain platform, which is just like a plug and play, so you can add any type of consensus or maybe do any kind of a membership service provider. Like you can just take out a module and add it to the Hyperledger fabric, and it will work mostly. Uh, Wherein R3 Coda is also another tool which is specifically designed for people who are, uh, you know, wanted to work with financial industry. So it is a specialized distributed ledger platform for financial industry itself, the R3 Coda. These are in this, the governance is done by the Ethereum developers. So they are responsible for the governance on the network itself. On the Fabric, Linux Foundation is actually responsible, and in R3 Coda, they are themselves responsible how the governance will be happening. Second, the third point is the mode of operation. So the operations here in Ethereum can be either public, private, or permissionless. It cannot be one. And in Hyperledger Fabric, you mostly create out blockchains which are permissioned and private. So if you have these keys, then only you will be able to log into this network. Otherwise, you won't be able to access it. So this is how the Fabric creates a solution on top of it. Wherein R3 Coda is more or less similar to what Hyperledger Fabric has to offer, that is permissioned and private. So they also create solutions which are not publicly available, but are made available for a closed group who will have certain certificates and identities to be enrolled in the network as a player of that particular uh, uh, environment or ecosystem. So, what are the consensus working in these Ethereum? So Ethereum was earlier based on proof of work. Now it is actually being shifted to proof of stake, and the consensus has been recently changed in 2020. I think so in 2022 to proof of work, and yeah, so that is how the consensus is being done on Ethereum, and it is ledger level itself. Whereas on the Hyperledger Fabric, broad understanding of consensus that allows multiple approaches. So it is basically using master slave approach, which is like a more of technical, not technical term, but very technical specific thing, wherein the consensus are being followed by the whatever the data masters generates, and it is then to be distributed among the different slave nodes, which then achieves the what consensus then it achieves the consensus over the network itself. So the that particular thing is called as a Byzantine fault tolerance problem, where it achieves a consensus in that way. And it is also in a transaction level itself. So how the transaction is happening is how the consensus is achieved on the network itself. Whereas on R3 Coda, the specific understanding of consensus is actually the notary nodes. So they are responsible for maintaining the consensus over the network, and it is also a transactional level part of it. So how do you write the smart contracts on this Ethereum network? You use this programming language called Solidity, which is more or less similar to JavaScript, and through this you can write different contracts which will execute over the period of time on the blockchain network itself. And in the Hyperledger fabric, you write these smart contracts with Go and Node.js, and you can also have different SDKs like Python and JavaScript. There's Java also to write your smart contract code. And in Hyperledger fabric, the smart contract is called as chain code, which is more or less similar to what smart contract is, but it can be generally written in traditional languages like Node.js, Go, or Java, or Python. Wherein in R3 Coda, it is specific to Kotlin and Java, and you can write your smart contract code in Kotlin and Java itself. And the smart legal contract is for legal pros only. So, what is the currency used to fuel these network in Ethereum? Is actually Ether, and you generate these tokens via smart contract, or you can generate it via mining to from the network itself. Hyperledger Fabric doesn't have any such currencies, and if you want to create a currency and tokens, you can create it via the chain code, which we just learned how to. We learned that we can write it using the Go, Node.js, or Java. In here, there is no concept of currency, so you can just create other platforms like CBDCs and etc., but you cannot create any currency on top with R3 Coda. So, distributed ledger and blockchain. Centralized or distributed ledger. A distributed ledger is a network that records ownership through the shared registry. So, say, this is the diagrammatic representation wherein every source has to communicate with the central authority ledger, and that is the only source of sharing the shared registry. Wherein the distributed ledger, you can communicate with any of the peer who you are connected with. It's like you are connected with this peer, you can just directly communicate with this peer, and so on and so forth in the network by using these gossip protocols. But here it is a centralized ledger, and here it is like a distributed ledger, and every ledger is maintained with each node itself to be on the source of the truth as well. Okay. We'll see now what exactly a blockchain structure is. Let's see what goes inside of Bitcoin blockchain. So we have this block, and this block consists of the version number, what number of block it is, the nonce, which is the number only used once that we previously also saw previous block hash, so that it is linked in the form of chain, the timestamp of that particular block that has been created. The Merkle tree and the root is actually some kind of cryptographic algorithms wherein every hash is actually changes the form of the tree that is storing the transactions itself. You can see these are the three components basically: the header, the Merkle, and the list of tree. Header consists of these four things. Contains a version information, nonce, block ID, and timestamp, wherein the Merkle is like a hash built from the block's transaction identifiers. So basically, whatever the transactions are here is actually the uh, Merkle tree's root, which will identify how the transactions are getting stored on the block itself. There is list of records, so whatever the transactions has been done is actually stored in this third component. So identification hashes that were included into the block's Merkle tree. So you see these are the blocks. How a block will look like. The block height is one thing. The state is confirmed if it is confirmed or not. If we can see it, I think so, some older transaction maybe. You see the transaction status is final. Timestamp is there. Every timestamp it is there on. proposed on, or when was a block proposed on. So this is Ethereum. Somewhat it is different from Bitcoin blockchain, but it gives them clear understanding what exactly is more or less stored on the block itself. So the transactions, how many transactions were there, you see if these were the transactions inside that particular block, and it's all anonymous. So no one knows whose address is this until unless you carefully search and look for the metadata. And yeah, so if you want to see how this block structure looks like, so this is an example for Bitcoin. I will Bitcoin blockchain explorer. So you see, this is what Bitcoin blockchain looks like. Block, sorry. Still, I think it's not confirmed yet. Yeah, so this is like a Bitcoin block. I think so. We can pick up like previous one, maybe something like 6987. Yeah, you see, this is the information that is inside a block, a hash. What is the capacity of that block? The BTC values inside it. The Merkle root. What is this is actually the hash of it. What is the current difficulty at which it is getting mined? So this is the difficulty uh, which it got mined on. What's the version? The size of the block, it's actually in bytes. The depth of it, so what is the Merkle tree is like, how deep it is to identify the tree formation is actually that. Yeah, so transactions, how many transactions are there? It's 2560. Input value, output value in BTC, witness transactions. The fees that was charged during the transfer of transferring of the BTCs inside this block. The height of the block is actually the ID. When it was mined, the timestamp, the reward given to that particular uh, person who has mined the block. The 6.25 BTC is the minted part the miner getting. The fees inside the block, what was the average, and this median fees, and who is the miner. The miner name is via BTC. So you can see, check this out also. Very interesting, very informative. So distance is like technical thing which is inside an tree structure formation. That is what I think so distance means over here. And sometimes that gas, it goes the value inside the gas, so that is how the value might be little different from what the transaction fees is. So this concept also we'll be learning further ahead. Just wait for that. So structure of a Bitcoin block header. So consists of three sets of block metadata, reference to previous block hash, as we have been learning over the course. Difficulty, target, timestamp, and noun. So what is the target difficulty as of now that we just saw? The Merkle root, which is a very important factor inside the block header itself. So we have like size of 4 bytes, the version field, a version number of to track software protocol upgrades. So this is 4 bytes of the data. 32 bytes of data is of the previous hash, which is a reference to the hash of the previous block in the chain. Uh, the Merkle root will also be of 32 bytes. So hash of the root of the Merkle tree of this block's transactions. So if like a hash changes, the complete structure of the tree is actually being changed, and the timestamp is actually consists of is actually the size of 4 bytes, and the approximate creation time of this block is actually the timestamp. And difficulty target, so it's the proof of work algorithm wherein the difficulty target of the block is actually given. So how difficult is actually to mine the transaction over the network is actually the difficult target of the block header itself. Block identifiers, header hash and height. Block header hash, the primary identifier of a block is its hash, cryptographic hash. So that's how it will be identified. A digital fingerprint made by hashing the block header twice, resulting in a 32-byte hash. So that is how the header hash is generated by hashing it twice, and resulting in a 32-byte of hash, which is the output value. The block hash identifies a block uniquely, so it is a unique identifier of that particular block. Block hash is not included inside a block's data structure, so it is not a part of it, but it is attached to it. So yeah. Block height. So block height is the position of the block in the blockchain. So what number of block it is. Genesis block being the 0 block or the first block. It is then again added to the new block, which will be block 1, 2, 3, 4, and certain like it a sequence of blocks on the blockchain is the number of block. The first ever block created is at block height 0. In some blockchains they term at once, but in Bitcoin it can be 0. Each block added on top has one position higher in the block, so it increases sequentially. So like 1, 2, 3, 4, 5. It is also not a part of blocks data structure, because it's just a number that is stored on the block itself. Not stored on the block, but on the blockchain itself, just to give an information. Each node dynamically identifies a block's height in the blockchain. Yeah, so that is what a block header hash is and block height is. Now let's come to this Merkle trees. What exactly a Merkle tree is. So you see, also known as a binary hash tree, this is a concept of uh, data structures and algorithms, and this is a binary hash tree which shows the hash of every particular transaction stored on the block itself. Our data structure uses summarizing and verifying the integrity of large sets of data. So it basically summarizes for you the transaction information and verifies the integrity of the transaction that is stored in the block. Contains cryptographic hashes. So these are the hashes that will be identified inside the Merkle tree itself, displayed upside down with the root at the top and the leaves at the bottom. So it is working like this is the top hash, and the leaves of it is actually the transactions that is inside of the network itself. A block of one or more records is collected, and such records are then hashed. So it is then hashed twice actually to store inside the network itself. Hashes are then paired and paired again and hashed again until a single hash remains. So it keeps on doing till until there's only one single hash remaining at the end. So the single hash is called the Merkle root or the Merkle tree of a transaction. So every transaction is keeps on getting like collectible, and one particular hash is formed. It is kept on hashing of every transaction until one particular hash is left, and that particular hash will be put it out in the block, which is like here. So every transaction will have a every transaction will have a hash, and it will keep on getting hash, like one or two these hashes, and until only one hash is remaining, which will be kept here. So that is what a Merkle tree is. So even if like one transaction is changed here, the root is like completely different from what hash has been produced. So if a one transaction changes, this completely root tree will be changed. Advantages of a Merkle tree. Merkle tree provides proofs are and management require only a very small and terse amount of information to be transmitted across the networks. The major advantage is a tree is constructed by hashing paired data, that is a lease that you saw here, and the repeated pairing and hashing until a single hash remains. So it keeps on hashing the transaction IDs until one a hash is remained, and that will be resulted in Merkle root. In Bitcoin, leases are the most almost always transactions from a single block. Merkle trees require little memory disk space and proof are computationally easy and fast. So since every transaction has been reduced to one particular hash itself, so that will be using one small very little space instead of a large amount of data sets that are be stored as a transaction on top of blockchain network. Blockchain trees of even number of transactions. In this example shown, the Merkle tree consists of even number of transactions. So blocks number 6 plus combined values of A, B, C, D, these value, plus timestamp and nonce is actually the block 7's identity itself. So these transactions are hashed to get this value, transaction A and B hash value, and then again it is hash A and B, A, B, C, D to get one particular Merkle root. The Merkle root of odd transaction, let's suppose that there are odd number of transactions in a block. So in this case, the last transaction is hashed by itself. So if you see this, it is easy for people to, you say suppose AB can be hashed together to form there are 4 transactions, A, B, C, D. AB will be hashed together to form one transaction. CD will be hashed to one from transaction. Then it is these all are these transactions are then again hashed. So it is easy for Merkle tree to get the hash. But in here we have 7 like transactions, I suppose. So this in last this will be hashed. The transaction will be hashed by itself to create an hash of the transaction itself. So it's like 0, 1, 2, 3. 0, 1 is hashed to become 0, 1. 2, 3 TSA, and 4, 5 is hashed with together, but 6 is hashed twice. So 6 will be here hashed twice. So then again this hashing will be again done 0, 1 with 1 this 2, 3 again. So it will be 0, 1, 2, 3 will be the hash. 4, 5 is 1 and 6 is 1, so hash will be like 4, 5, 6, and then the last will be the 0, 1, 2, 3, 4, 5, 6 will be the last and final hash of that particular Merkle root. So this is how the Merkle trees are done when the leaves are in odd number or when the leaves are in the even number itself. So this is an illustration of again a block. This are the block number, previous hash, timestamp, transaction root, actually Merkle root, and the nonce. And these we saw that everything is stored in the form of hash, so keeps on hashing until one particular hash is left, and that is also stored inside the block header. And nonce is number only once, that is just a random generated number inside a blockchain. Algorithm, as we have seen widely, encryption algorithm in the blockchain technology, this is diagrammatic representation. You create a digital message of sending $500. It will be enciphered by the public key encryption, and the communication channel, which you can be like an Ethereum network or any other network, and then it will be sent out to that particular person. He will include the decryption key, which can be the private key, and encrypt or decrypt all the data which has been sent by this particular person on top of the network itself. See, we now have a public key and private key and a method for encrypting and decrypting with those keys. Let's see an example to clear the details. There are different approaches used in attacking the RSA algorithm. So one can be brute force. Brute force is nothing but keep on guessing until you get that particular set of secret keys that can be used to encrypt or decrypt the data. So it's like you just keep on guessing what exactly the possible value combinations are. Second is the mathematical attacks. In mathematical attacks, we are using different techniques which are similar in effort to factoring the product of two primes. So these are also some kind of attacks that can happen to question the security of RSA. So let's talk about now consensus algorithms. So consensus is provides like the technical infrastructure layer for blockchains. This makes it one of the more critical components when seeing assessing real world use cases. Consensus is key because without central authority, the participants have to agree on the rules and how to apply them. So that is actually important, because if there is no central authority, everyone has to come to one unanimous decision, and that unanimous decision can be achieved using these consensus algorithms. Consensus does two things. It ensures that the next block in the blockchain is the one and only version of truth. So it brings out to the with the certain set of rules that this is the correct block, and it will be the only block that will be added to the chain, and that particular thing can be only version of the truth that will be served to each and every peer on the blockchain ecosystem. It keeps powerful adversaries from detailing the system. So it keeps all these people with heavy resources, like heavy cryptography no heavy mining rigs and mining systems, to overtake the network. So it won't allow these attacks to happen. And one of the very famous attacks was the consensus can also be termed as the heart of blockchain. So initiate the transaction so it is avoids like few problems like double spending. Initiate the transaction, multiple parties can transact. The transactions are recorded in an into a network block and presented. And so this is like a block is broadcasted to the network, and validation is done via the consensus. The network of nodes validates and verifies via the consensus and confirms. Consensus is recorded and provide the basis of trust mechanisms, and once verified, the transactions becomes a part of the new block of the ledger, and the new block is then added to the existing blockchain, and the transaction is complete. So this is like a flow of the transaction with respect to consensus algorithms coming into play inside the blockchain network. So what is the need of consensus in a blockchain? We already know that there's no central authority, so to make a unanimous decision, a consensus is required. So we'll see what exactly they have. So one is basic acceptance of law, rules, and norms to decide a transaction, which is like a one source of truth only. Common acceptance of industries and institutions that can apply these laws and rules. The need for the consensus. So, what are the basic parameters of consensus mechanism? So, First is to achieve decentralization. Decentralized mechanism, a single central authority must not provide the transaction decision finality. So everyone should be providing their input, and according to that, the decision is to be made the transaction is genuine or not. Second, quorum architecture. Nodes exchange messages in a predefined mechanism, so which may include the stages or tiers. So then it achieves the quorum actually. Uh, Third parameter is validation. So the process provides means to verify participants' identities. That means the transaction is actually a legitimate person, and there's no malicious activity happening over there to make sure that the transactions are validated properly. Integrity, it enforces the authentication of the transaction integrity and validity. So that is the again a parameter of consensus mechanism. Non-cancellation and confidentiality. This provides means to verify that the supposed sender really sent the message. So it's like no third person has initiated the transaction on behalf of the particular sender until unless he has provided the access. So then it means that it is a genuine person and has initiated the transaction over the network itself. So fault endurance, the network operates efficiently and quickly even if some nodes fail or are slow. So there might be chances that some nodes get corrupt and they die. So in that case, it makes sure that the consensus still is achieved with other nodes that are active on the network itself. Fulfillment, it considers throughput, liveliness, and latency. So these are the three things that it fulfills to make sure the consensus is achieved over the network itself. So let's see the consensus history. So we have this Byzantine general problem. The Byzantine army completely encircles the city, as you can see in the image. The army has the many divisions, and each division has a general. So if you can see, every division is there inside the picture itself, and every division will have a certain general which will have certain followers as well. So general communicates between each others as well as between all lieutenants with their division only through messengers. So they'll be communicating with each lieutenants will be communicating with the generals, and yeah, so these is a concept of basically a master slave. So generals can be also defined as masters, and lieutenants also can be termed as slaves. So whatever the communication they have given out the masters, the slave always have to obey them, and that will be only in the form of messages only. So moving ahead, all the general and commanders have to agree upon one of the two plan of actions, and the exact time to attack are all at once, or if faced by fierce resistance, then the time to retreat all at once. The army cannot hold on forever. If the attack or retreat is without full strength, then it means only one thing: an unacceptable, brutal defeat. So when this part comes in, it is like whatever plan of action is there, everyone has to be agreeing to that particular order. Otherwise, this the whatever the plan of action is or plan of attack is will not be viable or will not be implemented as planned, which will then means that it can be either successful or fail, but mostly it will fail. So when it fails, it means that it will be hacked, and this particular infrastructure that has been created will be obsolete and will be deleted. So if all generals and messengers were trustworthy, then it is a very simple solution. So that it means that if everyone is sincere to what their duty has been assigned, the plan will execute it as planned, and will be a definite win. But if not implemented successfully or not communicated properly, then it might be a failure. However, some of the messengers and even few general commanders are traitors. So that results in no solution exists if less than or equal to 2-3 generals are loyal. So this is like something, if the generals of each division are not say suppose act as a malicious peer on the node itself, so that means they will not follow the order, and if they will not follow the order, the plan won't be executed properly, and it will be considered as a fail, and these traitors will win the network uh, over the network. So to eradicate this problem, we have this general consensus agreement of two. If in the network there are three generals, if two agree on that particular information and execution, then it will be considered as the a general agreement over the network, and third automatically has to obey by hook or crook to the decisions that are made by the other two generals. So that is what consensus also mean, to agree on to a certain percentage of certain percentage of people agreeing on certain information to make it as a source of truth.
Who created Bitcoin? Option A, Satoshi Nakamoto, a mysterious figure whose identity remains unknown. Option B, a group of computer scientists at MIT. Option C, Elon Musk, the CEO of Tesla and SpaceX. Or option D, the United States government.
Just a quick info guys, Intellipaat offers you a blockchain certification course which will help you become an expert in distributed ledger technology, Ethereum, Solidity program and many more. Through this course, you will also receive additional courses co-created with IBM, namely IBM Blockchain Foundational Developer, and deploy a web-based blockchain insurance application. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description. Without a doubt, this course can set your careers to a new height. So visit the course page link given in the description below and take the first step towards career growth with the blockchain tech stack.
Is what we learn from this problem, Byzantine general problem. So the solution to Byzantine general problem is practical. The practical Byzantine fault tolerance algorithm, which is used to establish consensus in blockchain system, is only one of those potential solutions. So the solution of PBFT was introduced to us in 1999, where the person named Miguel Castro and Barbara Liskov introduced the PBFT algorithm. PBFT can process an enormous number of direct peer-to-peer messages with minimal latency. And how does it work is we have one asynchronous distributed system where nodes are connected by a network, and this Byzantine fault or a failure model is actually a faulty nodes behave arbitrarily, so it can work in a more random way. And in this we have independent node failure. So even if few of the nodes fail to respond to how the plan has to be executed, the minimum number of like 2 out of 3 people if agreed, then it will execute the order itself, and it will be considered as the consensus has been achieved, since these many number of people has been agreeing to the decision. If that particular decision has not been made, the transaction the process is then again repeated with a new master being elected by the network, and the same procedure repeats until you reach out the consensus on the network itself. So the third point is cryptographic techniques to prevent spoofing and replace and detect corrupted messages. So this makes sure that nothing malicious is happening, and everything is going according to the plan that has been written down by the or decided by the nodes in the network. So it is very strong adversary, and this method of established consensus requires less effort than other methods like proof of work, wherein you need a lot of resources, n number of resources, to solve that particular cryptographic puzzle to come down to the general agreement that okay, this particular transaction is being audited and happened over the network itself. So moving ahead, we have proof of stake. Proof of stake is a category of consensus algorithm for public blockchains that depend on validators' economic stake in the network. So, to implement proof of stake, every node who is on the network should have certain amount of tokens, and they should minimum deposit that number of tokens to participate of validation of blocks over the network itself. But sorry, but this can not these are not limited to the number of tokens a person wants to stake. If he stakes more, he has a more higher chances of getting the chance to validate a block on the blockchain itself. So say suppose a person named Jim has submitted like 32 number of Ethereum tokens on to become a validator, and there is also a person called Kevin who has submitted like 74 number of Ethereums to become a miner over the network itself to validate the block. So what the proof of stake says that the highest number of revenue, the person who invests in as a invest to become a validator will be chosen. So the person who has more tokens, like say Kevin, has a more higher chance to be selected as a blockchain validator miner, which will validate the transactions over the network itself. So it is proof of stake is a category of consensus algorithm for public blockchains that depend on validators' economic state in the network that we just understood and discussed. It is a new kind of consensus algorithm which was pioneered by Peercoin in 2011. Now there exist many versions of it, like NXT is using it, Tendermint is using it, Flying Fox is one, and your chance of being picked to create the next block depends on the fraction of coins in the system you own. So it's like the stake you implement, the number of stake you have on the network is the way you will be selected as a miner to mine the transactions on the upcoming blocks. A participant with nothing to lose has no reasons not to behave badly, and this is called nothing at stake problem. So yeah, so this also actually kind of maintains the integrity, so that miner actually knows that there are certain number of tokens being staked, and he cannot act maliciously or provide false information to their own benefit on the network itself. So that if that particular person acts maliciously, his tokens might be slashed over the network and will be also banned from the network itself. So that is the kind of advantage to it. And there we have proof of work versus proof of stake example, and not example but the difference. And how is it done? The probability of mining a block depends on the amount of work a miner does is what proof of work mechanism is, and stakeholders validate new blocks by utilizing the share of coins on the network that we just studied. The biggest disadvantage is to takes more energy than proof of stake. And the first example of proof of stake was Peercoin. And the proof of stake, the disadvantage for proof of stake is that the more you stake, the more better the chance you have to mine a block. It's like rich becomes richer, and that is the concept of proof of stake basically. One example is mining, which is computer cycle time to validate new transaction. Uh, that is the example of proof of work. And in proof of stake, a user would need to own a majority of all coins in order to attack the network. So if he has like 98% of Ethereum tokens, or maybe 52% of Ethereum tokens, then he will be able to easily attack the network itself. So it's just like majority of shareholders can take down the company, no? So that is the same thing in blockchain only as a proof of stake. We have this another consensus algorithm called POET, which is developed by Intel, and it's an alternative consensus protocol, which is also known as POET. A POET is a Nakamoto style consensus algorithm that is designed to be a production grade protocol. It is capable of by supporting large network of populations, so it can cater n number of populations when it comes to blockchain. POET relies on secure instruction execution to achieve the scaling benefits of a Nakamoto style consensus algorithm, without the power of consumption drawbacks of the proof of work algorithm. So it basically is similar to what proof of work is, but eradicating the major problem of power consumption. That is the only drawback of proof of algorithm. POET simulator provides POET style consensus on any type of hardware, including virtual cloud environment. So it can be achieved that as well. So example of POET is it is used in Hyperledger Sawtooth. So one of the Hyperledger Sawtooth is the umbrella technology under the Hyperledger umbrella, and yeah, so that is basically using the consensus algorithm as POET. And yeah. So what are the advantages of proof of elapsed time? The advantages are it is fair investment, it is fairness. So the function should be distributed leader election across the broadcast possible population of participants. And investment, the cost of controlling the leader election process must be proportional to the value gained from it. So how the number of money you get a reward, no, is actually should be less than the cost of controlling the leader election process, so that you can gain from it rather than losing of the money. Verification, it should be relatively simple for all participants to verify that the leader was legitimately selected. Public is like everyone has access to it. It is a decentralized, distributed, and public digital ledger that is used to record transactions across many computers, so that the record cannot be altered retroactively without the alteration of all subsequent blocks and the conclusion of the network. So it is like, in a nutshell, it is like a blockchain is like a publicly accessible to all. Anyone can read and append all the data, and there's no restrictions to it. And a few of the examples of these are Bitcoin, Ethereum, Dash, Factcom are the few examples of public blockchain. Whereas in a private blockchain network requires an invitation and must be validated either the network starter or by a set of rules in place of placed by the network starter. So private is like for a close group people who are there uh, for close group of people who are there who are there with an invitation. So it's like a healthcare system, and healthcare system has like uh, doctor records of patients, which is very critical information, and is not like few people are not comfortable with the availability of it to other providers. So that kind of solution can be derived on a private blockchain, wherein only with permission the information can be shared with other providers. So say suppose a patient is there, and patient wants to get his sciatic pains resolved. So the person he goes to, the doctor he goes to, is the neurologist. So to give the history of that particular patient, he needs to give access to that particular doctor itself, and no other doctor or other person will be able to access his medical history, which makes it a perfect solution as a on top of blockchain, as the healthcare system to be termed as a perfect solution on top of blockchain. Then comes consortium. So it is like controlled by a consortium members. Only predefined set of nodes have access to write the data or a block. So few of them are Ripple, R3, and Hyperledger can be an example for consortium, wherein only like persons like admin can give you the access over the network itself, or like they will have the access to read and write, but and rest can only view the data as well. So permission and permissionless blockchains. Properly permissioned blockchain network differ from unpermissioned blockchain networks solely based on the access control layer built into the blockchain nodes. So the way that they have given the permissions is the like, if it is open to all, it is a public permissionless blockchain. If it is closed to a group of individuals, it is permission blockchain. Since the network is open, anybody can participate in the contribute in the network, hence permissionless. Restrict the actors who can contribute to the consensus of the system state, hence permission. So this is the way you can say that these are the way it can be termed as permissionless or permission blockchain, which is like public and private blockchain. So here's a tabular representation of public or private blockchain access. Public, as we discussed, has access to all. Private is just like access to limited number of people. Speed of public is actually low because it has to cater n number of people, but in private it can be very fast because limited number of people, we know how they might be behave. And yeah, the security aspect of it is proof of work and proof of stake, so it has to be much more the security of it has to be much more complex than what we have in private. The reason being, any number of peer can be a communicate with the blockchain. So a malicious actor can be there, a normal person can be there. So we have to make sure that a general consensus is achieved, and everything remains security intact and auditable for the proper functioning of the public blockchain. But on the private, we know who the participants are and we know if they'll be malicious or not. So we have like certain read and write read and write sets which can be controlled by one particular person or the peers to either control the network or better functionality for the blockchain itself. Identity. So everyone in the public is anonymous. There's no need to show your identity. You just only have your address and you can just go through the public blockchains, where in the private is like pre-approved identities, and like who will be inside the network, and their identity is not anonymous as such. Then comes the asset. So what kind of asset public deal with? Public blockchains deal with is the native assets, like Ethereum having ETH, Bitcoin having BTC, and in private there's no native asset, because you are not building for a public network. So it's like Hyperledger won't be having any tokens, R3 Goda won't be having any tokens, MultiChain won't be having any tokens for to fuel the network itself. But on Ethereum and BTC, we might need these tokens, and the reason for being these tokens are the miners, because they will be given the rewards, right? So that rewards actually comes from these native tokens to fuel the network. So here are a few more examples. And permissionless uses mostly proof of work. Permissioned uses permission public uses this proof of stake. And so the more this diagram basically represents, the more the anonymity of validators is more of the public, and if you know the users on your network, it will be more of a federated or a private blockchain, wherein the trust in validators is like more when it comes to the private permission one, but in permissionless the trust is less, because any number of individual can come and join and start to interact with the blockchain itself. So these are a few of the, I think so, a consensus algorithm which you can read later on. And yeah, moving ahead, we'll understand the concept of sidechains. So sidechains are what? But separate blockchains which is connected to other blockchains through the use of two-way peg that allow transfer of digital coins or assets between blockchains at a fixed or a deterministic exchange rate. So what does it mean is, it is actually not inside a blockchain but a chain which is running in parallel to the network of blockchain, and it is actually used for uh, communicating between two digital assets. So one of the examples can be Polygon chain, which is built on top of Ethereum chain, and it works as a solution for implementing a fast scale blockchain, which is like an disadvantage of Ethereum. So whatever it wants to do, it is doing much more fastly with less gas implemented on the a side chain, and everything is mimicked on the same thing on the main blockchain itself. So this is what is a side chain, which is like everything happen in with different terms and conditions, but is actually pegged to what a main chain is, that is the Ethereum network. So few of the examples are these. Arbitrum can also be one. What do sidechains offer? Sidechain enhances blockchain's performance and privacy protections. So whatever the main chain is lacking behind is actually a solution offered by sidechains. Sidechains is any mechanisms that allow tokens from one blockchain to be securely used within a completely separate blockchains, but still move back on the original chain if necessary. The same thing that Polygon network has to offer. You can just go around with the Polygon network to have a better understanding what a sidechain is, and Arbitrum as well. These are like layer 2 solutions which are designed on the main chain itself, and which eradicates mostly which are actually designed to eradicate the problem of what main chain has to offer. Like majorly are the gas optimizations. Gas is like a fee over the network which is incurred by the transaction sender, and is given to the miner as well, besides the amount that he's sending. So that is the gas fees. So they reduce that, they make it much more fast, since public blockchains are slow, so they can much more fast by doing some scalable activities and so on and so forth. and side chains can have their other side chains for micropayment. So what, like say you want to transfer some amount of money to Polygon chain, so what you can do is you can just take it back, bridge it to the other network, do your operations, and then once your operations is finished on the better version of the main chain, you can come back to the Ethereum, because it has the reliability and security of it, but the performance of a new base machine, which is an updated version. Transfer of assets and sidechains. So Rootstock, as an example, to transfer assets from one chain to another, the following are the steps. So you can just follow on these 4 steps, and a user on the parent has to send their coins to a special output address. Coins will consequently become locked and spendable. So that will happen on the main blockchain. And after the transaction completes, SPV then confirms it across the chains. So these will be confirming on the other chain as well that the transaction has been completed, and will same amount of money will be sent to the other side chain. So after waiting out for a contest period, which is just a secondary method to help prevent double spending, the equivalent amount will be credited and spendable on the sidechain and vice versa. So once you have created a request, it will block your that amount of money on your main chain, and equivalent amount of money is sent to the side chain, and that will be credited and minted to you on your wallet, and you can do to perform your normal operations which you have just came in to work on. uh, Platforms for implementing blockchain. There are many types of platform which we use to implement blockchain. We have initially seen Hyperledger, Ethereum, and R3 Coda, and we have these other chain as well called MultiChain and Hydrochain. But I think so MultiChain is actually like not a chain that is being widely used now, but we have this Ethereum and Hyperledger as a main source of blockchain tools which are used to implement blockchain infrastructures. So we'll be learning more of this, and few of the examples are OpenChain, IBM Bluemix. These are the tools and technologies for implementing solutions on blockchains. IOTA being the one or helping you to create a DLT. It is a distributed ledger technologies. Yeah, you can also look into the slide and play around with these tools to have a look upon what they do. These are the few other examples as well. BigChainDB, open source system that starts with a big data distributed database and then adds blockchain characteristics, which are like the security and transparency, etc. And they offer like a decentralized control, immutability, and the transfer of digital assets. Sidechains are separate blockchains which is connected to other blockchains through the use of two-way peg that allows transfer of digital coins or assets between blockchains at a fixed or otherwise a deterministic exchange rate. So side chains are like a chain which is actually mimicking the exactly the main chain, and that particular main chain have some like of disadvantages, like say suppose we are working with Ethereum. So why is there a need of sidechain? The sidechain is actually built because there might be some kind of disadvantages or like limitations to the main chain itself. So what people do is people try to make a solution which is similar to what the main chain is, but is actually covering all its disadvantages, and those disadvantages are on the covered on the side chain. So let's say suppose what are the disadvantages if we wanted to see for one main chain, and if we want to say a main chain, we can say like Ethereum is a main chain and the side chain for it is Polygon, like we learned yesterday. So what are the exact limitations that Ethereum might have for which Polygon have been created? The first of them is expensive gas fees. So to transfer to transfer or make a transaction sent to a receiver, a person needs to provide some kind of gas fees, which is actually given to the miner as a reward. But this gas fees can vary from time to time and is dependent upon the congestion of the network. So say suppose if we have the congestion high, then these gas fees will be high, and these gas fees, if they are high, they will be charged more by the sender itself. So that was one of the limitations, that the expensive gas fees had to be incurred every time you have to pay for send a transaction to some person. Second of all, the transaction took a lot of time on Ethereum engine to get verified or validated on the network. So it would be like, say, suppose around 6 minutes, and the network becomes kind of slow and expensive to use, and it's not cost efficient. So people from this team of Mumbai had developed a side chain basically, which is a Polygon. So it is a chain that is exactly running parallel to the main chain, but the operations are much more smoother, much more faster, much more cost effective. So whatever the kind of operations you want to do on the main chain, you can do it similarly on the this Polygon chain as well. But the thing is, the chain needs to, why would they be shifting out to the Polygon chain when they have Ethereum chain and its security? Just because of transaction cost being less, and the gas fees is actually being expensive over there, is not exactly why they would shift. They need some kind of like, the essence of blockchain will be removed if they just swap out to Polygon and make it obsolete, make this Ethereum chain obsolete. So that was not a viable solution. To overcome this, what they did is they used the security of Ethereum, and they built on top of Ethereum itself. So now what is happening is these side chains are actually running in parallel, and to use those chains, what you need to do is you need to lock some kind of this ethers on the main chain itself, and you need to buy these Matic tokens, which is the Polygon's version of cryptocurrency. So similarly, in Ethereum you have Ether, Polygon has Matic, right? So if you purchase these Matic tokens, what will happen is you change your ethers in exchange of this Matic tokens. And once these Matic tokens are actually being purchased, what happens is those ethers get locked on that smart contract itself, and the equivalent amount of Matic will be transferred to you on your wallet itself. So now you are actually being transferred from one chain to another chain, and you can do all kind of operations which is similar to what Ethereum has, the security and everything, but it will now also include the lower gas fees and fast execution of transactions. So as soon as you complete all your operations and everything on Polygon, which is more or less the same, every syntax writing of the smart contract syntax is the same, the Polygon Explorer is actually the same, and all the other operations are also more or less the same. So you can do your thing or work on your this Polygon network, and use the same ERC20 address as well, which you will get from maybe you will generate it from MetaMask or any other wallet, and use it to connect with the Polygon chain. And once you are done, you can just go back with your Matic token and send it back to the Ethereum itself, the main chain itself. And at that time, whatever the amount of Matic tokens were given to you will be actually sent back to the contract or burnt, or and the equivalent amount of Ethereum you have, you will get from the Matic token itself. So that is basically the concept of sidechain. That you will have a chain which is exactly similar to what the main chain is, but it will actually be much more, covering all the merits of, covering all the demerits of the main chain itself. So yeah, that is what exactly the side chain is. And if you see, the side chain enhances blockchain's performance and privacy protections. The same thing that I was just telling you guys, and which and the rest of the things is actually the same itself. So I hope I made sense this time and you were clear, right? Okay, you understood. Thanks a lot. Okay. So now moving ahead, today's session we'll be starting to cover our module 3, which is the Bitcoin and blockchain. And yesterday, Ramakrishnan, we covered this delving into blockchain itself. So you can just go through the recording, and if you have any doubts related to it, you can send us on the mail given by the Intellipaat team, and we'll be getting back to you as soon as possible. Okay, so let's start with our third module, which is blockchain and Bitcoin. And okay, so I hope like everyone of you is now well aware of what blockchain is. And I know like mostly people will be aware about what Bitcoin is, but still we'll be understanding further more ahead. And if you guys like have like then we'll identify the features of blockchain itself and what exactly it has to offer with these blockchain technology, and why is the hype is there for this blockchain. We'll understand through the features that it has to offer. The third is define blockchain use cases in different domains. So where all has the blockchain shined and how is it working? Like why are people going crazy to develop a solution on blockchain? We'll just see that and understand all the use cases that are currently executed on blockchain itself. Next, we'll see what are the trends and understand if the blockchain jobs are actually suitable for you, or what kind of blockchain technology jobs are out there in the market. And according to that, you can just suit yourself and apply for them. Lastly, we will be seeing list all who all can go for blockchain technology jobs. So that will be the one module, and also we'll be covering this Bitcoin mining as well, which I think so is the part of it. What as per the time permits, we'll try to cover the most of the things in it. So starting with the session today, we'll start with what blockchain and Bitcoin are. So I think everyone has understood this definition as of now, that blockchain technology is the latest buzz in the industry today. Bitcoin is actually the implementation of blockchains. So that is exactly what we are trying to learn for the past two modules. And Bitcoin came into existence in the introduction of blockchain's white paper in October 2008, where the first time of white paper was actually shared with the public. And I hope like I've shared the white paper to you blocks linked and secured using cryptography. As we all know, as of now, that transactions are combined together inside a block, and block has different types of details which is actually chained together to create a blockchain itself. So we understood what are blockchains, but what is Bitcoin? So Bitcoin was the very first implementation of the cryptocurrency, and it was trying to resolve this issue of high transaction fees given by these guys. Maybe I think so, if I'm not wrong, but these guys were actually guy from Hawala, wherein people used to try a lot. Like it's a theory as of now in the market that Satoshi was very fed up with the guys ending out the money from one place to another using this Hawala money. So he tried to make a concept of a technology to eradicate this problem, and everything was you know built kept in mind with the similar use cases, but this has not yet been proved or given, but it was just a theory that this technology was actually kept in mind to make it easier for people to send out the money to anyone or any person on this planet, and you can send it via like in hardly maximum to maximum like 1 or 2 minutes, but the transaction confirmation will happen like after some time, because miners needs to mine that block, and as soon as the miners try to validate it, the first miner you will know gets the reward, but the other miners will also validate it, and there will be some amount of confirmations that will actually confirm that the transaction has been updated successfully on the blockchain, and it will not get reversed or reverted back to any person, or maybe it will not get cancelled because of low gas fees on the network. So make sure that if you guys are doing these, so you kept this things in mind. Okay, next point is uses cryptography and mathematical algorithms. As we all know that it has different cryptographies like Merkle hashing and SHA-256 and other cryptography algorithms as well, like RSA, working behind it to make it much more secure and eradicate all the vulnerabilities that are thrown by the malicious actors. Thirdly, we know that only 21 million bitcoins will only be ever created, and beyond that, no one can create the bitcoin until unless there is some kind of upgrade to it to the network, and they try to brute force it to make the network, or the network agrees to that, okay, we need more than 21 million bitcoins. So it is estimated that these 21 million bitcoins will be like this technology. The difficulty will be rise for solving the transactions and confirming the blocks on the blockchain, and miners actually will need to use a lot of resources, heavy computers, to actually solve those cryptographic algorithms to mine the block over the blockchain itself. Also, these rewards actually keeps on getting half on certain block numbers. So initially it was 50 bitcoins for solving, like confirming a block on the blockchain, but the process or the concept of halving happens on a certain number of blocks, and this keeps on reducing in half. So earlier it was 50, then it was just 25, then it was 12.5, now it is actually 6.25 for resolving the block on the blockchain, and the reward is around 6.25, which every miner will get. And obviously the value is actually the USD value is actually pegged to it, and it holds the value for like around, I think so, 26,000 or 27, which is a very famous website for tracking all the prices for every cryptocurrency. So you can see all the trending cryptocurrencies, and the number one has always been Bitcoin, and number two has been ETH. But these all can vary and depend upon the different the supply and demand, and the way it is performing on the network. It is actually ran according to that, right? So if you see, we have like $26,000 as of now for one Bitcoin. So if you want to sell, you can get this 26,566 on different exchanges, or maybe whatever the rate they have to offer. You can check different exchanges, because they have different prices for buy and sell on the network. And if you want to see it, you can also see that the price of these can be actually converted in INR itself. So if you just convert it to that, you can see this. The price has been changed from 26,000 to 22 lakhs 7,713. Yeah, so this is like a very useful and handy site you can uh, keep with you to check the prices if you're interested in trading or stuff like that. And held in the electronic so how is it held? It is held in the electronic distributed ledger. So bitcoins are not like it is present somewhere on the network itself. So we have the concept of UTXO, which is actually being converted to Bitcoin as soon as you make or send the transaction to a particular person. And these UTXO, we'll learn more about it on the future sessions, and understand what the how it is actually being generated, how the Bitcoin is actually being generated from the thin air itself. So what is blockchain? Blockchain is the technology behind Bitcoin. So we all know that Bitcoin is a use case of it, which is actually a cryptocurrency, but not the technology. And this has been using all these concepts and derived in a language called C and C++. And you can see so this is the actual coding behind it, and it uses this concepts of cryptography, C++, peer-to-peer, and cryptocurrencies. And this is actually the code for the Bitcoin core. And you can just clone it and try to see what all things are there. And if you want to contribute it, you can just raise a PR, and someone from the community might see it and approve it. And so, you are just actually contributing and doing the open source work on the Bitcoin technology itself. Next part is the features. So now we'll be delving into the features part of it, what exactly it has to offer, why is there such a hype around blockchain. So these are the few features of blockchain. First off is the hashing encryption. So as we all know, everything on blockchain is actually converted into hash and then gets stored. Everything is encrypted. Nothing is shown in like as it is format. Everything needs to be first encrypted, and then with these receiver, it needs to be decrypted with the keys they have. And once these are performed, these actions are performed, only then it will be secure, maintained as a secure network over the blockchain itself. Second feature is the distributed public ledger. So no single center, as we all know, there's no central authority, so there will be no single point of contact whom we need to get to if we have any troubles in the ledger itself. We will be like given out a copy to us of the ledger, and everyone can maintain that, and this keeps on working like on a like it keeps on getting updated on multi-second basis if you're connected to the internet, of course. And everyone will have the same values, everything the same with the people who are actually connected to the software as a node or a peer, right? Next features of blockchain is actually it's more specific to Bitcoin, but the features of blockchains may include the immutability, cause it is not actually changing the value, and it is only working on append only part, or the read or append only actually. So this becomes impossible for someone to actually rewrite or hack this blockchain itself. Proof of work is also one of the consensus algorithms that it has to make everyone understand, or help people to come on one particular decision itself, to maintain the stability in the network. And the last but not the least is incentives for validation. So miners are actually who are heavily investing on their resources of good computers will actually be rewarded with these tokens which have like values of around 22 lakhs for one Bitcoin itself, and they get around 6.25, which will be roughly around 1.2 CR, which is a lot for a particular miner to just confirm the transaction over the uh, network itself. But the thing is that there is a huge competition, and everyone needs to solve everyone is trying to run a race of solving the mathematical problems to confirm the block over the blockchain itself. So these are the actually core features of blockchain. And when I say blockchain, it is actually focusing on the Bitcoin blockchain itself. So whatever like we are actually going to learn is around Bitcoin, Ethereum, and multi-chain itself, because these are the most popular ones, and every other blockchains might be different, slightly different, but mostly the concepts will be core around the Bitcoin itself, as I previously mentioned. So, what are the blockchain use cases, and how industries are using blockchain that will disrupt, these trends and everything around the technology? First is the financial services. So, as you see, the Bitcoin being the biggest example of financial services, these are like ways you can do your sending or receiving or the transaction, doing trading or some stuff around it. But if you want to like build around these exchanges also, which will be like, say suppose mimicking exactly what these stock markets are doing or something like that, then we have also solution on other blockchain which is called Ethereum, and they have these decentralized exchanges which provide these financial services on top of blockchain itself. But also, if you have like these ideas, certain ideas you want to give, like say suppose you want to we want to create a cryptocurrency which will be acting like a mutual fund, so you can do it easily on top of Ethereum or maybe a Polygon network, so that it is much more faster and much more easier to do with less transaction fees. So you can create some kind of concept of these mutual funds or any kind of other financial services that are present on the current system. You can just try to implement it on the just blockchain system itself. Moving ahead, voting part. So voting, as we all know, like is the most scrutinized part, wherein people tend to claim other people on cheat and being a cheat for adding more voting power to them, or doing like some kind of a manipulation on the EVs, so on and so forth. There are like solutions as of now who are trying to do these voting on blockchain itself, so that it becomes very fair and square for every individual. And since it has the capability of being transparent over the network, everyone could view who is voting, how many votes are there, and you won't be able to identify who is voting. But if you know the address, whose address is what, then you will be only to able to identify. Otherwise it would be very difficult to make sure who is. So it maintains that identity, but it is actually pseudonymous or anonymous basically for every other individual on the network itself. Then moving ahead, real estate. So you can then again create like few of the smart contracts, wherein you can mention that the smart contract will be considered holding all these money you wanted to transfer to your renter, and the rentee can just add the money on this smart contract. And once everything is okay and he's satisfied with the stuff, then he can be able to he can be make it sent to the this particular person who is a landlord. And vice versa, it is same that landlord is actually scared that the person who is renting his house won't be able to pay the money. So it is actually like an security for him as well, because the money is inside these smart contracts, and as soon as the terms and conditions are met, they would be transferring out, or like automatically transferring out the money from the person who is renting it to the person who is the landlord itself. So it's actually a very good use case, and currently our Indian government is also doing something around real estate. They are trying to put all the registries of the properties and everything on the blockchain itself, wherein no one can actually do a fraud, that they are trying to overpower the other person and try to take their property with fraud or other kinds of scams. So it will actually solve, this technology will actually solve those parts as well. Moving ahead, music streaming. So it is a very important use cases where people can uh, show, like digital creators can showcase their talents and get digital assets instead of that. And these streaming apps are actually very valuable since, I think so, the afters of 2012 to 13, wherein these applications were coming into the picture. So you can build a solution on top of blockchain itself, so wherein if you are consuming the digital message or asset created by the creator, then you need to be paying all these tokens or maybe some kind of royalty given to him, wherein everything is fair and square and no big whales like maybe TCs or Sony Music Entertainment can come and steal their money from them and not paying them. So that can be one of the important use cases that blockchain can solve. Moving in, supply chain and management. So it is a like very famous use cases that blockchain is actually solving, and people are trying to trace a single product from the farm to the consumer's plate, wherein every information is actually getting updated on the blockchain, and everyone has these information where the product has been and how it has been transferred to you from the farm to the field, and how much, also like if they have these parameters like how much money they bought them. So that can also be added, but it totally depends on the person who is actually creating the blockchain and trying to trace all the supply chain and management itself. So it will be easier for people to trace the product, and human errors will actually be very you know converted to minimalistic, so that people will be able to automate these stuff and make these things happen easily on blockchain itself. So what are the industries like in financials? Barclays and Nasdaq are like the pioneers who are trying to uh, make their first trade transaction using blockchain, and Nasdaq is also will soon run the blockchain trading. But these things have currently evolved, and for this financial services, this thing called Uniswap has been made, which is actually the protocol on top of Ethereum blockchain, and it provides its very different financial services where you can swap the tokens, you can purchase the tokens, you can even buy these tokens with the help of these pools and mining and do stuff with that. So if you want to see, you can explore these things as well. You can buy these NFTs also, which are trending, and seeing how what all uh, NFTs are there in the market, which is similar to what Coin Market Cap is doing. So we can see that Mutant Ape Yacht Club is actually the most trending NFT, which is actually has a floor value of 4.82 ETH. So if you want to see, you can just fool around with this, and it will be actually a good thing for you to understand the financial aspects of what blockchain can be. Voting, we have seen that Estonia is actually a small Baltic nation which has implemented the blockchain based e-voting system. And followmyvote.com, you can visit the website to see the first open source online voting solution based on blockchain. So These are the two major things who people who are actually disrupting the industry by implementing these solutions. So yeah, you can go with this. You can check this out. Yeah. So real estate, like blockchain solves the issue of huge paperwork and high agent fees, is actually a good problem that it will eradicate. And Ubiquity is like the first enterprise ready blockchain secure platform which can be used to manage and track and transfer land titles and property deeds. So these guys have implemented the solution on top of blockchain itself, so you can visit them and see how they are doing and just try to maybe play around with it, so you'll have a good understanding of these particular use case, how blockchain technology is getting implemented on it. Music stream. So yeah, as we all know, artists lose up to 86% of the proceeds from their music because of illegal downloading. Because that is the most uh, common issue that digital artists face. That their songs, as soon as they get released, people tend to just copy it and paste it on their websites, and you can just download it with certain few clicks. And these people won't be getting all this money and getting paid for what they have created, or cost they have incurred to produce those music. So yeah, so blockchain will actually eradicate the problem, and won't be will be issuing all these challenges on these streaming apps. Like these Mycelia is a blockchain based platform for artists to sell their work directly to customers. So people who are interested in listening to one particular music can just pay some amount of tokens and listen to their or consume their digital asset produced by a music artist. Supply chain and management. So middlemen in supply chain takes time, add cost, and make mistakes very often. So as we all know, like if you keep on adding a human to a chain, then there are chances that it can be qualifying for the human made error, or maybe like they are not trying to upload the data correctly onto the platform they have built upon. But blockchain will actually solve these things, and will also be reducing these costs, because the middleman will actually be removed from the blockchain itself, which is actually a forte of blockchain. So provenance is one kind of platform which facilitates transfer and transferable trade through the deployment of the blockchain technology. So if you want to see, these are the actually good examples given in this PPT for every use cases that blockchain is disrupting. So blockchain job trends. So as we can see, these data are little like old, but currently also people in this technology are actually in demand, and people are trying to switch to this high-end technologies like AI, ML, and blockchain to have good pay scale and learn more about it. So these are the futures, and I would suggest everyone to actually learn it, because now or in the future, the people will be actually moving to these technologies. And so since this being a future, everyone needs to move it by either will or non will. So yeah. So in like for the data that has been shared by with us, it is actually seen that job posting for the blockchain actually increased by 0.5% within the span of just 2 years, and it was in huge demand, and every other company is actually seeking for blockchain developers or maybe blockchain analysts or researchers, because since this technology is actually on a nascent stage, there are huge demands of researchers, wherein people pay job seekers to see what if the solution can be derived, or create a POC around it to have an understanding if the solution is viable or not. So yeah, blockchain researchers are also in very demand. Yeah. So what are the salary trends? On average, blockchain salaries are 40 to 50% higher than majority of job profiles. Actually, I would say it depends upon how much skills do you have, like what all things do you have you learn, and according to that you will be given out the pay. But mostly, like, it is actually higher than what other engineers are offer, or other fellow researchers or analysts are offered. Like, it is like, since the technology is in trending and people don't know much about it, so they tend to find people who have an expertise on it, and you can be one of them if you learn thoroughly about what blockchain is. Similar trends exist on across geographies, that is in US, India. So everything you can see is actually starts from the US and or Japan maybe. So those people are actually have these huge demands of blockchain guys who have an expertise of how these things work in this technology. So who should go for this role? So this is a very common question that people who are seeking to learn blockchain have, like who should learn it, why should we learn it, and so on and so forth. So who should go for these roles? So if you see this plateau works, so this has like opening for a blockchain developer, and people say that if you are a cloud professional, you can apply for this job. But obviously you need to have the this knowledge about Ethereum, MultiChain, Hyperledger, or Ripple. You actually, to clear an interview, you need to have the theoretical information of how these technologies are working in behind the scenes, and how these technologies are helping to create different blockchains or blockchain solutions around it. So yeah, so theoretical part is must for every job opening. And since if you're applying for blockchain developer, you should have the understanding of the core concepts of it. And when I say core concepts, you need to understand the proper working of what Bitcoin is, because most of them use the same concepts around different blockchains as well. Moving at experience with working with Node.js, Python, Go, Rust, and JS. So I think so. Sham was asking what exactly is a prerequisite. So if you want to become a blockchain developer, I think so. These are the four languages that are widely being used in blockchain. So if you have like little bit of understanding of it, or maybe understand how to write the general syntax of it, I think so you'll be fine. Because writing down this as a core blockchain developer, you need to write down the smart contracts, for which you need to learn Solidity, which is very similar to what a Node.js or JS has to offer. So even if you have like understanding of one programming language, that might be more than sufficient. But if you have like understanding of JS, then you might be having an edge over the others, because everything has more or less the same concepts related to Node.js or JS. Yeah. So comfortable working with, yeah. So SQL and NoSQL is why there can be options. So knowledge of cloud infrastructure technology such as AWS, Google Clouds, Microsoft Azure. So these are like in huge demands as of now, because when you try to create an infrastructure, no, so you need to create on some kind of these cloud platforms. So AWS, Azure, or Google Cloud being the pioneers in it, people tend to find people who have understanding on how to handle these platform, and these platform actually tend to have different, like, n number of millions of features in it, like CI/CD pipelines you can create. You need to, how do you manage those virtual machines, the SQSS data, the RabbitMQ, the messaging services, and obviously the database, the SQL and NoSQL databases. So these are the one of the important things you need to have maybe uh, beforehand. Then it will be good. Otherwise, yeah. So you can learn it as and when you are doing this, if you can convince them comfortable with Linux and have a good understanding of OS internal. So every developer is actually working upon Linux, because mostly the things don't work around Windows, but Linux or Mac works fine for the blockchain developer. So if you are using these machines, or if you have these machines, so it is very widely available, and a lot of forums and communities work around with these Mac and Linux. So every solution you can see on this like Stack Overflow or different other forums will be related to people working around this Linux operating system as well. So this is one another role for blockchain architect given by architect. So you see these are the prerequisites for them, and if you qualify like even like 60 to 70% of them, I think so they will be able to get you hired you in their company itself. Mining of Bitcoin is our moving ahead. We'll see the economics of Bitcoin, and let's start before like we get into these details. Let's consider these economics of Bitcoin, and these are the six actually important parts of wherein we define the economics of Bitcoin. The first one is Bitcoin is stamped after the creation of each block at a settled and a reducing rate. So every Bitcoin is created when the block is mined, and whatever is the rate of according to price and supply and demand is actually being predicted or being shown on different websites itself. And it the second point is for each 210,000 blockchain blocks, or roughly every 4 years, the money issuance rate is diminished by half in the Bitcoin ecosystem. So this is the concept of halving, wherein every 4 years, or like every 210,000 blocks, whichever comes first, the money issuance rate is diminished by half. So earlier in the starting it was 50, then it will go down to 25, then it will go down to 6.25, and in next and 210,000 blocks it will go down to whatever the half of 6.25 is. So yeah, so that will be the amount that or the rewards that the miners will be getting for this solving this blocks on the blockchain itself. For the first 4 years of Bitcoin operation, each block contains 50 new Bitcoin. So whenever people used to confirm the blocks on the blockchain, they were used to get 50 Bitcoins, as we just learned before on the initial days of Bitcoin launching itself. Then the fourth part is the rate of new coins diminishes exponentially more than 64. So like only 64 holdings will be done until we get to the number of 13,230,000. Mined will be like that particular blocks will be actually mined till the year 2140, and it has been calculated by these group of people or one particular person, Satoshi Nakamoto, making all the calculated moves till the year which is like roughly 110 years from today. And it has all these code written behind it, and you can just check out the code given by me earlier of the GitHub and other Bitcoin paper as well, if you want to have a little bit of understanding by yourself at your as an assignment. So when it achieves the base cash unit of 1 Satoshi, so 1 Satoshi is about 100 million, as we actually didn't check out. You guys were able to see, but one Bitcoin contains of 100 million Satoshi, and that is the minimal unit present for the Bitcoin itself. That is minimum denomination, sorry, present for Bitcoin as of now. It cannot be further divisible, and that is like similarly in rupee we have like 1 paisa and cannot be divided further ahead. In similarly in Bitcoin it is 1 Satoshi. Finally, after nearing to about 13.44 million blocks in approximately 2140, almost this number of satoshis, or sorry, this number of satoshis, or almost 21 million bitcoins will be issued. So you see how many bitcoins, like how many satoshis will be generated. So it's like, anyone wants to take a guess for this? So moving ahead, thereafter, blocks will contain no new bitcoins, and miners will be rewarded solely through the transaction fees. So since there will be no new like rewards, there will be no new bitcoins getting generated, and miners will actually be getting, rewarded on the basis of what the transaction fees has been given by the sender over the network itself to mine the transaction. So this is the economy or supply of Bitcoin. Supply of Bitcoin currency over time based on a geometrical decreasing issuance rate. So it will actually, as the time progresses or we moved into the further years, it will actually start to go on a flat rate. This flat rate wherein everything will be created according to the decreasing issuance rate, and the limited and the decreasing supply and issuing rate makes a settled financial supply that opposes expansion. So since these are like in limited in number, it might increase the value of it, since since every uh, thing in limited number is actually a valuable thing, and it gets appreciated over the period of time. So it is stated by financial experts that Bitcoin will try to achieve an amount of 1 million or 100,000, sorry, 1 million by like 2030. But we are not sure, but it's just a prediction of it, and over the trend of tenure, it might increase to 100 million for one Bitcoin. As of now, it is just 26,000, but it has actually seen the inflation of till 60,000, and people have earned a lot of these Bitcoin by selling and buying at these rates itself. And currently they are holding, but yeah, so these are the ways that people tend to invest in it and are currently working around it with this itself. So different from fiat money, which can be imprinted in an unending numbers by a national bank, Bitcoin can never be swelled by printing. So we all know that current systems where banks can generate n number of amount of fiat currencies, and which can cause different issues with the current system, but they don't tend to resolve it. So that is like a major problem also, and but in case of Bitcoin, that cannot be done, because everything has been calculated and written in the form of code, and everything is actually working in an auto like pilot mode, wherein everything will be happening according to the calculations made by these developers or this particular person called Satoshi Nakamoto. So since Satoshi is actually not known, but they have given out like this picture of Satoshi Nakamoto. He is like the guy claiming that he's a Satoshi Nakamoto person, but we are not sure upon that. It is not proved till now, because people also believe that it cannot, like, single person cannot write such code and with such sophistication of calculations. So they tend to think that it is a group of people, but we don't technically know about it. And also, do you know a fun fact that as of now, this Satoshi Nakamoto has like roughly around 50,000 bitcoins in his account as well, which is like equivalent to maybe, I'm not sure what exactly will be that value, but it is lot for now. So he has like pre-mined these Bitcoin tokens when he created this Genesis block, itself. So how do we mine or slash create bitcoins? So as we know that bitcoins only get created when some person tries to verify the block, and the reward that has been created will only be the way to create these bitcoins and make it circulated over the network itself. Bitcoin mining, brief note. So, what exactly Bitcoin mining is, the definition we'll just see. So, Bitcoin mining is a process of adding transaction records to Bitcoin's public ledger of past transactions or blockchain. So, this is, as we all know, just a process of carefully adding these blocks by resolving all these cryptographic puzzles by the use of heavy GPUs and other machineries as well. The ledger of past transaction is called the blockchain, as it is the chain of blocks. So we have also seen that how blocks are getting generated, how they are linked to make a chain, and how what is the longest chain rule, and so on and so forth. So the blockchain reserve serves the to confirm transactions to the rest of the network as having taken place. So these miners are actually responsible to make sure that the confirmed transactions are all, like, a copy of the ledger, updated ledger has been sent to everyone over the network, so that everyone is actually on the same page itself. And behind the scenes, you know that all these consensus algorithms work to make sure that everyone who receives a ledger, because everyone won't be receiving it in the same order, it will be given to them in a chronological order. So to come to a basic unanimous decision, or like a general agreement, these consensus algorithms works to make sure that everyone gets onto the same page itself. So, what are the types of Bitcoin mining? So, there are basically two types of mining. One is solo mining. Solo mining is like you are completely on your own one man army. You will just start to run on your software with your GPUs and your Antminer machines, and you will be starting to solve these or resolve these cryptographic algorithms to get these rewards. So miners endeavor to produce new blocks all alone, with the return from the reward and the transaction expenses going all together to himself. So whatever amount of uh, expenses he'll generate for the internet, for the electricity, for the purchases of resources, it will be at the end all going to him, the rewards to his particular address, and he can do whatever he wants with the Bitcoin. He can either sell it, or he might want to hold it and sell it in the future when the price gets inflated. Yeah, so that's totally upon him. But the concept of solo mining is that every person is an individual, and he's trying to this confirm the block over the blockchain, either by these machines or maybe his laptop or whatever it is. This enables miners to receive extensive payment with higher variance, a longer time between the payments. So there is actually, since there's no other partners or any other miners, so it won't be divided with any other person. So everything is given to him. Every resource is for him. So it is like a very lucrative deal if you are a solo miner, but it is actually also a very expensive thing to do to become a solar miner, because it requires a lot of capital uh, to get invest to start to earn in today's date. But if you were doing these in back in maybe say 10 years or like 10, 12 years, so it will be like very easy for you to mine, and you can just use your laptops or maybe any other uh, PC or node to verify the block over the blockchain itself. So there's also other type is called pooled mining. As we understand by the name, pooled mining is actually miner pools deploy different miner workers to discover blocks uh, the all the more regularly, with the returns being shared among them in rough correlation to measure of hashing powers they have contributed. So what does this mean is, like, the amount of resources you add to that particular pool is the way you will be getting the percentage of share when the Bitcoin is mined. So if you provide a strong GPU which is able to resolve, which is able to power 50% of the pool, so you will be given out like 50% at the payout when the transaction is confirmed by that particular pool itself. So there are a lot of people who are trying to do it, and they just put in their PCs or maybe their the virtual machines from these clouds like AWS Azure to make sure that the transactions are actually getting mined with their computation power. Yeah, so this enables each miner to receive small payments with lower variance, so a shorter time between payments. So people tend, like, once they get the rewards, they tend to share them according to the percentages of resources they have allocated. Let's first understand the working of solo miners, how solo miners are doing it. So Bitcoin consensus algorithm allows for the creation of new Bitcoins by the process of mining. As we all know that these are
What is the main purpose of Bitcoin mining? Option A. To create new Bitcoins and distribute them into circulation. Option B. To verify and validate transactions on the Bitcoin network. Option C. To earn rewards for providing computing power and ensuring network security. Or option D. All of the above.
Just a quick info guys, Intellipaat offers you a blockchain certification course which will help you become an expert in distributed ledger technology, Ethereum, Solidity program and many more. Through this course, you will also receive additional courses co-created with IBM, namely IBM Blockchain Foundational Developer, and deploy a web-based blockchain insurance application. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description. Without a doubt, this course can set your careers to a new height. So visit the course page link given in the description below and take the first step towards career growth with the blockchain tech stack.
the way consensus algorithms are the way we understand how the mining will work. So in proof of work, as we all know, we'll just show the power of our resources, and in this other this consensus algorithm called proof of stake, wherein we'll just showcase the power of our the stakes that we put into the blockchain network, and according to that we'll be selected to mine the transaction. In that, you can, it doesn't matter what kind of machines do you use, but it actually uh, like matters how much amount of money you are willing to put to become a validator or a miner on that particular blockchain. But of course, like, you cannot put in like these, say, suppose 72 ethers or maybe 32 bitcoins over the network and just try to solve it with a laptop, because that would actually work for that as well, because you need to have a certain amount of power to be able to solve that cryptographic algorithm and mine that particular block over the blockchain itself. So yeah, so it's like these are the consensus algorithm on in a nutshell, which we need to which will help us to mine a block over the blockchain, and according to rules we can do so. So what are the four things we can see here? So autonomous check for every transaction, so everything is autonomous, so everything will work in these four steps as well. So proof of work algorithm comes into play when it comes to Bitcoin, and everyone will work according to that particular showcase the power of the resources and try to mine the block itself. Third is the confirmation. So as soon as they get confirmed, blocks confirm on the blockchain, you get the number of confirmations by other miners, and as and when you get lot more confirmations, you get the rewards accordingly. So independent aggregation. So there's no other miner working with you, so you don't need to share a cut with other people, and you are solely on your own, and you can do whatever you want to do with your Bitcoin. But since this is like a very expensive thing, I would say, because that requires a lot of uh, uh, these GPUs and these machineries costs, and other parts as well, like electricity and internet not being so much in India, but in abroad also, it is actually a very expensive thing to afford an internet in some places. And electricity is yet most more or less the same everywhere, expensive basically, because these machineries actually use heavy consumption of electricity, and these resources tend to use a lot of electricity to just mine a particular transaction. So it is actually, we have these calculators also if we invest in. So mostly people use ant miners, but you can use whatever you can think is the most powerful one. Also, in the previous lectures, I've shown you what where you can buy these ant miners and their website itself. So autonomous verification of transactions. So the firstly autonomous check of every transaction by each full node in the light of an extensive rundown of criteria. So this if you are connected to the Bitcoin and you want to act as a miner, you have to make sure that you are made as working in a working as a full node, and the node being the your computer itself. And we learn further ahead what exactly full node and other types of nodes are there. But for now, you can just understand that every check are made for this transactions by each full node to make sure that a person is actually doing the right thing on over the network or not. Independent aggregation of those transactions into new block by mining nodes combined with the exhibited calculation through a proof of work algorithm. So every node is actually independent and aggregating these transactions into the blocks by combining these transactions with the exhibited calculation through this proof of work algorithms with these proof of work nodes, by showcasing the obviously the power and the resources that are used to mine over the network. Thirdly, independent confirmations of new blocks by each nodes and getting together into a chain. So everywhere you will be independent. You don't need to be dependent on any other uh, miner to confirm the transaction. Independent selection by every node of the chain with the most cumulative consumption computation demonstrated through the proof of work. So you have the freedom of making the independent selections, and you are not limited to get in decision by your unanimous decision with the other miners as well. Independent verification of transactions. So let's say Andy initiates a transaction of 5 BTC to Bob in this network. So as you can see, this is a diagrammatic representation wherein a node A is trying to send out 5 BTC to B, and everyone is getting updated with that. So before sending transactions to its neighbor, each Bitcoin node that gets the transaction will at first confirm the transaction. So they will just make sure that everyone that this guy has actually made the transaction, has initiated the transaction, which will make sure that that particular person's identity is attached to that transaction that is trying to send, or the transaction receipt is trying to send. This ensures that only valid transactions are profile rated across the system. Invalid transactions are rejected at the first node, at the first node which receives them. So if you think, if these nodes think that it is some kind of fraud or scam, so it will, and how will they detect it? They will detect it according to the transaction syntax they have created in the for sending out the transactions. So if there is anything wrong with it, the algorithms will come into play and will actually make these transactions null and void. Checklists of transactions. So there are certain kind of checklists that we have made and you can read like every node confirms each transaction against a long agenda of criteria. So these are the criteria that we think are required for a transaction to be a valid transaction. First thing is transaction syntax and information stack has to be in sync with the Bitcoin protocol. So whatever transaction they are trying to generate, it should be according to BIP 39 Bitcoin Improvement Protocol, and everything has to be sync with it. Otherwise, it will be straight away rejected and sent out to and the equivalent amount is either reverted or is just deleted and never shown to the network also. List of neither inputs or outputs are empty. So either inputs or outputs are empty, then it will be actually again making that the transaction is not correct and this is a fraudulent transaction. The transaction will again be sent back to the person, or it will just be deleted. The transaction size in bytes is less than a max block size. So does anyone know how much is the max size of blockchain? Sorry, a block in a Bitcoin blockchain. If it is more than that particular size, it will just be sent out as an illegal transaction and sent back. Each output value and also the aggregate must be within the permitted scope of values. So it should not be like we are trying to send out like more than 20 to 21 million coins and or a negative value, and it should be more than zero. So any value which is beyond 21 and below zero is actually considered as an illegal transaction. So obviously it will throw an error. A matching transaction in the pool or in the block in the main branch must exist. So some kind of transaction which is similar to it should already be consisted in that unconfirmed transaction in the pool or a block. Otherwise, again, the transaction might not be valid one. For each input, if the reference output exists in any other transaction in the pool, the transaction must be rejected. So whatever the kind of input they are providing is there should be kind of an output inside that particular of that particular transaction in the pool. Otherwise, the transaction will be rejected. So there is a concept of input and output. What we were seeing yesterday, wherein the transaction works upon the UTXO types. So whatever the things they are trying to input is actually working. It should be converted back to the what equivalent amount of bitcoins they would have. So that concept we'll further learn ahead in this in details about the UTXO. But for now, please just understand that whatever the amount of input they are trying to provide should be equivalent to the or to the output. Otherwise, the transaction won't be considered as a valid transaction. For each input, the reference output must exit and cannot be already be spent. So the concept of UTXO is that we'll further learn ahead is actually known as the unspent transaction output, which is actually converted into the blockchain itself. So if the status of that particular output is considered as spent, then that particular transaction will be considered as a double spending and will again then be rejected by the network itself, because you have already been sent that transaction and that transaction is not existing on your wallet, which means that you don't have that particular amount of bitcoin with you in your wallet. And if you try to send it, then again the network will throw an error of insufficient funds and give it back to you. Reject if the sum of the input value is less than the sum of the output value. So it has to be made sure that the input value is always less to the sum of the output value. Otherwise, it will be considered as the false transaction sent out to the network itself. So these are few of the checks that happens. Sorry. checklists that have make sure that these transactions are actually correct and works accordingly. Combination of verified networks. So independent aggregation of those transactions into a block by mining these combined nodes combined with the exhibited calculation through a proof of work. So everything is independent as we just seen earlier, and the combination of verified transaction is only being sent on the network itself. So what does this mean? So by autonomously confirming each transaction as it is received, and before it transmitting it, each node maintains a pool of valid transactions, which is actually confirmed transaction. Like every transaction is correct according to the syntax of Bitcoin blockchain, but it is, however, not being confirmed by the miners as well. So that particular pool is actually called a transaction pool, memory pool, or mem pool, which I was trying to explain you guys earlier, that whatever transaction is actually broadcasted by the sender is firstly sent into a pool which is unconfirmed, that we are just seeing over here. Transaction reaches mining nodes it has collected and validates and relays new transaction just like other nodes. So what does this mean? So this means that transaction will reach the miner's node uh, in the way that it has been collected, same way, and validates and relays new transactions just like other nodes. But these transactions it is not exactly picked up in the same manner by each and every miner, but every miner has a different style to pick up the exact transaction. So transactions can be up and down according to the way the miner has picked up the transaction. And unlike other nodes, the miner node will then aggregate these transactions into a candidate block, and then will start to make that block, add those all informations that we read previously, and try to start to guess that crypto solution to that mathematical puzzle to confirm that block over the blockchain, and will start to fight with the other miners for the reward itself. In the network shown above, the miner nodes in orange color, so these are the miners, aggregates a transaction in a candidate block. So they are trying to accumulate all the transactions in the mempool and try to make a block and create a valid block that is eligible for getting added to the chain itself. So example, let's say Andy is a miner, and a mining node contains a local copy of the blockchain. So the list of all blockchain created since beginning of the Bitcoin system in 2009. So to become a mining node, it is actually an important criteria that you have the copy of the ledger starting from 2009 when the 2008, sorry, when the Bitcoin was first started with the Genesis block, till the date they are mining. So like say suppose today is 17th of September 2023 and you want to start a mining node, then you need to have a copy from that 2008 to 2023 with yourself to become a mining node. And these nodes, so what actually is happening, we see the flow of that particular thing. So Andy's node is listening for transactions, trying to mine a new block and listening for blocks discovered by the other nodes. So it is trying to listen for new transactions, if any, made by any peer in the network, and try to mine these new block by compiling compiling all those transactions to 1 MB of so that the block is almost around 1 MB of data, and listening for blocks discovered by other blocks, and it will simultaneously check if other blocks have created a block or successfully made a block with those cryptographic algorithms and everything. As Andy's node is mining, it receives a block, say 273,816. through the Bitcoin network. The arrival of block signifies the end of competition for the block and the beginning of the competition for the next block. So as soon as they get this notification that okay, so and so person has minted this particular block, they'll end those competition, try and validate this block, and then start to work on the next block itself. So the race is over as soon as anyone is able to mint a new successful block with valid everything, obviously. During the previous 10 minutes, while Andy's node was searching solution to this block 273816, it was also collecting the transactions in preparation for the next block 273816. So the node is actually simultaneously working on different other prospects as well. It is not just only working to confirm the text block, but also trying to calculate the next to next block as well, like compiling all those transactions, sending out the on the block with the valid block details and sending out to the network itself. By now, it has collected a few hundred transactions in the memory pool. Upon receiving the block 273816 and validating, Andy's node will also check all transactions in the memory pool and remove that were included in the block 273816. So to make sure that the transactions is not duplicated in 273816 block and 273817 block, it is actually checking if the transactions are confirmed and added in the previous blockchain. If yes, then it will remove it and search for new transactions from the memory pool to add it in the block 273817. Whatever transactions remain in the mempool are confirmed and are waiting to be recorded in the block. That we already know that it will look for other transactions because the block size is actually not full and still has some space. So he will actually look for other transactions as well for containing that particular size of to fulfill the needs of that particular block size. Sorry. So Andy's node immediately constructs a new empty block, candidate block, which will be a number of 273817. This block is called the this block is called thus because it isn't yet a valid block. So and so if the valid block number is on the blockchain is 273816, the new block is actually not being created, which is the 273817, and this block will then again become inside the competition to add all the valid transactions. May not make sure that not the transactions have not been added before in the previous blocks, and this will make it a candidate block to be added to the network itself. The block becomes a valid only if the miner succeeds in finding a solution to the proof of work algorithms. So even if he adds the transactions to the block and all the valid block number and timestamp and Merkle root to that particular block, but if he's not able to find out the mathematical puzzle solution to that mathematical puzzle given by the proof of work algorithm, it won't be considered as a valid block and it will be made a null block immediately as soon as he creates it, or it will not be sent to the network only, and the others chain will then again will be followed, whoever is creating. These are all the 6 fields listed in the table which a miner needs to have to confirm to construct a block over the blockchain. What are these 6 fields? We need to have the version. So version is a number to track the software protocol upgrades. So it is something related to what Bitcoin has to offer. So that particular version number is to be there, otherwise not a valid block. Previous block hash, very important, because otherwise the chain will not be formed. So it is a reference to the previous parent block in the chain. Otherwise, the chain won't be able to form properly. And also, we see that this particular thing has certain limits. So above or beyond that size is also not a valid part of a block itself. So this is the maximum size of everything. 32 bytes Merkle root, so every transactions having being hashed, it tries to be, so every transaction that has been hashed will be hashed again and again with other transactions as well, until unless there'll be only one particular hash is remained for all transaction, which is like if, that particular hash will represent the transactions that are inside that particular block itself. So any number you create, like try to find out, it will validate that, oh yes, this particular transaction exists in that particular block itself, whatever the block number is. So that is a Merkle root which we learned yesterday. And yeah, so a hash of the root of the Merkle tree of the blocks transactions is there. Our transactions is also important part that has to be added, but it's not in the block header, it's inside the block's main body itself. So next is the bytes, or like the timestamp. So very important, when the block was generated, you need to add that timestamp. And the difficulty target, so the whatever the target was at that particular time to solve that block, you need to add that particular information as well with the leading number of zeros, and whatever the value is afterwards, you need to add that to make sure every person, if that particular block gets mined or confirmed, every person should know that what difficulty was there at that particular time. Last but not least, nonce. So this is like a number only used once, which is like a counter used for the proof of work algorithm. So this can be anything. This can it is not mandatory that the number has to be moving up sequentially, but it can be any number inside the blockchain, inside the block itself. So random generated number, and these people try to find these number itself to with these cryptographic solutions and the mathematical puzzles. So this is how you create a block header. If you have all these six fields, it will be a valid block over the Bitcoin blockchain. And yeah, so you can just make this as a candidate block as soon as you have all these field and values with yourself for this particular block. Mining. And he started mining the block once his node has all the fields filled in the block header in the blockchain. So once they have all those values, then only it will become a candidate block. And with all the other fields filled in, the block header is now finalized and the process of mining can begin. So as soon as you have all these values, you start to solve that particular cryptographic algorithm. The goal is now to find the nonce value, which results in a block header and a hash that is less than the difficulty target of the block. So as soon as you have all those details, you have a goal now to find that value of the nonce that was generated by the when creating a block, which results in block header and a hash that is less than the difficulty target of the block. So whatever the difficulty target is, the hash has to be less than that. Otherwise, it won't be calculated as a valid block by the miner. The mining hub should test billions and trillions of nonce esteemed before a nonce is found fulfilling the prerequisites. So every second it is trying to solve trillions of hashes per second, theta hashes per second, to actually make sure that that particular number is, or that particular solution key is found by the use of those proof of work algorithms or the steps they have to offer. Since an approved piece have been developed by Andy's hub, it is an ideal opportunity for Andy's mining apparatus to mine the square to discover an answer for the verification of working calculation that makes the square legitimate. Sorry. So, whatever Andy's hub has been generated, it is an ideal opportunity for Andy's mining apparatus to mine the square. So to find out that particular value, and as soon as he does that working calculations, it will make sure that these blocks as is legitimate and can be added over the chain itself. So presently, to prove the piece as per the confirmation proof of work calculation, Andy's mining hub needs to achieve the trouble target. Let's see how the trouble is spoken to. So the block contains the trouble focus in just documentation called difficulty bits or just bits. And let's say a block has a hash of like 0190 as the difficulty bits, and this notation expresses the difficulty targets as a coefficient exponent format, with the first two hexadecimal digits for the exponent and the next 6 hex digits as the coefficient. So this is actually the formula to calculate the difficulty target from this representation. So if you add all these value, so you'll be able to get the target for that thing of numbers, but it's actually not for you, it's actually for these mining rigs to solve these particular thing and get the solution for these difficulty the solution for this cryptographic algorithm according to the difficulty as well. So what is the condition of the difficulty? Difficulty recalculation happens automatically on every full node. So it changes after like every block has been mined. So every the difficulty keeps on adjusting according to how much time it took for a particular node to solve the cryptographic algorithm. For every 2016 blocks, all nodes recalculate the proof of work difficulty level. So it keeps on adjusting on the 2000 according to every 2016 blocks. So according to that, how the difficulty is calculated according to that 20 after every 2016 blocks, like how are the nodes performing, is it difficult or is it not. If it is very easy, the difficulty will increase. If it is not easy, the difficulty will slightly go down to what they had previously what they had to previously solve. The condition for retargeting difficulty measures the time it took to find the last 2016 blocks and looks at that to the typical time for 160 minutes. So it will calculate all the measures for that a resource has taken to solve those last 2016 blocks, and according to that, we have learned that the difficulty gets adjusted. The proportion between the real time span and the cover time span is figured, and a comparing change up or down is made to the difficulty. So this is how the difficulty is getting calculated. The equation will be something like this: new difficulty, the old difficulty into actual time of last 2016 blocks. So what is the total time or the average time done to calculate the the solution for the 2016 blocks, divided by 2160 minutes. And according to this, you will be able to find the new difficulty. It can be either up or down. Whatever the value comes is actually the new difficulty as is. We have seen that Andy's mining node has worked hard to reach the difficulty target. Let's see what happened next. As you saw, so successful mining is if he is able to calculate that target, that particular solution, then it is considered as successful mining, obviously. So if it is not able to calculate, it won't be considered as successful mining. So as you saw earlier, Andy's node has created a candidate block and prepared it for mining, and Andy has several hardware mining devices with the ASIC. ASIC is basically the chip as well. The ant minus is what ASIC is here, where hundreds of thousands of integrated circuits run the SHA-256 encryption algorithms in parallel to at unbelievable speeds to make sure that the uh, algorithm is actually getting solved, and it keeps on calculating. Like earlier we this learned that it uses brute force, so it is like checking if it is either 1 2 3 4 5 6 the solution. According to that, it keeps on calculating millions and trillions of solutions to just to make sure that if the nonce value is equivalent to what the mining rig is trying to calculate. So they will have certain formulas, and they will work accordingly to calculate those particular value. So the mining code running on Andy's desktop transmit the block header to his mining hardware. So we have seen those 6 value details, and if that particular details are uh, correct, then his desktop will just try to submit it to his mining hardware, which starts to test the trillions of nonces per second. So it is calculating like trillions of value to estimate if the nonce value is that or not. Almost 11 minutes after starting to mine the block, one of the hardware mining machines finds a solution and sends it back to the mining node. So it has to be actually 10, but it takes like roughly about maybe 11 minutes to make sure that the transaction is correct and can be validated on the blockchain itself. So immediately Andy's mining node transmits a block to all its peer that this we have found that particular solution, and this block is a legitimate candidate to be sent over the chain, and everyone will start to receive and validate then the propagated new blocks and to make sure that if Andy is cheating or not, the other miners will also try to validate that proof, and if everything seems to be okay, they'll provide their confirmations, which is actually the part where we learned previously that we have to add certain number of confirmations, like around 7 in Bitcoin, to make sure that the transactions are valid and cannot be changed further ahead in the blockchain, or might not be cancelled because of due to this low gas fees or any XYZ reason. So as a block ripples out across the network, each node add to its own copy of the blockchain, and then the competition to find that block in the chain is over, and they uh, start to work upon the next block along with the transactions, and check if the transactions have already been minted or not. If yes, then it will be removed from, and the new transactions will be picked up from the mempool. Otherwise, the same number of transactions will be sent if not picked up by the previous block itself. So that is what the successful mining of block looks like, and now comes the independent confirmation of each block. So validation of the new block is happening over the network every now and then. In Bitcoin's consensus process, every new block is validated by every node on the network and make sure that nothing is fishy over the network itself. This makes sure that only valid blocks are propagated on the network and maintains the integrity of it, and nodes validate the block by verifying it against a long list of criteria that must be met. So we have seen the checklist, and that is like the valid transaction. So they are trying to verify according to most of that checklist stuff. Now they have certain list of criteria also. The block structure is syntactically validate. This is actually the not the transaction part, but actually the part wherein it is making sure that the block is actually a value uh, a valid block. And those criteria includes the block structure is syntactically valid. The block header hash is less than the target difficulty, which we previously learned, and the timestamp is supposed to be there, and that is the timestamp is less than 2 hours in the future. So we have to they have to make sure that it is the value from today's time till the next 2 hours. It should be in between them or less than, but not above them. So if it is beyond that, it is actually not a valid block itself. The block size is within acceptable limits, so more than 1 MB or more than more than 1 MB is not a valid block. And the first transaction and the only transaction is a Coinbase generation transaction. So what does this mean is that transaction is actually based upon the uh, Coinbase as a network transaction itself. So that has to be like a valid transaction, otherwise the block is considered to be invalid. All transactions within the block are valid and use the transaction checklist for the independent verifications of transactions. So if they satisfy the transaction checklist which we learned earlier, then it is considered as a valid block, otherwise not. So last but not the least, what is the independent aggregation of the block in the chain? Main chain. So the chain of blocks with the most cumulative difficulty associated with it. The chain of So the chain of blocks will actually check the cumulative difficulty and what exactly is that difficulty should be added in that particular block itself. Under most conditions, this is like the chain with the most blocks in it, and unless there are two equivalent length of chains and one has more confirmations of work, it won't be added to that particular chain itself. So that is one of the conditions that it needs to satisfy. When a new block is received, a node will try to slot it into the blockchain. So, what if they are successfully able to validate all the criteria that has been mentioned before? It will try to push that particular block to on the reward, and the node will look at the block's previous block hash field, which is the reference to the block's parent. So other miners will actually try to validate it and provide their confirmation as well. But it is actually of no use because the reward is with other person. But as soon as they are trying to make it confirm, they are checking that if the block is actually confirmed over the network. But there can be a number of reasons for which the transactions can get cancelled or can be termed as an invalid block. So to make sure that doesn't happen, they try to throw their checks that has been written by these guys earlier in 2008 when starting the Bitcoin blockchain network. Then the node will attempt to find that parent in the existing blockchain. As soon as you get the block, you'll try to find that hash and find the parent of that block. Most of the time, the parent will be the tip of the main chain, meaning that this new block extends the main chain itself. So yeah, so that is it. Like previously, whatever the block hash was, so that was the top of the chain, because no other block has been mined above it. They have to make sure, and now since they have been mined, so that will become a child, but parent will be that particular block itself. So what are orphan blocks? So there is also a concept of orphan blocks, which is like a valid block is received and there is no parent found in the existing chains. So the block is considered as an orphan block. So if you like see their transactions sometimes get mined properly, but it won't have a parent block to it, and it's like a block with no parent. So as the name suggests, a block with no parent is called the orphan block, but the transactions inside it are actually valid. So that particular check is not done to make that as an orphan block. Orphan blocks are saved in the orphan block pool, which is separate from the transaction uh, mempool and every that other pool, where they will stay until their parent is received. So until unless the hash of that parent is verified by the other miners, it won't be confirmed as the block, no, a candidate block over the network itself, or actually successful block. So it has to has a parent, and it has to be existing on the blockchain. If not, it will be considered as the orphan block, and the transaction will be staying over there for a tenure. Once the parent is received and linked to the existing chains, the orphan can be pulled out of the orphan pool and linked to the parent, making it the part of the chain. So whoever was the previous block is actually the parent of that particular block, and if it is not found, then it will be just laying around that orphan pool only. Orphan blocks usually occur when the two blocks that were mined with a short time span between each other are received in reverse order. So, like they won't at say suppose like two people have tried to mine a block at that particular time itself within fraction of seconds. So one particular block might be the might have get got confirmed and have the parent, but other one is not able to uh, get confirmed because that particular block is lying in the way. So yeah, so that particular thing will actually be considered as an orphan block because the previous one has sent the transaction earlier than what the orphan block has sent. It will be considered not a candidate block until unless the previous block is either proved wrong or maybe get corrupted for in a reason. So yeah, so it will till then be able to call as an orphan block because it won't be having a parent block in that particular chain itself. So bitcoins are assembled in the longest chain. So we all know that whatever is the longest chain has to be followed on the blockchain. Otherwise, all these blocks are again an orphan block, and the transaction will go back in that pool itself. By choosing the greatest difficulty in the chain, all nodes in the longest chain accomplish the network-wide consensus. So everyone would agree to whoever is creating the longest chain, he or she will be actually the considered as a valid person to share the ledger, and that will be a more trustable person to mine the block. Brief errors between the chains are settled in the long run as more proof of work is included. So it will broaden one of the conceivable chains. So whatever errors are there in chain, it's actually settled not exactly at that moment, but during the long run. And as more and more proof of work is sent to the chain, it will actually be enhancing the enhancing it as a one of the conceivable chain, because everything cannot be rectified as and when the solution is provided for the block itself. So mining node, which is the vote, with their mining power by picking the which chain to be extended out by mining the next block. So they will try to put on a vote with their mining power, and they will be actually picking which is the longest chain and which they need to start at the new block for which the competition will rise. So when they mine another block and expand the chain, the new block itself speaks to the vote, and yeah, so that is how the block will get inside a chain and will expand the chain by adding that particular block inside the blockchain. The difficulties in solo mining. So we have seen how solo mining of Bitcoin works. However, solo mining is becoming difficult. Let's find out why. Bitcoin mining is to a great degree an aggressive industry. So As soon as the difficulty gets increased, you need a newer machine or a high value machine to solve that cryptographic algorithms. So it is an aggressive industry because every 2016, every block number 2016, the difficulty gets up and down.
What is the process called when miners compete to solve a complex mathematical puzzle to validate a block? Option A, cryptography. Option B, hashing. Option C, proof of work. Or option D, blockchain formation.
Just a quick info guys, Intellipaat offers you a blockchain certification course which will help you become an expert in distributed ledger technology, Ethereum, Solidity program and many more. Through this course, you will also receive additional courses co-created with IBM, namely IBM Blockchain Foundational Developer, and deploy a web-based blockchain insurance application. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description. Without a doubt, this course can set your careers to a new height. So visit the course page link given in the description below and take the first step towards career growth with the blockchain tech stack.
So yeah, so the hashing has explained exponentially each year of Bitcoin's presence, and so there's no instance that a hashing power has been decreased or lowered down during the course of the network, but it has only been increased gradually in a linear way. The competition between miners and the growth of Bitcoin has resulted in an exponential increase in the hashing power, and the total hashes per second across the network is already being increased day by day. The acquaintance of ASIC mining leads with the another gigantic leap is mining power, and by setting the SHA-256 work directly on silicon chips specialized with the goal of mining. So that is how the things will work, and that is how the mining and hashing race is occurred. So if you see this chart, the total hashing power in gigahashes per second over 2 years. So this was the value that has been increasing day by day. So if you see, this is actually a growth that is just keep on increasing during the end of it, and recently it has actually increased very fastly, and that all happens because of the number of miners actually get connected to the network and try to solve those cryptographic algorithms. So as the amount of hashing power applied for the mining bitcoins has exploded, the difficulty has risen to match it. So that is how the graph is working for it. So mining by the pool of miners. Since solar mining has become impossible with the increasing difficulty in the Bitcoin network, miners have started mining pools. So what is mining pools? So mining pools is like, you have previously understood that number of resources that you send, and according to that a percentage of Bitcoin will be given to the amount of resources that you have added. Mining pools coordinate many hundreds of thousands of miners over a specialized mining pools. There are basically these websites wherein you can just add your resources, and those resources will be accessible to that particular website, and they can start to mine the nodes itself. So yeah, and individual miners can configure their mining equipment to connect to the pool server after creating an account with the pool. So after you have the account with the pool, you can configure how much space or how much memory you need to allocate, or what all resources you need to allocate to participate in that mining pool. The pool server will periodically send payments to miners on the Bitcoin addresses associated with them. Once their share of rewards has reached a certain threshold, then it will be given to them. So, well, like you have certain amount that needs to be transferred, then only they'll transfer you the reward. Otherwise, they will just keep on adding it until you reach that certain threshold. Their mining hardware remains connected to the pool server while mining, synchronizing their efforts with the other miner. So they tend to make a solution in such a way that other miners who are trying to put in their effort is combined with the effort that you put with your resource machines, and they combining then will try to solve those then algorithms that are associated with the blockchain. Successful blocks pay rewards to pool Bitcoin address rather than individual miners. So whatever successful blocks are there, the rewards are paid to the pool of Bitcoin address, but not the individual miner directly. So whoever is associated will be getting the bitcoins from the pool. Whoever is organizing that pool, whichever website is organizing that. Pool miners share the effort to mine a block and then share the rewards. So they share whatever the share it is there. So they will associate. They will transfer you the tokens according to that. So difficult pool mining difficulty of targets. The mining pool sets a lower difficulty target for earning a share, typically more than 1,000 times easier than Bitcoin's network difficulty, so that all individual miners are able to mine and earn Bitcoin. So it kinds of makes a fair game for other people as well, so that it is easier for so that individual miners can also participate, and the pool of miners won't take up the charge on the network itself. So when someone in the pool successfully mines a block, the reward is earned by the pool and then shared with all the miners in the proportion to the number of shares they contribute to the effort is. So this is very straightforward and clear that how much, no matter how much they uh, are investing or doing, the amount of resources they are providing is the way is according to that it will get the rewards also. Pooling pool mining difficulty of targets. How does a mining pool measure the individual contribution? So as to fairly distribute the rewards without the possibility of cheating. The answer to this is that it uses the Bitcoin's proof of work algorithm, and to measure each pool's minus contribution, you there will be a setting a lower difficulty so that even the smallest pool miner wins a share frequently enough to make it worthwhile to a contribution. So these are certain set of rules so that it is actually a fair share game for mining of pool. For pool miners to also get a fair share in the network, even if they are there with the small resources than other people with the high tech. High tech GPUs or mining rigs. Pool mining types. There are several types of pool mining payout systems. So different payout systems are summarized as follows. So pay per share is one of the popular one, wherein approach is to offer instant flat payout for each share that is solved. Then the payout is offered from the pool's existing balance and can therefore be withdrawn immediately without waiting for a block to be solved or confirmed. So you don't need to wait for a block to be solved or confirmed. You can just, as soon as you are done, you can just get the payout and exit from the pool itself. So it is necessary for pool to have a certain balance. The possibility of cheating minus by the pool operator and the timing attacks is thus completely eliminated, and the method results in the least possible variance for minus while transferring all the risk to the operators. So the result of possibility of loss of the server is offset by setting payout lower than the full expected value, and this is how you are able to get the PPS working for the other miners who are connected to that particular pool as well. Then we have these pay per last N shares. So these are like a higher payout, and this is for people trying to mine as fast as possible. And this will give you a wide fluctuations in 24-hour payout. But for hardcore miners, the law of large miners states that you will earn more money this way. So yeah, so if you want more money, then you should go for the pay per last and shares. Otherwise, you can just go for pay per shares, wherein you are secure and much more safer way to get your payment from the pool itself. So moving ahead, we learn about Ethereum. Let's know more about Ethereum. So Ethereum was introduced back in 2013 by this person called Vitalik Buterin. He is actually a very famous guy, and he is actually this particular person who has introduced this Ethereum as a concept. And why did he introduce this? He introduced this because of the limitations that Bitcoin had. So Bitcoin was only used uh, with traditional like finances itself. So you can just buy, sell, or like trade on Bitcoin, but the data uh, like storage was not available. So that was the biggest limitation that the Bitcoin technology had, and we like blockchain had much more of use case potential to it. So this guy actually introduced this Ethereum as a technology, as a concept, because he understood what how blockchain could disrupt, and he gave out us a machine which was basically a Turing complete machines. If and that particular machine is capable of deploying decentralized apps and several other features on top of Ethereum network, which is shared with everyone on real time itself. So this was introduced way back in November 2013, when blockchain like Bitcoin blockchain was in a very nascent stage, and Ethereum also like came into the picture with its capabilities enhancing the uh, enhancing the experience on the blockchain, and enhancing the potential of blockchain. So yeah, so we had this uh, cryptocurrency called Ether, which is actually fueling the Ethereum network source. And the basic idea proposed was the creation of a Turing complete language for Ethereum, and it allows the development of smart contract for blockchain and decentralized apps. So you can create decentralized apps with the use of smart contract, which is the important feature, like most important feature of Ethereum itself. So Ethereum aims to enable innovation in these four key areas actually. Currency issuance is one. So when you say currency issuance, it is all about Ether, and you can also launch your own cryptocurrencies on top of it by creating few smart contracts. And with the help of those smart contracts, you can create different standards of tokens, which you can use to either raise fund or store it as a NFT. So with that is like different topics altogether, which we learn further ahead. But if you wish to see the standards, so you can just Google Ethereum standards. So this is these token standards we have in it, ERC20 being the most famous one. and it is actually a fungible token. So there's a concept called fungible and non-fungible, wherein fungible in a basic English language means interchangeable. So it's like you can change with other tokens as well. So it is not like a very unique kind of thing, but it's very similar to what other cryptocurrencies are, and it can be changed according to that particular value with that particular function itself on the smart contract. So when we see ERC 2721, so these are built on top of smart contract itself, but the functioning changes according to the standards, and you can go through the standards by clicking onto this link and read more about it, why it is used, what exactly it is used for. You can use this for lottery tickets, fiat currency like USD. So we have, like earlier also I was explaining uh, the concept of USDC and T, which is actually a dollar pegged to the cryptocurrency itself. So every dollar that is existing on the network is actually pegged to the dollar in your real life. So that is actually the concept of pegging it to the real network itself, and so on and so forth. You can create these ERC20. So if there isn't kind of prerequisites to it, you can just read through it, and yeah, so that is it. This is a basic uh, methods actually for in which every ERC20 token standard should have. So the name of the token, symbol, decimals, total supply. So you have to provide how much supply would be regulating for that particular token, and what is the balance of that particular smart contract on which that particular token has been implemented. So you can trace on how many numbers of tokens are left and how many are issued, and so on and so forth. And yeah, transfer from, approve, allowance. So these are the few of the methods that you can call from your typical server, which can be written in either Node.js or any other language like Go, C++, whatever, however you're comfortable with. But the most famous one is Node.js itself. So everyone is using that and to call out these functions itself. And these are something called as events. So as we know that events is like any occurrence that is happening over the network. So this particular is acting as a event, wherein you if any transfer or approval is happening, so you'll be get emitting an event, and that particular thing will be can be seen on the uh, this Etherscan itself. So this is the blockchain explorer for Ethereum specifically. Blockchain explorer for blockchain.com is actually an explorer for this Bitcoin, but you can also see the Ethereum transactions as well on it. But to specifically, we have this specific website called Etherscan, which is actually a explorer for it. But if you just want to keep it like on one website itself, you can just come into this website and you can uh, check out the details that you're looking for. So yeah, that is it. So this is like a market cap for this particular token called Ethereum, and this is a diluted market, and this is a volume being traded in last 24 hours. And what kind of algorithms it is being used for mining the network itself. So previously we learned about the mining of the what mining is. So most of the concept is similar to Bitcoin, but recently it changed actually from the similar concepts of the Bitcoin to a new consensus algorithm called proof of stake. And that proof of stake is actually being used now, and I hope you guys know the difference between proof of work and proof of stake as of now. So without smart contracts, Ethereum is much more like what Bitcoin is. But if you're having this smart contracts on top of Ethereum, so you can write down those smart contracts, and it will the function, and its function will stay on the blockchain forever. So you have to like carefully write those functions and thoroughly make a go through it, so that there's no chance of vulnerability into it. Because if there is, and if there's a security threat to it, then I think so that particular contract is actually not upgradable until unless you're using open zeppelins, proxy smart contracts or other things like that. So that is like a different concept we'll be also learning further ahead. But let's just keep this session simple as of now, and understand how exactly the theoretical concept of Ethereum is, and are getting very famous these days. So what DAO means is it's like an organization wherein people cumulatively put out decisions, and on top of blockchain itself. So you have different kind of voting mechanisms embedded into it, and that particular voting will help how the organization will function throughout its cycle. And yeah, so if you have like any ideas related to it, like a crowdfunding source or maybe anything else, so you can implement on DAO itself. And we have different DAO tools, which makes it easier for you to actually create a DAO. So all DAO tools, if you just want to look into this, you can just go through this website. It will actually give you an idea how many tools are there. And so you see these are like different DAOs on top of it. It has different mechanisms on which it has been implemented, and you can just go through inside it and read about how what exactly this DAO does, what are the team's terms of services, and yeah, how is it connected to the network, what network it is using. It is built on the Binance Smart Chain mainnet, so you can just go on top of it and just see what how they are implementing it. And these are actually the core members of that particular DAO who is actually handling the functioning of the organizations and keeping an eye on the treasury as well. So whatever funds you might be having, that like might be getting, will be like shifted to the treasury, or like uh, given out to the different the peers, as and when the blockchain functions with the DAO. So yeah, you can go through these sites as well and learn about what exactly this is. I'll be also sharing this link. Uh, yeah, so this is like a general information. They do not have this GitHub with them that is published, but rest of the things is actually shared, and you can interact with them through Twitter, or maybe if you want to just work it on the snapshot itself, so you can also do that. We have different strategies also. So everything, like if you wanted to understand how this particular snapshot is working, you can just go through its talk itself, which will also explain you how the things work, function on top of this network itself. Proposal, whatever it is. Yeah, so snapshot is a very famous tool to deploy your own DAO. All you need to do is connect your wallet and just uh, these are the steps you need to follow just to deploy space on top of snapshot itself. You can check out different tools also, like very famous DAO tool wherein people actually interact with each other and do things like this, and they sell their nouns as well if they can, if they want. So this is like a number wherein people just bid and see how they can own this cool, you know, a doodled kind of thing. And yeah, so these are like very famous, uh, you know, uh, DAOs, which you can actually you will be able to see it on Twitter or slash X, whatever you want to call. People are just putting out these nouns on their images as well and just buying it out. So this is actually a very famous DAO tool wherein you can just come in and propose or delegate their vote according to whatever the decision is yet proposed by an individual on the network itself. So if you see, one guy has put in like this as a proposal wherein he's asking lower fork threshold to 10%. So this is actually, you can see this proposed by Carol.eth. So .eth is actually nothing but an ENS. So you guys also can create your ENS with your names itself, and then you will be able to interact with this particular DAO. But you need to be connected on a mainnet, which will cost you some gas if you want to create an ENS for that. But you can also create like on top of test network itself. It will not be available for the main net, but it is actually a cool thing for you guys to learn how uh, like to own an ENS on top of Ethereum network itself. To and if you want to communicate with them, you can just communicate with it, and this particular ENS will be acting as a address basically. So you can just send out the money to someone with this particular ENS, or receive the money. You can interact also with it, do chat or stuff like this. Buy it with this much amount of money on Ethereum itself. But you can also go to this test network. I'll urge you guys to, mm, build like get some tokens on top from the faucet itself, and Ethereum testnet faucet you can search for, or maybe you can just create a new one, however you want to see. So you can find him like on with the address, maybe on Twitter or somewhere on the internet with their ID, and ask them to sell it or maybe try to make a bid to it. So it is a very interesting concept as of now for ENS. Most of the people who are actually interested in Ethereum have their ENS with them. So ENS testnet, you can just look for this. You connect with your MetaMask maybe. Mhm. So yeah, with this you are just connected with the Ethereum mainnet. You can just go to this MetaMask and maybe change it to Gorley. I think so. Yeah, you can just look for test network Ethereum ENS. So you'll be able to get that. If we see if I can find it for you. So we have this mainnet and testnet that I'm explaining to you. So this Gorley is actually something on top of test network itself. So what you can do is you can just go inside this Notion tab, and I think so they'll be able to give out you the steps on how to get your ENS. So I'll yeah, so that was Ethereum, a basic understanding of the innovations that it was working with, and now we'll just see how is it different from Bitcoin. So more or less, like it is based on the same concept as well. Just besides the fact that smart contract part has been added to this. On Bitcoin, we do not have any kind of smart contract. We can just put in the use this Bitcoin network for financial part, but as and when like we proceed, it's also kind of and adding the some kind of utilities to it. Like Bitcoin has recently introduced this concept of NFT, so this decent making decentralized applications. Yeah, so it is a more secure network, and everything on Ethereum is actually much more feasible than Bitcoin. So let's see what all comparisons do we have. So we have these founders as Satoshi Nakamoto and Vitalik Buterin and its team for Ethereum. Satoshi Nakamoto is yet not to be found. He just implemented the technology and vanished into thin air after deploying it. Every kind of major agency is actually looking for him, who is Satoshi Nakamoto, and is closely monitoring his address, through which he, implemented or mined the Genesis block, introduced the Genesis block for the Bitcoin blockchain. So these were the founders for the respective blockchains. And what is a scripting language? So scripting language is like Turing incomplete for Bitcoin. So it's non-Turing, language being used as a PC. But in Ethereum, it's very like a Turing complete kind of thing. So when was it introduced? So it was introduced back in 2009, when the Bitcoin, like when the people were introduced with the blockchain and the Bitcoin part. And in 2015, this was actually being implemented. Yet it was conceptualized back in 2013 as a white paper, and it took around like 2 years for them to, just to implement this technology. And yeah, besides this, what is the coin release technique? So how do you guys get these BTC or Ethereum? So in Bitcoin you get it through mining. So that is the only way. Like if miner mines, then only he'll be implementing the concept of UTXO, which will then be converted into Bitcoin. And then he'll be having that Bitcoins itself. So fun fact, do you know that Bitcoins doesn't exist? It is actually in the form of UTXOs, which are then converted into the concept of Bitcoin. And yeah, it doesn't exist until unless you spend it. So that's what unspent transaction output means. So you just have the transaction outputs into your account, and once you send it, then it turns into the spent transaction output and change into that. So yeah, that is the only way actually you can, you know, make this Bitcoin live into the network itself. Otherwise, you won't be having those Bitcoins existing in the network. So after you mine, then you'll be able to actually buy it from the miner, or maybe trade it, or whatever you want to do. And through with this Ethereum, how do we get ethers? We get it from the ICO. So we have so the basic building blocks of programs written for Ethereum platforms are called smart contract. And let's actually see what a smart contract is. So you see a diagrammatical representation, which is like a contract between two parties, and it is actually written in the form of code itself. And the individuals involved are anonymous, so they don't need to know each other previously or beforehand. to interact with each other. They can use they can trust the smart contract as their escrow, and whatever the information they want to share amongst them, they can just store it on smart contracts, and as and when they are completed with these steps, they can just release those information or whatever kind of uh, thing they want to give to each other once their deal is completed. So you see, the individuals involved are anonymous, but the contract written in the pub is in the public ledger. So to see an Ethereum smart contract, so you can just go into this. Sorry, this is like a. I earlier also used had shown you these contracts, I guess. So these are the places where you can just find out the smart contracts, and you can just read it. I'm not sure if you will be understanding this, but yeah, this is how a smart contract would look like, and it is implemented once, considering every situation, and everyone could just come in and interact with the smart contracts and try to try to implement the features that has been embedded in the smart contracts. For this, say suppose we have this token as USDT. So the what this contract does is, so this contract is responsible for converting your cryptocurrencies like Ether to USDT, and whatever the number of tokens you want to own, you can just exchange by giving out your Ethereum to these smart contracts, and they will give you in return for the equivalent amount of USDT to it. So whatever is the amount for this, I think so that right now it is like exactly $1. So if the Ethereum price is, say suppose, what is the Ethereum price right now? So it is 1589. So you'll get around 1589 USDT tokens from the smart contract itself that will be implemented on the blockchain itself. So that is the function of smart contract, wherein everything you can see it on the network, but you have these predefined functions wherein you can interact with it and do whatever kind of operations you want to do on top of this network itself. Obviously, if the functions are written in that, then only you'll be able to do it. Otherwise, it won't be feasible for you to do it. So yeah, once you have this on the public ledger, a triggering event like exploration, expiration date, and a strike price is hit, and the contract executes itself according to the coded terms. So whatever has been written is actually being triggered as an event, and it will just give you these things as like expiration date and this, what is the price that is actually going to hit when it is deployed, and code then is actually working on the automated mode. And yeah, so that is basically what smart contract is. And then me and you or any kind of individual who is connected with the Ethereum network can actually interact with that smart contract and use its functions as a features to be doing your tasks, whatever you have in mind. Yeah, so that is what is basically a smart contract. A smart contract is a computerized transaction protocol that executes the terms of contract, whatever has been written on the this contract itself, and the language is used for interacting, like writing down the smart contracts are Solidity, which is the most famous one as we previously learned. And we have other smart contract languages also, like Viper and LLL. With the help of that, you can also write a smart contract. And when running on blockchain, a smart contract becomes self-operating computer program that automatically executes while specific conditions are met. So as and when the conditions are met, it will execute the result to it, or maybe call the next function and then start to executing that particular functions. The operations that is written inside that functions itself. So this is actually a diagrammatical representation of how smart contracts work in a permission blockchain. So when it comes to permission, it is called a private blockchain, how it is working. So if you see, we have these physical contracts earlier within Alice and Bob, and what are these guys doing there? They have programmed that particular physical contract in Solidity, and have implemented on Ethereum network itself. So blockchain is actually on, once it is deployed on blockchain, it is also in the permission ledger, wherein a specific people who are in that group or blockchain can be only be able to see that smart contracts, and rest of them would not be publicly available, like it is for other tokens or maybe other smart contracts you want to deploy. Okay, so smart contract is a software program on a distributed ledger allowing immutable, verifiable, secure, and record all contract and transactions. So this is what smart contract is, and Alice and Bob will interact with that particular smart contract, and what will it will give is lower operational overheads and costs, leading to economical and financial products. So whatever their operation overheads were and costs were earlier, it actually lowers it down because everything is just working in the automated way, and there's no other human involved or maybe other resources involved that will be causing them extra, the pay or maybe an error, which can also be termed as an human error, as in, the expense to it. So if these things are removed, the transaction cost or the operation cost is actually becoming less because everything is automated and written before and thoroughly audited and checked before deploying it on the network. So these are the banks, insurers, and capital marketers, custodians of network and validated. So this is like something where working as a CBDC. So what is a CBDC? It is like a controlled environment wherein people can control how the things will be working, and how will they be able to do that? They'll be able to do that by defining those functions inside the smart contracts itself. So yeah, so that is how it is actually working, and once it has been deployed also, that will give you a faster, simple, and hassle free process with a reduced settlement time. So whatever you want to do on the network is actually uh, very fast, since it takes around 12 to 15 only seconds to implement the particular transaction or maybe deploy it on the blockchain itself. Yeah, so that is how a smart contract gets on permission blockchain. You just run up or fire up a network, create your own permission network, and then just write down a smart contract on top with the help of Solidity, and then just keep on adding to that particular network so that every individual on the network can just come in and interact with the smart contract and does it functionalities and exit the permission blockchain if he wants. So, what is the cryptocurrency used in Ethereum? So, as we all know, Ether is like very famous thing. So that this is like a cryptocurrency which is actually fueling up the complete Ethereum ecosystem. So, if you do not have these Ether, like you will be just an handicapped person on top of Ethereum. You can just able to see things, but you will not be able to do any kind of operations on top of Ethereum. So if you want to do any kind of operations, you ought to have this as in your network itself. So Ethereum is incomplete without cryptocurrency. Let's have a look of the cryptocurrency used in Ethereum. The Esteem token of Ethereum blockchain is called Ether, as you all know. It is recorded under the code ETH. So ETH is actually an acronym, a short form for Ether, and it's exchange on digital currency trades. So if you cannot find anything where to buy Ethereum, you can just go on to this traditional cryptocurrency exchanges and buy it from there, and then you can transfer it to your secure wallets, and then interact with smart contracts with the help of that particular Ethereum itself. So you can just connect to the websites and start to interact with the Ethereum blockchain. So what is the utility of Ethereum? So the utility is actually to pay for the transaction fees. So whatever kind of event, like thing you want to do it on Ethereum, you need to pay gas fees to it. So what is the gas fees slash transaction fees? It is actually a fees that is given to the miner for confirming the transaction over the blockchain, as we have already known about this. And if you want to get your transaction completed, you have to pay these fees to get it confirmed over the network and do some whatever kind of computation services you can do it with the help of ether itself. Every time a contract executed, Ethereum consumes tokens, which is termed as gas, to the to run the computation. So according to what functionality you have written on the smart contracts, a gas fees is actually calculated, and that particular gas fees is actually uh, implemented by y- beforehand, should be present in the smart contracts, so that it does all the communication with the network fluently and easily, like very smoothly. So these are the denomination tables of ether. So like in Bitcoin, we have one BTC equals to I think so 100 million satoshis. So that is the smallest denominations in this. The smallest denomination is way, which is one to the power of 18. So like one ETH equals to one is to the power of 18, and this is the value, like 1 with 18 number of zeros, if you want to calculate way. So one this a much amount of money equals to one ether, and these are the other denominations as well. So 1 to the power of 3, so that is 1000, that is que me mbe que, and micro ether, Sazabo, and Fine. It's kind of milli ether, like other denominations as well. So this is the most famous one that is used. Quay is also another part of it, which is which is a favorite by other Ethereum developers. So whatever calculations you are doing, it is either done on Quay, on your traditional system, or maybe on your smart contracts. So people prefer to use the Quay itself, if not Ether. And yeah, Way is actually on the uh, smallest unit for whatever the transactions. So whatever you want to do on Ethereum, you have to have like some kind of base way in with you, which is the smallest denomination, and sometimes the function returns the value in actually is in way. So make sure, like when you're interacting with in Ethereum, or if you are just trying to manipulate data on Ethereum, make sure to check how much gas it is required, and that gas should actually be known in what denominations it is before you try to interact with other Ethereum network itself. Grass, a crypto fuel for Ethereum. So, as we all know, if you do not have money for paying out the gas, you cannot do anything, and you cannot do any transactions, and whatever you have to do, you require gas beforehand, either in your wallet or in the smart contracts, whatever you're trying to deploy. Let's understand what gas is in Ethereum and system, and why is it necessary. So I hope till now every one of you have. Okay, gas in Ethereum. So what is gas in Ethereum, if you guys know as of now? The gas is nothing but it is required to be paid for each activity performed on the Ethereum blockchain. And any kind of activity you want to do, you have to pay gas for it. A transaction fee is charged as some amount of ether and is taken from your account balance. If you are doing a transaction, your transaction plus a certain amount of money for gas actually gets charged when you try to broadcast the transaction over the network itself. Yeah, so that is what a transaction fee is. A fee is paid for transaction to be included by the miner. So that is actually to confirm the transaction over the network. The more the fee, the higher the chances of the transaction to be picked up by the miners for inclusion in the block. So that is actually true. So the gas fee can also work as a kind of a bait for people to, confirm, get their transaction confirmed. Sometimes people actually put in the wrong value to just confirm, so it sometimes become much more higher than what a transaction uh, fee has to be. So it's like some guy who was trying to send out $1942, and that was equivalent amount of like 0.05 bitcoins, I guess. And for getting that transaction confirmed quickly, he actually by mistake added the transaction uh, uh, gas fees as I think so 5 bitcoin, and that was the actually the most uh, amount of gas that was actually being paid on the network itself to confirm a transaction. So that was a kind of error, but you make sure that you make it like use these Ethereum wallets functionality of adding the gas, and check the gas fees that is going on right now just to confirm the transactions over the Ethereum network itself. Okay, so this is the gas fees that you can check out. So you see median gas price, so it is around $0.27, 27 cents to confirm a transactions over the Ethereum network, and that is equals to 8 GUI that we just were learning previously for other denominations as well. Okay, providing too little gas will result in failed transactions. Okay, yeah. So if you provide any like limited number of gas, it might not be able, miner will not be able to pick it and it will fail. So the transaction will be reverted to the initial stage, and no transaction will be done then. And you need to do the transaction again with more gas fees. Otherwise, it won't work. Assessing the transaction cost. So how do you assess what a transaction cost will be? So the transaction cost can be estimated using the following formula. So the total cost is equals to gas used into gas price. So gas uses the whatever the functions you call, no. So according to that, the gas is actually being calculated as gas use, and the gas price is like the price that will be implemented for executing that particular functions itself. So gas uses the total gas that is supposed to be used by the transaction during the execution, and gas price is specified by the transaction originator as an incentive to the miners as well. So if you are trying to, can you guys see my MetaMask? So this is how you add this gas fees itself. Other formula is also like 21,000 into whatever the number of functions you have used. So according to that, the total cost will be incurred. So what are transactions in Ethereum? So the transactions, the most notable difference between the Bitcoin and Ethereum blockchains is that Ethereum blocks contain both a transaction list and the most recent state of the ledger of these transactions. So whatever you are trying to do on the network is recorded in the form of transaction. So if you want to see what is happening, just go through the transactions on the network, or with the smart contracts, you'll be able to understand what exactly is the things that are going on right now. And let's take a look at the transaction and accounts in the Ethereum blockchain. So the term transaction is used in Ethereum to refer to the signed data package that contains a message to be sent from an externally owned account uh, to another account on the blockchain. So Ethereum actually consists of different data packages, and it will also consist of a message which is digitally signed and then actually get broadcasted over the network, and it will be actually be sent to an externally owned account, which is a smart contract or maybe another address, and which actually will be sent onto the blockchain itself. So Ethereum, that's how you make a transaction on top of uh, Ethereum. And as we have previously also seen, what is the process of sending out the transaction. So I think you guys have a better fair understanding about how transactions work in blockchain. And Ethereum blocks, moving ahead, Ethereum blocks contain both a transaction list and the most recent state of the ledger of these transactions. So whatever is actually the current state of the Ethereum blockchain, you will be able to identify on the Ethereum network with the help of these transactions itself. So accounts are one of the main building blocks of Ethereum blockchain, and without them, I think so there won't be any. Uh, the Ethereum blockchain will not be able to function as so. Accounts, like there are two types of accounts basically. One is the externally owned accounts, which is like these transactions. So this is an externally owned account which is owned by the individual itself, and it's defined as a basic form on account that interacts and generate updates on the Ethereum blockchain, whereas the other type of uh, account is the contract accounts. So contract is also working as an individual entity on the blockchain network, and each smart contract is allocated an address through which it communicates and does like a receiving or sending the transaction or completes its basic functionality that it has to incur, and that has been written by the developer itself. So yeah, so contract accounts, they are programmatically executed when they receive the instructions in the form of transactions from an EOA. So what is an EOA? As we understood that it is just a normal account that has been created by a user just like you and me. And contracts can push or pull funds and request these actions from other contracts calling on the code to perform the dynamic transaction. So if you are trying to send or receive funds, you can do it on with the help of contracts. Contracts will have certain definitions written inside their functions, and according to that, the code will either be able to pull out the funds from the externally owned accounts, or maybe like send the tokens from that particular account itself. So the contracts have that much authority in the Ethereum network. So if we restrict Ethereum to only externally owned accounts and there are no contract accounts, then uh, we arrived at an altcoin system that is actually less powerful than Bitcoin itself and can only be used to transfer Ether. So it's basically like you are removing the functionality of dApps to create the decentralized applications, and you're basically stealing the aura of Ethereum network, and so that was basically it won't be it's useless without these functions working in it. The state of all account is the state of Ethereum network, which is updated with every block, and about which the network really needs to reach its consensus. So yeah, these accounts is also very important to attain or to reach a consensus in the network itself. How approval occurs in Ethereum blockchain. Let's see how transaction happens and how a block is created in Ethereum blockchain. And what it will do, it will determine these tail blocks called as uncles or owners and include them in the block. So what is uncle blocks? So these are the blocks that are actually not broadcasted over the network itself. So it is like transactions that are confirmed but not added to the that particular self of chain. So it is like a stale blocks which are not confirmed on the Ethereum blockchain network. So that is what a uncle block is. And updates the next thing is updates their account balance with the reward earned from the successful mining of the block. So as soon as he confirms the transaction, that particular amount is actually transferred to his wallet, and a valid state is computed and block is finalized, which defines the result of all the straight transactions. What validators or miners do in Ethereum network, and these are the basic theoretical level of what actions miner performs and how it functions. Uh, Moving ahead, we'll start with mining reward. In order to incentivize miners for supporting Ethereum network, certain kind of block reward is given and is granted to the lucky miners who generate the correct block. So whoever performs the consensus algorithm and gets that uh, algorithm correct, the answer to that algorithm correct, so his block will actually be added to the longest chain of blocks, and that particular block will be getting all the rewards whatever the miner is trying to achieve. And currently the block reward is set as 5 ethers for Ethereum, and whoever successfully mines the block over the network, he'll be getting out 5 ethers for just to confirm the transactions. But I think so this is like the previous one. In proof of stake, the ethers are around like 32 ETH now. Let me just check it out for you guys quickly. Ethers reward in proof of stake. You see, reward payments are automatically processed for active validator accounts and with a maxed out effective balance of 32 ETH. So any rewards above that will not be considered as the valid amount. So it is like bumped up to 32 ETH instead of 5 ETH as of now, since it has been moved to the particular consensus algorithm from proof of work to proof of stake. So I think so this content is little not updated, but we'll get this updated as soon as possible now. So this will contribute to the inflation in the number of ether available, and hence the.
What is the key difference between Ethereum and Bitcoin? Option A. Ethereum is a cryptocurrency while Bitcoin is a platform for building decentralized applications. Option B. Ethereum uses a proof of stake consensus mechanism while Bitcoin uses proof of work. Option C. Ethereum transactions are faster and cheaper than Bitcoin transactions. Or option D. All of the above.
Just a quick info guys, Intellipaat offers you a blockchain certification course which will help you become an expert in distributed ledger technology, Ethereum, Solidity program and many more. Through this course, you will also receive additional courses co-created with IBM, namely IBM Blockchain Foundational Developer, and deploy a web-based blockchain insurance application. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description. Without a doubt, this course can set your careers to a new height. So visit the course page link given in the description below and take the first step towards career growth with the blockchain tech stack.
The value of each ether. So as we all know, like when miners mine the block, then a particular uh, ETH or any token is getting generated, and once it is getting generated, the miner either sells it or trades it with other tokens to make it existing in the ecosystem as well. So what is the consensus mechanism in Ethereum? For any distributed computing system to properly function, we all know that we need there needs to be a mechanism for an entire network that comes to an agreement, or its state or its token supply is divided among the registered address on the network. So there has to be like some kind of agreement, like whatever we have learned in previously. uh, it's what we similarly will be learning in this Ethereum as of now, wherein we learn the general agreement that is achieved by the consensus algorithm, like proof of stake and proof of work. So at the time of writing, Ethereum uses a similar proof of work protocol known as Ethash. So that this was like previously being used. Currently, it has been moved to proof of stake for better utilization of resources, and it is not similar to Bitcoin, but it is moved to the idea of validators validating the block over the network by staking out like 32 ETH to become a validator. And once they become a validator, they'll be able to, get those Ethereum tokens onto their network itself. Okay, so it uses this is actually correct that it uses different cryptographic primitive for its hashing function, known as SHA-3 and rather than SHA-256, what Bitcoin uses. So the hashing function is done using the SHA-3 rather than SHA-256. So we have this thing called Ethash, which is designed to make Ethereum both resistant to the high powered mining chips that currently dominate the Bitcoin industry. So the mining part is actually little bit different from what Bitcoin miners use as a resource. So these they use basically ant miners and other resources to mine over the network. For this Ethereum, we use these high powered GPUs like RTX 1080 and other powerful GPUs as well. And since they have like different way of mining the things, so we need different resources as well. And so it has like a more of an approach of a light client implementation that allows users to use Ethereum without needing to download the Ethereum blockchain into their device. So it's not necessary for you to have your complete Ethereum blockchain onto your device. You can do without it as well, with the mode known as light, not the complete full blockchain. That has to be that is a minimum requirement when you are mining on top of Bitcoin network. But on Ethereum, you can just work as a light node, and you will be able to start to uh, mine over the Ethereum blockchain itself. So light clients download headers in light, like when you are working as a light line, you will not be downloading the complete transaction, the complete blocks and everything. You will just be downloading the headers of the block for references, and you can just start to work in that mode itself. So what are some more functions of Ethereum? uh, Ethereum actually blockchain is intended to do far more than process shared transactions. It is designed to execute complex code where the functionality is only restricted by the imagination of its developers and accessible resources. So whatever you kind of business use case you have, if it is it can be implemented on Ethereum network. All you need to do is write a bunch of smart contracts, and then you'll be able to implement that particular business use case on top of Ethereum itself. And yeah, so that's how you kind of implement the use case on top of Ethereum network. The complex code are executed in Ethereum virtual machines. So this is actually a computer running behind the Ethereum network, which is called an Ethereum virtual machine. So whatever smart contracts you are writing is actually going onto this virtual machine, and this virtual machines will execute your smart contracts and put on top of the blockchain itself. So this is how you get your code published on top of the network and to other nodes as well. So what are the releases that has happened? So Metropolis and Serenity were the uh, kind of releases that were done. So Metropolis is like a Ethereum upgrade that was introduced on GitHub for testing, and it was just a matter of time before it goes on live. It is not only uh, introducing further protocol upgrades and opening the other doors for Casper, but also this new interface is for non-technical users was also getting implemented in it. And this actually release will actually uh, gain some kind of adaptation for non-technical users, and this will help developers to create easy to use applications for like other individuals to use, like for you and me guys. So like everyone can do that with the help of this update itself. Serenity is also one another kind of release. This is like a last phase on the Ethereum network, and this release was actually planned in starting of in like January or maybe February of 2018, but like uh, due to like delays in the network, maybe some of the other features that are getting implemented before these things were getting delayed. And what exactly the Serenity goal was to switch from proof of work to proof of stake, which has actually happened. And this is actually implemented in 2022 in the month of June, I think so. And the method that was called was Casper. And yeah, so this is actually kind of a release that has happened over the network itself. So proof of stake has been implemented. Casper of that this Ethereum upgrade was also done for implementing the new interfaces for non-technical users. So what are the development technologies on Ethereum? So in addition to the main Ethereum blockchain protocol, there are also supporting technologies in development that seek to help the network. So the components built on the network run more efficiently. So what are those development technologies? These are the development technologies, like supporting technologies which help to Ethereum to run better. So internet is one, hardware clients is like people miners using mining rigs, like using high performance GPUs like RTX 1080 or maybe another kind of powerful GPUs, whatever are existing currently in the market. uh, we have this consensus algorithms running as a Ethereum node, and these are like Swarm for storage, Whisper for messaging, and EVM for consensus. That are the other supporting technologies. And dApps is like what Web3 technology tools are running, which is similar to what they are running on Web2. So it's like whatever they are running on Web2, they are trying to implementing on Web3 with the name known as dApps. So dApps is nothing but a decentralized application which is built with the help of smart contracts and implemented on top of this Ethereum network itself. And yeah, so this is last of the thing, mist application, which is basically an application for uh, adding the different types of wallets in itself, used for interacting with the smart contracts or the Ethereum network. So you can use Web3.js or Ethers.js and to interact with your smart contract. You can call out your functions of the smart contract, and in return, you can get whatever value is being defined inside that function. And with this library, you will be able to get the addresses, you will be able to get the responses, you'll be able to do other certain calculations that are to be done off chain itself. And you can push out the data, you can pull out the data using this web3.js itself from the Ethereum network. So this is like a diagrammatical representation of what Web3.js is. Let's see what they have written. So the key connection between Ethereum network and your dApp is Web3.js. Allows you to compile, deploy, and interact with your smart contract. So as I was previously telling, this is like a gateway to enter into the smart contract world and interact with everything that smart contracts has to offer as a function. So you can see the tab is just like this is like a user interface, and wherein compiling, deploying, and interacting with smart contracts actually is happening. And once you have written the Solidity code on that like UI itself, that is basically a remix editor or maybe Ganache or Truffle type of tool, which is like used to connect with the uh, Ethereum network. And once you have written a Solidity code, you can just compile using a standalone Solidity compiler, that is an npm package. Those who are all those who are not aware what npm is, so npm is a node package manager which is used to run different kind of packages that has been written for node itself. And Solcy is one which is like a Solidity compiler that is used to compile the codes that are written on top of Solidity itself. Or you can use Web3 compiler as well, uh, like the local Ethereum node Solcy. So what is local Ethereum node Solcy? It is like a you try to mimic Ethereum chain on your local network itself, and a fresh chain is implemented using this tool called Ganache, which gives you like a 10 Ethereum accounts and some ethers, testnet ethers to implement on top of your chain that has been locally added to your PC with the help of this tool called Ganache. So you write the Solidity code, and some bytecode is given back to you, and that is called the ABIs. And then you can, with the help of that, you can, you know, try to interact with it. So once you get the bytecode, you will return the Solidity bytecode, which is basically the ABS, so application binary interfaces. And you get these ABIs from the bytecode and execute the contract functions. And once you do that, you will be able to make these RPC requests with the help of Web3.js. And local Ethereum node you can run either using Ganache or this is tool. There's one more tool called Geth, which is required for you to run and to have an your own Ethereum network running on your local machine. Or you can use like third party services called Infura. So Infura is one of the most important tool, which is has the different APIs to connect with the Ethereum network. So all you need to do is have an account here. So if you see get started, you can create your account from here. or if you once you have able to create your account, you just log in, and this will give you an API key. So this is like a fresh uh not fresh, but it's actually free of cost, and you can do like simple transactions and interact with your smart contract using this APIs. And this will give you like this RPC URL, which you need to connect and add it to your uh, uh, local code. And with this link, you will be able to connect to the Ethereum smart contracts. So it is like a third-party tool which helps you to interact with your smart contract deployed on your Ethereum network. Mhm. And if you need like other just testnet, so you can just scroll down from here and it will change your link, and now you can communicate with the smart contracts that are deployed on your Goerli network. So Goerli, Sepolia, and mainnet are like three different networks. Mainnet being the primary one, which has the value, and Goerli and Sepolia are like the test network, which is just used for testing purposes. And also, you need to have these Ethereum Goerli ETH to interact with your smart contracts. So how do you get your goal leads? You get your goal leads with these faucets. You add your wallet address over here. From you can add it like go back to your account, copy your address, paste it here, and then just send me ETH. So once you fulfill these conditions of sign up and logging in Alchemy, you will be able to get your Goali ETH in your account, just MetaMask account or whatever account you are providing. Yeah, so that is how you interact with different networks. And we have this linear blockchain also, Polygon, which is like a which is like a side chain for Ethereum. And I have previously explained also the concept of Polygon. So yeah, so you can use this as well. Just enable network, and they'll be giving out these RPC URL, so you can just use that to either connect it to the to the main net or to the test network, which is called Mumbai for Polygon. Similarly, you have different other blockchains as well. All you need to do is have this API and you are good to go. We have different tools other than Fura as well. The those tools might be paid one. So if you see simply trends, this quick node. So this is also like a provider for Web3, and you'll be able to communicate with them through with their APIs through the network you're trying to connect to, either mainnet or testnet, whatever. Mm. Can also look for like more Web3 providers. But these actually are the most important one, for which you need to connect with the Ethereum network. Or what you can do is you can just create your own node as well by running this get accounts. So this is like a Web3 provider which helps you to connect with the Ethereum network. You can run this also, and whatever kind of RPC URL it will provide at the end, you can use that with the Web3.js library to then again connect with the. So we understood about Web3.js. So it's nothing but a library to connect with the Ethereum network. Also, similar to Web3.js, we have something called as Ethereum Ethers.js, which is like a somewhat a little better version of it, uh, much more faster. This is like a documentation for it, and you guys want to just have a look, I'll also share this link as well. So this is like a library to help you get connected, basically written on JavaScript as well, and it also has these classes and functions that are available and to available to import manually from sub packages, whereas on Web3.js these things are not available. It will also be able to run from the front end or the back end, and all you need to do is like add it as this as a provider, and then you just add it uh, these lines to just connect this MetaMask functionality to your normal websites. uh, this is how you can just query your blockchains, and what block number it is on, so it will give you like it is on this block number. And this actually completely works on the concept of big number. So yeah, so if you are working with the balances on Ethereum, make sure you convert this to appropriate denominations, or appropriate your data type, and then work upon it. So this is it for Ethers.js. You guys can have a look, like an overview. We'll be using ethers.js or either web3.js to interact with our blockchain. So I'll just show you web3.js also. So installing it, like, it's not a big deal, but just to add it as a package manager, just add it through package manager or yarn, whatever you use, npm or yarn, and then you'll just be able to use this particular library. If you want to read this also, I'm sending you the link. Okay. So what is mist application? So mist application is styled as a decentralized application discovery tool. Mist is actually is meant to serve as a wallet for smart contracts that features graphical user interface. So it gives you a GUI which acts as a wallet for smart contracts. You can able to see what is exactly happening, and you can interact accordingly to with your smart contract using this particular Mist application. So this is like a wallet itself for interactions with the smart contracts. It's a desktop application used to communicate with your node, and it allows user to dynamically set transaction fees and manage custom tokens. So whatever types of smart contracts you have implemented to as a tokens, you can also handle that tokens through your Mist wallet. Also, if you want to add like custom gas fees to it, you can do that as well. Sorry. So what is the exact difference between Mist browser and Ethereum wallet. So as you can see, we have a tabular representation wherein it says that Mist is the browser for decentralized web apps, whereas the Ethereum wallet is also known as the Meteor D dApp wallet, and it is actually used for all purposes itself. The Ethereum wallet app not only focuses on the uh, browser related specific app. So Mist is still in heavy development. It's not recommended to visit untrusted tabs until the full security audit is done. So it is actually in the development phases itself for the Mist one, and people don't tend to use this. They either use these Ethereum wallet apps like MetaMask or maybe some other wallets to interact, but mostly the famous one are Ethereum wallets. But if you have this another browser called Brave browser, you have their wallet as well. So Brave wallet is also there, and Rainbow wallet is also there. The My Ether wallet is also there. So these are like few of the examples for what Ethereum wallet app is, and you can use these to interact with your Ethereum chain to just send and receive the transactions, but you cannot send and receive the data from that particular wallet as of now. So the releases are called Ethereum Wallet, as it is only offers a bundle of Mist browser with a single tap, the wallet. The future with Metropolis releases will provide a full Mist browser that is able to open any tab available out there. So yeah, that is an Ethereum wallet with that and Mist wallet differentiation. So what are Ethereum clients? How current is slide 37? Has all this been fixed? Now, how current is slide 37? Are you asking is it updated or not? Yeah, so Mist wallet and everything like these are not some kind of tools that actually are in like very much of use. People actually tend to use different other wallets, but this was introduced at a very nascent stage, wherein these MetaMask and everything didn't exist. So moving ahead, Ethereum clients. What are Ethereum clients? So Ethereum clients are something that helps you to communicate with the Ethereum infrastructure, Ethereum network. So developers write up contracts with uh, which that are then converted into EVM bytecode via an EVM compiler and uploaded onto the blockchain using an Ethereum client. So there are various clients supporting the Ethereum network. Let's see what clients are and what purpose do they solve. So client is nothing but a interface to help you implement your smart contracts and interact with your Ethereum network itself and with other smart contracts as well. Since the start of the Ethereum project, there have been very multiple client implementations across the range of different operating systems and programming languages. This client diversity is essential for the long-term health of the Ethereum network. So people just run these clients, connect them as your nodes, which is actually storing all the ledgers and updating all the network and acting as an active participants to maintain a consensus and make the network strong by running the client network itself. So Ethereum clients are software that allows users to approve transactions slash blocks, create, manage accounts on Ethereum, send, receive transactions to and from your Ethereum accounts, deploy smart contracts onto the blockchain, and mine Ether on the Ethereum blockchain. So basically, when you run a client node, you actually become a node that it has the capability to mine the transactions, or just to be on the other side to either come interact with the other smart contracts, or deploy your own smart contracts. Whatever you want to do, you can just run that type of node client to be able to connect it with the Ethereum network itself. So what are the list of Ethereum clients? Get. So this is like the famous one that we were just seeing, this Go Ethereum. It is like an gateway into the decentralized web. So if you want to uh, interact with any kind of smart contracts, you need your Get up and running, and whatever kind of URL, RPC URL it will provide. You need that particular URL to implement in your code if you want your code to be interacting with these your your Ethereum accounts. And also, once you are like up and able to up and run this particular client, you'll be able to see all the transactions, store all the transaction on your block local node itself. So that is also one thing that it will do. So it requires a lot of storage if you are running a Get application as of now. So yeah, so next is Parity. Parity is another type of client, which is similar to what Go Get is doing. CBB Ethereum. So these are like a very old one. I think so. They are not in use also. But these are some kind of clients you can use to connect with Ethereum as well. Ethab, Ethereum JS library, and so on and so forth. So let's see what Go Ethereum is. So Geth is client is commonly referred to as Geth, which supports the running of a full Ethereum node implemented in Golang. So this is actually uh, im- implemented in Go language itself, and everything inside it supports that programming language only. What exactly it has to offer? It has like integrated with the Mist browser. You have the light client wherein you just have to download all your what do you say, block headers and previous block headers for references. And also you can do stuff other stuff with this. Swarm is like a you know Swarm is actually, what was it, storage part of it, and Whisper is just for messaging part when it comes to this Get itself. So it offers all these features on top of your when you run this Go Ethereum client. So you can just go in here and see how you get started with Get, and you need to just run these. This will be for, I think so. For Windows is also there, Ubuntu is also there, and uh, other operating system as well. But they are starting with Mac OS. So for Windows, if you want to do, you can just do it with package install Go Ethereum clients, and you can run this in Docker as well. Okay, there are no questions. I see. So what are platform functions? So platform functions in Ethereum. While the architecture of the network is certainly impressive, it's what built on these intricate components that truly illustrates Ethereum potential. So let's have a look at various platform functions in Ethereum. So we have seen this DAO. So as we all know, these are the organizations that exist entirely on a blockchain and are governed by their protocols. So whatever protocols they implement is actually written beforehand itself when you are implementing a DAO tool. a unison of many long-term smart contracts between people. So uh, DAOs are nothing but like like group of smart contracts working together to uh, maintain the flow of the DAO, and other rules and regulations that are implemented uh, are actually written inside that smart contract itself to make it as a decentralized autonomous organization. So it is like once implemented, you cannot change it, but you can change it with either the vote or like update it. But that particular thing will be existing forever. So whatever changes you like make it to next time, it will be appended only. So everything is like a decentralized and autonomous, made it automated in this organization itself in the starting. So DAOs are designed to hold on to assets and use kind of voting system to manage their distribution. So nothing happens without the vote. So everything you have to decide for the community is using the vote. Either they are for or against it. And for this, they used to the organization members will actually be given out some their organization's tokens, and that will make sure that you are able to vote or not with their certain kind of protocols that they have implemented earlier in the smart contracts itself. So that is like a main thing, prerequisites to have if you want to interact with those DAOs itself. So like if in nouns, you have to have these nouns tokens with you to be able to vote, because voting also requires some kind of fees to be implemented. And if you want to say yes, then some kind of fees is actually being deducted from your account. Okay, so next is two or more entities in a DAO can interact with the each other in a fully decentralized and automated fashion. So different entities can also be able to have a like interaction with each other or use their functionalities when in like an automated way and in a decentralized way. So it is not controlled by anyone, but the consensus algorithms that has been implemented behind the organization itself. DAO compromises a global network of nodes and members that all work together. So everyone is has to offer something or the other when they are connected to the organizations, and they will be like adding value when they are connected to the organization itself. In DAO, each action or votes is represented by the form of transaction in the blockchain. So what, like as we know, blockchain everything is represented in the form of transaction. So in similar way in DAO also everything is like represented in the form of transaction, and a group of people writes a smart contract to govern the organization. And like you predefined types of rules and protocols you want to add in the smart contract, and that will run throughout the life cycle of a DAO. People add funds to the DAO and are given tokens that represents the ownership. So it's like a membership tokens that you will get once you are in inside that particular DAO. It can be either tokens or it can be NFTs or it can be any kind of ERC standard tokens. That depends on what the developers are trying to write and how they are trying to implement it. The DAO begins to operate by having members to propose how to spend the money. So the first vote is actually like asked by the general users who are connected to the network on wherein what all part is required to spend the money and how they can improve the their organization itself. So similar to what we do in our normal traditional organizations, how to improve it, how to enhance the performance and everything. So in that way, in the similar way, we do it in the decentralized autonom in these DAOs as well. and uh, the members vote on these proposals, so they decide if they want to go ahead with it or not. And if they don't want to go ahead with it, so they'll just vote against it with their tokens. And if they want, they can just go ahead with it. And the amount of percentage that is for and against will actually determine if the that particular feature or the implementation that has been proposed is to be implemented or not. When the predetermined time has passed and the predetermined number of votes has acc- accrued, the proposal passes and other fails. So yeah, so similar to what there's a kind of deadline to it. And according to that deadline, if you have voted, that vote will be recorded, and otherwise it will not be recorded, and the results will vary, and either it will be implemented or it will not. And individuals act as a contractors to service the DAO. So yeah, so any node can be acting as the contractors to either update the DAO or provide any kind of services to it if they want. So this is like an example of it. Uh, these are the steps, 6 steps. So first, it says a country holds an election and wants to prevent voter fraud. So it's like in the elections these days, a lot of news comes up to the news media partners that these machines are rigged, or the votes are actually rigged and only goes to one particular political parties. So these can be solved using the DAO or the blockchain itself, as it is a very a powerful use case for blockchain online voting system. So let's see what it has to offer. A country holds an election and wants to prevent voter fraud. A DAO should be created to safeguard the transparency and eliminate vote rigging. How does this happen? Since everything will be like in front of you, like in on the public ledger itself, anyone or any person can view what is happening, what is by looking into the transaction and who all has voted. Uh, a person who is trying to vote will actually be getting that vote, and he or she is not eligible to vote twice or maybe more than one time. So whatever it is, it will actually be uh, consistently being noticed, and everyone is actually being able to watch that particular ledger itself on the uh, DAO's on the DAO network itself. This is ensured by embedding the predefined conditions into the code. So whatever codes you whatever rules you want to write, you can add it to that smart contract for the voting purposes. Like a person should be more than the age of 18, and he or she should have like Aadhaar cards or maybe any other kind of social security numbers with themselves to be able to vote, or some kind of voting ID card to be pre given to them. So then only they'll be able to vote, otherwise not. Whatever conditions that may be, you can write in number of conditions for that. Voting tokens are issued to everybody eligible to vote, and as soon as you get connected to it, as you know, some kind of membership tokens are given to the people who are like willing to vote or are actually connected to the network. People start to vote, and every vote is recorded and processed on the Ethereum blockchain, which ensures transparency while allowing everything to be run by itself and to be decentralized. So nothing is controlled by anyone. Once you write the smart contracts, everything will be automated and will be done by the program itself, but no human intervention will be there, which will make it like fault tolerant. Second of things, it will be less expensive optimized, but the only thing is people can hack it if you don't write these smart contracts with the certain set of rules that are meant to be written with, like the best practices that you need to follow. So make sure you write with the best practices so that your smart contracts doesn't have any vulnerabilities and no malicious person can exploit it. And that's how the DAO works, and that's how the voting mechanism works on top of DAO. dApps. So dApps is actually a decentralized applications, which are like a computer applications that operate over blockchain itself, enabling direct interaction between the end users and the providers. So when you create a dApp, all you need is a few smart contracts that you will just deploy it on the Ethereum blockchain itself, and you need a smart contract interface. Sorry, a UI basically, which you can develop on either of the languages like Django, Angular, React, or any of the other languages that you know, and call out these APIs basically, and make a interactive UI just to start your own decentralized applications. And these dApp actually can be compromised of a single DAO, or even a series of DAO that work together to create an application. So it doesn't matter how many DAOs are there in the decentralized applications. Together, if they satisfy an agenda, there can be an n number of DAOs in a decentralized application. A decentralized application has also an unbounded number of participants on all sides of the market. So there is no foundation for this that such. And if you see, this is like an game called Etheria dot world, which is like a Minecraft game and is a decentralized application on uh, this Ethereum network itself. So we should just visit it. So you see, this is like a real verse first land and metaverse blockchain that is built upon this Ethereum itself. So this is like a customized NFTs and stuff like that on the network itself. Uh, you can view these instructions on how to play, and they will just uh, tell you how to work with the command line part itself. So first of all, you need to install a command line interface. So you might need some kind of client, basically a get or parity one, to interact it with the command line interface, and then you can just create an account with the get itself. And once you get that account ready, all you need to do is go to a faucet and just try and get some ether. And if you would like, actually this is on mainnet, so you can just go and buy from an exchange and then transfer it to your Ethereum based account that you just have created from the get itself. So this is like an interface wherein once you have installed get and everything, you can just start to write the variables inside the command line interface itself, and then you can just look into the map and see what unknown tile is left, and you can just pay and or start to own it. And if they've kind of have some network troubles with the this application itself, they either retrieve, you can just the transaction actually gets reverted back to your account, and then you can there's also this instruction where you can't buy the water tiles, and excluding water tiles you can just buy whatever the things are in green or maybe like yellow tiles if you see before. And you can do your stuff whatever you if anyone has played Minecraft, it's very much similar to what Minecraft has to offer. Sorry for that. uh and yeah, so that is it, guys. If you want to like visit this, you can just take this itself. So I'll just share it in the chat itself. Yeah, guys, if you want to play like this video game, you can do that as well. And see what exactly this thing has to offer. And you can see this map that completely is on the game, and you can just start to buy things and go inside what this is. So before going into this, I'll like encourage everyone to just uh, like read this exact documentation of how do you play a game on top of Ethereum itself. And yeah, so you'll be in no time playing a game itself. So make sure like you have the main net ether instead of testnet ether. Otherwise, it will be difficult for you to, have like you'll not be able to play because you need gas fees and everything to just play on the this application itself. Also, they have like a Discord channel for people who were wondering what Discord is. So it's like an application wherein you just get in and have a word with the community and ask your doubts if there's any. All you need to do is just verify it by the phone, and some interface will be like this. Just show it quickly. So interface will be something like this. And there will be some kind of channels over here which you can go inside, and these channels will be specific to what the name has been mentioned over here, and you can just go inside and interact with different participants who are actually playing the game, or people from this like who has developed this game, or maybe some kind of technical supports from their this network itself. So Discord in that case is actually very helpful if you just want immediate assistance for the applications. Yeah, so if you want like this Discord channel, so I'll just copy this also and just send it to you. This is like a real world example for the game itself. And moving ahead, what are the types of tabs? So we have like three types of dApps, wherein one is a peer-to-peer transaction one is an external authorities one, that is oracles, and one is a peer decision maker. So like inside the network, there are only peers who will be making out the decisions, like something of a DAO. So what is a peer-to-peer transaction? So a peer-to-peer transaction is, as the name suggests, transaction between one and other peers, and a user may need to exchange like some kind of digital transaction, maybe ether or maybe other tokens inside it, that is wrapped ETH, or stable coins like USDT, or maybe some other token like Brave, to be traded amongst each other. And they can do also like uh, use this network to uses network to networks distributed computer nodes to facilitate the distribution of the data. So it's like whoever is the nearest peer will actually be sending out the information to the next peer until or unless it has been reached to that particular person itself. So that is like a peer-to-peer transaction. And we have like something of an external authorities as well, which is like smart contract doesn't facilitate the functioning of calling out the external API. So say suppose I am working in like I'm trying to build some kind of let's say crop insurance application, and Actually, that is dependent upon the weather itself. So, say suppose a person they wanted to assess if the rainfall was there, or maybe some kind of storm was there, to inspect if that particular thing has that particular crops has been destroyed by the natural calamity or maybe some other kind of reason. So to sorry for that. To get that information, we'll be calling out those external APIs using the help of oracles, and that oracles will actually get that information from that APIs to our smart contracts, and we can manipulate those data as and what we are building. And yeah, so this peer decision makers, we have also already understood the concept of DAO, which is like a decentralized autonomous organization form where it is like a leaderless company, and you just in the beginning program some rules and mention how the proposals will be submitted and how the votes will be happening. And once you are inside it, you'll just be getting the member tokens, and you can just start to do the thing that you came upon when you joined this DAO organizations. So yeah, these are the three types of dApps in a nutshell. And let's see what a future lies for the dApps itself. The future of the decentralized applications. So as Ethereum and other projects have made writing dApp protocols quicker and more accessible, a number of possible disruptive dApps have appeared, like KYC chain, which allows the users to maintain a private identity wallet, which can also be used to authenticate their identification in finance, legal, or commerce settings. So there are some kind of applications which requires you to abide by the KYC and AML. Otherwise, you won't be able to, you know, deploy your network without these government agencies troubling you. So in that case, this KYC chain dApp is actually a very functional thing, wherein you can just maintain your identity wallet as well with the addresses, and you can use this to also do your KYC and other stuffs that is required by the just governing bodies itself. So next we have like VFund, which is like uses the smart contracts to enhance crowdfunding services, including GoFundMe and Kickstarter. So this is like something of a tool wherein uh, these services like Kickstarter and crowdfunding use this to actually make like a smart contract to automate all these funds from the a business owner who's trying to raise the funds and from the investors who are trying to invest their money on a good project. So this actually brings out the whole thing inside that. And we have Storage also, which is like a a cloud storage basically, and it provides you a censorship free, secure, and zero downtime distributed cloud storage by sharing the data and storing it among a decentralized networks of computers itself. So with Storage, once you are there, you can just install it using their docs itself, and you can use their storage. It's around maybe 150 GB at first, which is free, and you can store your data on top of Storage itself by just running few of the commands from the command line interface itself. Next, we have another form of a decentralized application called 4G Capital that provides microloans to small businesses in Africa by utilizing smart contracts. So they'll be just going out there and registering their addresses and proposing out their business ideas. And once the business ideas has been proposed, they can add the functionality of voting either to uh, provide the funds to them with the help of the organized peers peers what do you say
What are some of the tools and resources available for setting up and managing a private blockchain? Option A, cloud-based blockchain platform as a service. Option B, open source blockchain frameworks like Hyperledger, Fabric, or Corda. Option C, development tools and libraries for specific blockchain platforms. Or option D, expertise from blockchain consultants and service providers.
Just a quick info guys, Intellipaat offers you a blockchain certification course which will help you become an expert in distributed ledger technology, Ethereum, Solidity program and many more. Through this course, you will also receive additional courses co-created with IBM, namely IBM Blockchain Foundational Developer, and deploy a web-based blockchain insurance application. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description. Without a doubt, this course can set your careers to a new height. So visit the course page link given in the description below and take the first step towards career growth with the blockchain tech stack.
Peers like acceptance of the project, or otherwise you can also make it like installation of the normal business owner's loan, like we provided in the traditional part, wherein you just go to a small capital, small bank and deposit your fund, your project report, and according to that, they'll just give out you the project, funds according to the details that you have given, and what all money do you need. So something like that will be of an idea of 4G Capital. And you can also see a curated collection of various dApps at this particular website itself, and you can just go to the state of the dApps.com and you will be able to see different other websites as well that is functioning on Ethereum network as of now. So that was the basic theoretical part of Ethereum. Now we'll be delving into more technical stuff. When we say technical stuff, we'll be just focusing upon writing, like understanding the basic syntaxes of Solidity as a language and what Solidity has to offer. Till then, guys, do you have any questions about dApps or anything that you would like me to explain it to you? There's nothing you guys want to understand. Okay, everything is understood. So let's start with Solidity. So what is Solidity? Solidity is actually the basic programming language through which you design your smart contracts and write all the smart contract related codes. Ethereum would be incomplete without a native programming language, and that is actually the Solidity language, which is actually used as a core concept for the Ethereum language itself. We have other programming languages also, Viper and LLL, but the most famous one is the Solidity, and this course will be focusing upon Solidity itself. Sorry. We'll be starting with the just a theoretical part and delving more into technical stuff after the slides. Let's start. What is Solidity? Solidity is actually a contract-oriented high-level language whose syntax is more or less similar to that of JavaScript. It is designed to target the EVM, and whatever code you deploy, it's actually deployed on the EVM itself and then to the main network. So EVM it's the compiles the language, compiles the code and gives you the output, whatever it is. And once you deploy it, it sends out to the network once it has been error free and has the desired function that it has to do. Solidity is actually a statically typed, and it supports inheritance libraries and complex user-defined types, among other features as well. So it is not dynamically typed, so everything is like done one by one, and it is not like other languages like JavaScript and in the way of functioning, but the syntax is more or less same to what JavaScript has to offer. In contrast to object-oriented languages, Solidity is contract-oriented. So you have this concepts of polymorphism, inheritance, and encapsulation in it, and you can do that. Sort of functioning inside Solidity as well. It compiles instructions into bytecode so that they can be read by the network. So whatever it is compiled, it works on different EVM bytecodes, and once it converts to the bytecodes, it will be actually be seen on the network itself. So, what is like a layout of a Solidity contract? So first of all, you just define the what kind of versions you are using. Before that, you also provide the what kind of licenses you will be using. And in this, you can use like remix.ethereum.org, which is like the infrastructure for writing out the smart contracts itself. All you need to do is go inside a smart contract, and you can just see this is like a basic smart contracts that they provide. And to start with, they provide you with the smart contract license identifier, which if you remove it will just start to give out you the warnings, and it is very mandatory for you to add this. Besides that, you provide which kind of Solidity versions you'll be using, and you can just provide like this, or maybe something like a caret sign and then 0.8.0. This actually states that you will be using the Solidity versions which is above 0.8.0, and below this the code will actually be crashing or throwing you errors if you use like syntaxes from which are previously written in either Solidity version 0.4.0 or maybe something below that. Yeah, so this is like a contract. This is how you define a contract, and which acts like a class, and this is just a basic structure wherein you define the contract name, and inside that you provide the just different uh, variables and write down the functionality of what exactly this contract has to do. So once you have provided the version, which is something like this, source file can and should be annotated with a so-called version pragma to reject being compiled with the future compiler versions that might introduce incompatible changes, as I earlier was mentioning as well. Such a source file will not compile with the compiler and earlier versions than 0.4.0, and it will not work on a compiler starting with the version 0.5.0 or 0.4.0, whatever you have mentioned over here. Okay, so what is like a comparison between memory and storage? So memory and storage is like RAM and ROM in this Solidity itself. They are analogous to memory and hard drive storage in the computer itself. So what is memory? Memory is like the contract can use any amount of memory while executing its code, but the execution stops. But when the execution stops, entire content of the memory is wiped out and the execution will start fresh. So whatever you have stored in the memory, it will just keep on wiping as soon as the functionality of one function has been completed. But on the case of storage, once you store the data of blockchain inside the storage, it will actually be stored on blockchain permanently. So it's like uh, persisting throughout the life cycle, and once you have added to the blockchain, it gets appended and it can never be deleted. So every time you want to refer what was the earlier value in the state variable or the storage variable, you can just go throughout the internet and check the transactions what have been previously executed. So you will be able to find out what exactly the data was previously and currently. So that is the role of memory and storage inside this Solidity network itself. So also this memory is whatever the data you store on memory will not execute any kind of gas fees. So these things it's since it is not getting stored on blockchain itself, so it does not need to provide any kind of transaction fees. And since the data gets wiped as soon as the functioning is over, so you won't need to provide any kind of gas fees to it. But whereas it comes to state variables or storage, when it comes to storage, the gas fees is actually implemented or provided to store the value inside the state variable itself, because this is like storing the data on top of blockchain. And as you know, guys, on blockchain, if you have to do anything, you have to provide some kind of gas fees or the transaction fees for the miners to mine your transaction and store it on the block itself. Okay, so we have these general value types, which is Boolean and integers. And since I think so, you guys are technical enough, so you will be having an understanding what Boolean is. So if you don't know, so I'll just let you know the Boolean is like kind of a value of true and false, and no other values can be added to it. And so yeah, so no other kind of values can be added to it. Whereas in integers, you will be using two types of integer itself, which is integer int and uint, which is like assigned and unsigned integers of various values. So you can define this int like int and uint will like uint, and we have different byte size to it, from ranging from 8 to 256, sorry, bits, and which is same for integer and unsigned integer. And the value is like starting from 8 bits to 256. According to that, the value will be stored in that particular variable itself. So we'll be seeing further ahead how the values are actually getting inside the variables. Or if you want to see right now, you can see here we have defined, this is how we define a variable for an unsigned integer 256. This is using like a number till 256 bits can be stored inside it. And yeah, that's how you kind of start with the uh, uh, declaring a variables inside a Solidity language. Okay. Uh, yeah. So next is like general value types itself, and it's like addresses. So what are addresses? Addresses, we have previously seen. So address is like 42 bits of hexadecimal value, which is stored in 20 byte uh, which holds the 20 byte value itself. That is the size of Ethereum address. And address types are also have members and server base for all contracts. So as we have defined earlier, that externally owned accounts and contract accounts have different addresses as well. So according to that, it will function in the Ethereum network itself. Member of addresses can do this balance and transfer. And it is possible to query the balance of an address, also of a smart contract as well, using the property called balance itself. And to send ether to an address using the you can use this transfer function to transfer the value from the smart contract or from the external owner's account to that particular person's account, whomsoever you're trying to send. So this is how you send. This is a small example wherein you just provide the version. This is a variable. Variable is type of an address, and we have named it as X. Whatever can be the value. The value will be something similar to what we have seen earlier in the MetaMask itself. And this is actually picking up uh, our address itself with the keyword this, which will fetch the address of whomsoever is calling out the contract. So just writing out a normal if condition that if the balance is less than 10 and the balance of my address is greater than 10, then you just need to transfer it to the X's balance. So yeah, that is all about it. That is how you just write a minimal contract. It will although not execute because you need to provide the contract uh, this contract name, and inside that you provide out some kind of or maybe a function to it so that you'll be able to see a value. But also you can just given for the demo purposes to just understand how do you write a small basic function of checking out the balance for a particular person, and how do you can transfer some kind of amounts to that particular person itself. So, what are string literals? String literals can be written in either double quotes or single quotes, and these string literals, like as you can see, we have provided foo as in double quotes and single quotes. Both are acceptable in Solidity languages. They do not imply trailing zeros as in C. So, like in C, if you just write hello, so in the last you will be able to see it's implementing it as or storing it as /0, wherein the value increases to 4 bytes for this particular foo itself. But not in case in Solidity, as it is not implying the trailing zeros, and the value that is currently stored as foo will be stored as it is. So that is how the string literals work in Solidity. And as with integer literals, their types can vary, and but the implicitly convertible from bytes 1 to bytes 32 is also being possible if they fit to bytes and to string itself. So string literal support escape characters also like /n to go to the next line, /x or nn for different other functioning as well. And if you are from the background of C, you will be knowing what exactly this is doing. I think so. Preeti and Prabhu, I think so, are well versed with C, right? Ramakrishnan is also familiar with C, but is also familiar with JavaScript as well. Uh, yeah, so I think so you will guys be able to quickly pick it up. Okay, so we'll start with this. Okay, so we have also explained what this is doing. So it takes the hex value and inserts the appropriate byte, while this particular value takes a Unicode point and inserts it to the UTF based sequence. So this is also supported in Solidity itself. So if you want to do some kind of programming related to it, you can just do it. So we have arrays inside it. Arrays can be fixed and dynamic, and that is similar to what other languages also provide. For storage arrays, the element type can be arbitrary, so it is not has to be fixed. It can be arbitrary as well. For memory arrays, it cannot be mapping. So make sure that you keep in mind that memory arrays is not equal to the mapping itself. And what is mapping? Mapping is something of like an data type itself, wherein the values are stored in the form of key and values. So like in other languages, it's called, I think so, object in JavaScript. In dictionaries, it's in sorry, Python it's called dictionaries and stuff like that. So as according to that, it is actually storing the values in key and value. So uh, however you're comfortable with the language, you can just understand like that. An array of fixed size k and element type t is written as like t of k. So this is like the array element type, and this is the size that you want the array to be. A dynamic is actually written as just t, and you don't provide any value. And as and when you are kind of adding the values to it, it will kind of increase the array size. Variable of type bytes and strings are like special arrays. We'll see further ahead also how it is written. And arrays of length members have a length member to hold their number of elements. Dynamic storage arrays and bytes have member function called push that can be used to append and at the end of the array. So we have this functioning of push for appending to whatever data you want to add it inside the array itself. And I think so pop is also valid in Solidity as well. So apportioning memory arrays. So creating arrays with variable length in memory can be done using the new keyword as well. So if you see here in this function itself, once you provide this new keyword, you will be able to uh, add the value to that particular size of the array itself. And as opposed to storage array, it is not possible to resize memory arrays by assigning to the length of the number. So in here, you can see uh, the storage arrays is not able to add the values or change the size of the values to that particular itself. So you see bytes is like a special storage of array that we just saw, but over here you can just provide like a new keyword and you can just add this value to whatever the size of the array you want. So allocating storage in variable to memory arrays. So this is some kind of an unnamed array in storage, but storage is no sensible location it could point to. So it provides you like the exact storage from where it can be stored, and depending upon how you handle it, you can just provide it either by adding the keyword storage or the memory, however you want to store it. And this is some kind of an example for the same, wherein the function g is taking actually an unsigned integer of a dynamic size of an array and just getting stored in the storage variable. And the storage array is actually the name of the variable itself, whatever is getting stored in this unsigned integer. And this is like a function modifier, wherein this will tell the functions visibility. And so it's like an internal function, and it can be only be called by the this function which is inside that particular contract itself. No other function can call it. By default, the value of a function is actually private. There are four kind of visibility modifiers. First is the public, which is accessible by all, and there's no limitations on who can access it. Then comes the private, which is actually being able to call by the same function or the inherited function itself. And then comes internal, which is actually the function calling out the same function, calling out the same function which is inside the same contract itself. And there's also another visibility modifier called external, which is actually used to call out the function from other contract itself. No one can call that contract from the same functions or the other function only. So this is how you provide like the storage and memory part of it. And by default, it is actually taking the memory variable itself, but if you don't provide the memory keyword, it will actually give you an warning that this particular not a warning but an error that this particular has to be given some kind of storage, either memory or storage variable itself. So here is another example as well, wherein you provide the data. So by general, the variables defined in the starting of the contract is actually stored as in the storage variables, which is like of you know like which is like provide the gas fees on itself. It's a state variable, and every state variable is like having the value that has to be stored on top of the contract. And when I say value, I mean in terms of gas. And for the memory array, you just provide like the data location, like this function f, it has the uint memory array, as we have seen earlier in the previous slide as well. So if you want to copy the value from memory array to x, or you can just do it by providing something like this: x equals to memory array, and whatever is in memory array will be added to x itself. And this y7 is like acting as an fixed length of array, which is like the eighth element inside it. And y dot length is actually modifies x through y. So whatever the value of x inside it is will be modified by the length of 2. And delete is actually, as we all know, is for clearing out the array, so also modifies it by the y. So whatever functioning you are doing in the state variable, it will actually be costing you gas. So the following does not work. It would need to create a temporary array itself. So what we have further ahead is the array literals, or the inline array, which will come to the part of, sorry. So array literals is like are the arrays that are written as an expression and are not assigned to a variable right away. So it like as and when functioning happens in the smart contract, the array literals works according to it. A type of an array, this is like a type of an array literal is the memory array of fixed size whose space type is a common type of giving these elements. So this is like and common example for it. So if you see contract C with function f is actually having type, sorry, a variable type as g, wherein the uint value is in the form of array, and the first indice is actually the unsigned integer with no specific value of how many bytes it is, so how many bits it is. So it naturally takes around 256 bit itself, and 2 and 3 are already implied, where as the that is how it is stored in the array literals as well. And in function g, if you see this uint 3 of data, so it's like a dynamic size of an array, wherein it will not have values more than the 0, 1 and 2 inside this data itself. So this is how you define an array literal inside the smart contract itself. So now comes the part of mapping, which is like a very important concept. Mapping, as I told you earlier, it's something to something related to key and value, which is like objects in JavaScript, tuple dictionaries in this Python itself. Mappings is defined something like this. Mapping, you can just add this value, and according to that you can just provide the function, visibility modifier like public, and give out the name and a semicolon. That's how you define the mapping itself. Here key type can almost be any type except the dynamically sized array, a contract, or an enum, and a struct. So these cannot be the value, or besides this, you can just do anything. And for the value type, it can be actually of any type, including mappings itself. So to create a nesting of mappings, you can just provide the key type, which is like a starter type array, or maybe a normal integer, a normal data type like int uint string, sorry, character string, or bytes. And then you can provide mappings, and then you can again provide the key and value inside that mapping itself, to do some kind of an object inside an object type of functioning in this smart contract itself. So, mappings can be seen as a hash table, which are virtually initialized such that every possible key exists and is mapped to a value whose byte representation is all zero, type's default value. So it's something like this. The similarity ends here, though the key data is not actually stored in the mapping. Only its hash is used to look up to the value. So the value is converted into hash and stored inside the something of mappings, which is actually called as a hash table itself. So this is an example for this mappings as well, wherein you can use to store balances of a particular person who is calling out this function. So mapping is actually storing out the addresses along with what kind of balances do they have inside this unsigned integer. So if you see function update, and you just want a new balance uh, uh, to update the balances itself. So you will just call out this balances mapping here with the message.sender as the address, and you'll store the value as the new balance itself. Whenever you call this function with the new balance, it will update the balances of that particular address with the new balance itself. So that is how it will do. And this is like some kind of another contract, wherein this contract mapping user will call out this mapping example itself. So you provide like some of a function f that returns uint integer, and inside that function you're calling the mapping example m, which is this contract itself, and you're assigned to a variable called m, which will inherit all the value. And now with the new keyword, you can just call out this function call update, and you just do like m dot update at 100, so it will give you this new balance as 100, and that particular this contract will be updated with the contract address will be updated with the value of 100, and this will actually return the m dot balances dot this. So that is how you will be able to send out the balances to that particular contract itself with the updated balance. So this is a very good example for how you can write basic mappings, and as and when we proceed further ahead, we'll be using out these mappings a lot. So yeah. Now we have something called as enums. As you all know, enums are the way to create the user-defined types in Solidity. So you can create your own enums like stop, go, or maybe some other kind of things like read, write, update, or store. So you can define anything according to your use cases and use them explicitly in your this uh, smart contract itself. Enums are actually explicitly convertible to and from all integer types, but implicit conversion is not allowed in when it comes to enums. Enums, this explicit conversions check the value ranges at runtime, and a failure causes an exception, and enums needs at least one member inside it to, have a particular value be implemented. Otherwise, it will just throw out the warnings to you. Okay, so how do you write a enum? So this is like a smart contract test wherein we have some action choices. We have provided these values as go left, go right, go straight, still, still, and we have defined it as the enums as action choices, as choice itself. So when we call this, we call inside a constant this value, wherein we choose what kind of enums we want, and this is how we do it. Action choices, constant default choice. This is the variable name for it, and action choices we can just provide like go straight or maybe sit still or go right, whatever we are trying to call. We are just providing it with the dot notation itself to go inside and call these values. So I think so this is very much similar to what we do it in other languages as well. And yeah, so this is how you call it, and can just define a function set go straight and make your choice like action choices to either of the enums that are available with you in the choice function itself. So yeah, if you want to choose like action choices dot go straight, you can define this variable, and this is how you'll be able to call out the enums. This will be very important as well, because there are sometimes you just need a predefined type, and in most of the language sometimes it doesn't exist. So you want something like this to be existing in a language so that it is much more easier for you or anyone else to understand what exactly is going on in the code. So we have structs. So structs is like this particular that provides a way to define new types in the form of structs. So structs are like custom defined types that can group several variables together. So inside this, you can provide either integer, address type, bytes, booleans, whatever it is, you can provide inside the structs itself. Struct types can be used inside mappings, arrays, and they can itself contain mappings array of mappings and arrays. It is not possible for struct to contain a member of its own type. So struct inside a struct is actually not possible, although struct itself can be the value. So yeah, so if you see, this is some kind of a smart contract wherein you uh, provide like online voting system, and sorry inside that smart contract, you have written as a ballet and create a structure wherein you have defined the values of the voter. So voter should have like uh, weight 1 to whatever the like value of that particular voter is. You can provide if he has voted or not, an address, if he wants to either delegate it, or if like trace who has voted inside the smart contracts. And you can also define the number of voters, how many times the voters can vote, and so on and so forth. Yeah, so this is it, and this is like a struct that can only have like 16 member, exceeding which the following error might be the stack too deep. So inside this, you can just provide like 16 members to it, although you might not need that many. You'll just be needing, I think so, 6 to 7 max. But in some cases, if it happens, then you need to just delegate your structs accordingly, or maybe just shorten your structures types inside it. Okay, so these are like predefined types of available variables and functions, and the function variables are like they are special variables which a smart contract actually understand, and it is like a global namespace. So if you try to do something kind of this will actually throw you error and tell you that this is like a global namespace and are mainly used to provide information about the blockchain. So something of that kind, it will give you an error. So what are these properties? These are properties are like you getting the block hash. You can just do as block hash, and it will give you the block hash of that particular block number itself. And this is how you will be returning the value also if you call in the function type as well. The Coinbase is actually the block minus address whoever has actually mined that particular block will be with this block.coinbase, you will be able to fetch that address of that particular miner. And this is like the difficulty of the block. What is the exact difficulty? What theta hashes per second is actually recorded in that. You can call it with this. Gas limit is like how much is the limit that is required, the minimum limit that is required to execute this particular transaction. And the block number is like the current number of the block you want to see, and this is timestamp whatever the time it has been currently mined. So it will provide you an epoch type. So those of you like epoch is like, I think everyone is like well aware about what epoch is, but for Mahesh, actually epoch is something like this. So this is like something which is understood by the virtual machine EVM itself, and you can convert it to the normal date also inside the smart contract, or just convert it to other epoch timing in the smart contract itself. So what are these global type of available variables and functions? So we have something called as message data. So in Solidity, message data is a global variable that contains the complete call data of the current function call. Call data is a like a special area of memory where function arguments are stored, and when an external function is called, it also contains the function selector. That's the first 4 bytes of call data, which will identify what function is actually being called. I'm so sorry. So this function for this message data is actually a complete call data, special memory, where function arguments are actually stored in are stored when an external function is called. So yeah. So inside a message data, there are first 4 bytes is of the function selector itself, which is a very unique identifier generated by the Solidity compiler, and it is based on the function name and its parameter types. Uh, Message data is actually also used to determine which function in the smart contract should be invoked. And the remaining bytes in like first 4 bytes, as you all know, is the function name. Then the remaining byte will be of the message data itself, that will contain the serialized input arguments passed to that particular function itself. These actually things are encoded in the Ethereum ABI, and these, if you want to see, will be so this is the contract code, and whatever the functioning has been written is actually being stored in this contract ABI, which is used by Web3.js for calling out your smart contracts from the external, either your web front end or the back end, whatever you are trying to call with. So these are the ABIs. That is the main thing for all the functions. And if you could like read it like very focusedly, you'll be able to see these function names and everything inside this ABI itself. Okay, so this was message data. Do you guys want to see an example how the message data is actually working? Or should I just move on with the other? I should just move. Okay. So for message sender, it's like you're calling out the addresses for that particular sender who is invoking the function. Message sender will actually fetch you the address of the person who is actually calling out the function. And yeah, that is the only job of it. Message.sig is like another type of global variable itself, and it will often used to identify which function is being called in the smart contract. When the function when the function is called in a smart contract, the EVM encodes the function's name and parameters into this unique 4-byte identifiers, and which is called the function selector. And the function selector is included as the first 4 bytes in the message data, as we have already learned here. And when the function is called, the message sig allows you to access that function selector itself. So that is the job of the message sig, to actually help you call out that message function selector itself directly without manually parsing it with the other message data also. Besides this, we have message.value. So message.value is like a number of ways sent with the message. So you can provide any kind of information inside it, and also with that you can attach the number of ethers sent with the function. It allows you to access the value is actually in way to make sure whatever the value you're getting sent, or you're sending it, is actually in weights, either converted into ETH or maybe another kind of denomination, but this will actually send out the messages in way itself. So now moving ahead is actually the current block timestamp. So whatever is being called, it will send you in the form of epoch. That's why it is event. This is for the transaction gas price of the transaction as itself. So whatever is the current gas price of the transaction, it will give out that value. And yeah, so you'll be able to fetch that value in the form of integer itself. So as soon as you call it, like the number of gas you want to provide, you can just provide it in way and you'll be able to send out the transaction. The transaction origin is actually the sender of the transaction, and it will be just used to call out the address, and the origin, that particular address will be sent to the the transaction will be sent to that particular address itself. So what kind of mathematical functions you can do? You can do add mod, multiply mod, which is like add mod is, as the name suggests, adding out the computing out the numbers x and y, and then where the addition is performed with arbitrary precisions and does not wrap around the 2 to the power of 256. Whereas in the multiply mod, the multiplication is performed with the arbitrary precision and does not wrap around the 2 to the power of 256 itself. So something very similar to adding and subtracting of that particular functions itself. What are the address related functions? So when you provide an address for, like, say, suppose in the earlier functions, if you see, in the mapping example, when you do this m dot balances, it is actually the address functions itself. So balances is something like this. So m is storing the contract's address, and contract address will have the balances, and then it can have the functions of delegate call, which is like a low level call. And then the low level call, you provide low transaction fees, and it is not actually advisable to use this low level calls because that will uh like will not have the sufficient gas to perform the transaction sometimes. So you do with the normal send or transfer itself to if you want to send out the transaction. So these are the other related function wherein send given amount of way to address will be sent, and if it is done, so it will be returning out either the transaction receipt, or it will just give out the failure message. Send given amount of way to address throw on failure, like it throws in custom error. If you can do that also if you want to when it comes to balance and transfer. Okay, so we have a one question. One suggestion: learning a programming language is best done by writing code. Reading out these slides is not likely to be. To have just a glance over these slides, open for a question. Okay, so we'll be writing out these codes as well. We'll just going through the syntaxes, what all we have in the current Solidity language. If you want, I can give you out the examples as well, but that will take a lot of time for each and every functions when we write the code. So, but eventually we'll be using each and everything like this inside the POCs that we are going to deploy in the next modules itself. So this is like just an overview of what Solidity has to offer. Because if you don't know that, then I think so you will not be able to do the coding on. We'll just write the structure of the smart contract, that is just adding out the licenses and the Solidity version. And here I'll be using Solidity version 0.8.0 or above. To have an example, let's just name it as a example contract, and we'll just define a basic function called get data value, which will actually return us a uint value. So it will be either it should be not inside this, but a public function. It's the the visibility of that particular function, and returns uint 256 is what we are going to expect. There's nothing inside it. We'll come to this later. No, sorry. Okay, so once we are inside it, we want a variable basically with something known as value, and inside this I'll be using an assembly keyword, which will actually skip the first 4 byte, and the function for selector will be given to us, and this will actually load the 32 bytes, which is the 256 bits data that follows the function selector into the value variable. So whatever we are going to define here, it will load into that, and once I define in value, we should be doing it with value so and so, and it will be something like mload add message or data, and it will get the function variable 0x04. Do a simple one rather than that. Uint A with uint B, and you just do a public function with a pure value. and returns end, and I will return something a plus b. That's it. So this is getting automatically compiled here with this. Once we call it deployed, we'll be able to see that it calls this particular function as well. And if we add like these number 1 comma 2 add, it will give out this number, and in the message.data part itself, which is this, the input is actually shown as 0x771, which is the first identifier of it, and the rest of this is actually the message value of the function itself, which comes in message.sig. So this is like an example wherein you get the values for this particular thing in a hash hexadecimal form, and if you see the decoded input, it says as 1 and 2, and the decoded output as 3, which will be shown as here as well. So this is what the data comes inside the message.data and can be seen in here itself. So whatever the transaction has been done. So this was a simple example for a message.data wherein you just get the value and the functions for selector will be shown in here, which is something like this. And we have questions. Can you describe what we are trying to do in this here in plain English, and then proceed to show the code, please? So what we are trying to do is we are just trying to see the message.data is since a global variable inside it, so that everything will be shown inside the input as well. So these things, if you want some time to decode the stuff, what exactly is happening in the code, you can just go into this input part of it and of the hash, and you will be able to understand what exactly this is going. You will be able to see it in this etherscan.io also in the transactions part as well. So let's say, suppose we are picking out these transactions, and if we go into this more details, inside this we have this as input data. For now, I don't think they have provided any input to it, but usually you will be able to see out every function that has been called in here, and you will be able to understand what transaction functions has been called for this particular transaction hash itself. So that is important because sometimes you need to identify what exactly the user is trying to do with that smart contracts, and it will just let you know what kind of intentions he has with the transaction itself. So that is the way you will be able to call out and read all these message.data that is important for you to write in this Solidity contract itself. Was I clear, Ramakrishnan? Oh, who was that? Not yet. What exact part did you not understand? Like where is the confusion? So this will be actually a big code. I'll see. We have the address of the owner, and then we want some kind of address for the renter as well, and we want something with the value that is being sent or the money being paid for the rent amount, and the ones with the rent amount is done. Yeah, this is done. Then we just start to put a constructor wherein we'll just take the value of that particular owner, and the actually the address of that particular owner and the amount that it will call once we start the smart contract. And inside the constructor, we want the values of the owner to be equals to the owner that will be calling out the smart contract itself. And if I have provided, yeah. So the renter will be the one who will be calling out the smart contract itself, and we'll be calling out using the MSG sender itself, and the rent amount will be the amount that we have asked when the smart contract will be deployed. Okay. Yeah, so this will be the your basic smart contract, and now you want something of a function where you will start to pay the rent, and it will be like a public payable rent. And you can also like make sure you want to add a kind of a modifier to it, which will be used by like only the renter should be able to call it, and no other person should be able to call it. So we'll be providing that kind of authority on this function for specifically for the renter itself, and you can do it with the help of a modifier to ensure that only the renter can call the certain functions, and you will
What are some of the challenges companies might face when adopting Hyperledger technology? Option A, integration with legacy systems and existing infrastructure. Option B, lack of skilled developers and technical expertise in blockchain. Option C, scalability concerns for handling large volumes of transactions. Or option D, regulatory uncertainty and evolving legal landscape around blockchain.
Just a quick info guys, Intellipaat offers you a blockchain certification course which will help you become an expert in distributed ledger technology, Ethereum, Solidity program and many more. Through this course, you will also receive additional courses co-created with IBM, namely IBM Blockchain Foundational Developer, and deploy a web-based blockchain insurance application. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description. Without a doubt, this course can set your careers to a new height. So visit the course page link given in the description below and take the first step towards career growth with the blockchain tech stack.
just mention that some kind of statement which is like a error handling statement wherein you provide like address of the sender should be equals to the renter itself, and only the renter can call this function, something like this. And once you call it, you just need to close it with this, and you provide it with this is the way you call a modifier. And once you calling this function with the modifier, you will just make it as payable, because once you are depositing the amount in the contract itself, you need to make it payable, and then you just do that as only renter will be able to call this function. And inside that you will just again provide some kind of global variable with the value. So guys, I'll be explaining all the concepts of I think so this global variables in this particular example itself, wherein the MSG value is the value you'll be assigning to that particular transaction itself. And you'll be seeing out like a rent amount, and we'll see if it is the correct value. Let's say the agreed amount is not what it requires, so we just do it as incorrect rent amount send, and we should make sure that it is already we need something to make sure that it is paid at the first of every month, right? Okay, so let's just deploy another is first of the month, and we want it to be called by the smart contract itself. We don't want to change its state. We want something to be returning as boolean, and that we'll just see what the current day is for the smart contract. Inside that, we'll be using the timestamp, and the timestamp should be the first of every month. So how do you define that? You'll just say it as 1 days of every 30 part. I think so days is like this. It should be 30 of everything. 30 for every month on the first date. You need to provide that. So this will be approximately a month, and just return the current day as 0. I think so that will work. Now you need to comma instead of this, so that's why it's just throwing an error. I'll just do deploy again. So as you can see, the transaction has been mined, and in this example what we have used is we have used a message.value and not used the message.data directly. And in this message.value, it is actually showing what the input is. If you see 0.608 is actually this particular rents function that has been called, and this particular rent function is the value that has been stored in the message.data of the call data. And if you see the decoded input, you see that this particular construction function, which is the function addresses of 0787 has been called with the amount rent of 8. So this is what we are trying to portray, that message dot data consists of the initial functions which are being stored inside the function value itself, and the rest of the value is stored inside the function 6. So if you're trying to see what exactly is happening behind the smart contract, what is the intention for this particular transaction was that initially it was trying to call out the functions constructor, which we understood with this input. And if we see it inside this, it will be showing that constructor was called with the owner and the rent amount was given as 10. So the deployed contract will consist of the balance of 10 itself. So the rent amount, if you see, is actually 10. And if you see in the call data itself, the call from this particular thing has been called for the rent amount itself. So this is the call data that has been recorded early now itself. And the renter amount is actually the amount coming in from here, this variable itself. So if you just go inside, and you can see this particular input has been called, and the decoded input is not getting shown because it is just going to call the rent amount public variable itself. So yeah, so this is a little bit of an explanation of to be rent to be paid on every first of the month. And what we are trying to just say is that the message data will consist of the function selector, and the rest of the functions that has been executed in this will be added inside the input, this input itself. If you decode, you will be able to find out what exactly it has been called. So yeah, these are these four are the values for the function selector, and this is the value which is called the parameters itself for that particular functions, which is the owner's address and the amount that has been called. So Ramakrishnan, did you understand now? Cool. So this, okay. So the error condition is this now. This is the error condition that you provide, require. So if let's say support an like rent can be paid on the first month is like something we are calling here, or maybe this rent message value is not correct, or only, let's say suppose we are trying to call this function parent and we are not the owner itself. Let's say suppose we are here and we are trying to call this. See, it gives you an error, and it gives you an error, and it will, I think so here it will actually provide an input wherein it says that only renter is able to call. So example.parent, and it will not execute until or unless that particular address was involved in it. So if I call it from here, this was the address, I guess. What if the renter does not have the balance? Can we add that? Sure, actually, let's just Ramakrishnan keep that thing for the POCs, and then we can just go ahead, like firstly, quickly wrap up this what Solidity has to offer, and from the next week, I think so we'll be able to start with the POCs of how the renter can be done and so on and so forth. Okay, so for now, the question, let's just see what all modifiers we had. Message or data is actually being shown in the transactions earlier itself for the call data, whatever has to be provided. And the message sig is actually the last byte of it, which is already called in the message value. And message value is the amount that is being currently provided here in the form of transaction. And if you provide like a negative value, it will just keep on throwing us the error that this is actually not a transaction that is to be sent out. And with the error message as incorrect rent amount, I think so there's something. Can you copy the whole code and paste? Sure. Yeah, so this was the message value number of ways sent in with the message. So as soon as you make a call to it, you will be just sending out some kind of amounts in way. And if you want to add it in Ether, you will be adding just 10 and the number 18 number of zeros to send it as 10 ETH, or maybe if you want to send it as some lower denominations, you will be adding it 10 to the power of that particular things, like GUE is 10 to the power of 9, so you will be adding 10 and 9 zeros if you want to send in the form of GUE itself. So yeah, now you have used for the block timestamp as well, which we have used for earlier uh, this itself, and here we are trying to make sure that it is actually getting sent on the first of every month. So it checks if it is first of this month, then only it will actually allow you to be sent on that day. Otherwise, it was as we were seeing earlier, it will keep on throwing the error that rent cannot only be paid on the first of the month. And then again, we just made this owner get the amount itself. And once you get the amount, once the renter agrees, it will just send out the amount to the owner with this particular call of the function itself. Yeah, so that was it. And that is how the global internet variables are and functions are being called when you are using a smart contract. Okay, so moving ahead, addresses also you have seen, and okay, for this address related function, I wanted to just write a small, contract wherein you will understand how this is actually getting used. A simple wallet. Make sure you copy the structure first of all. Then just write the class name as simple wallet, which what we are trying to do here, we are trying to use most of these functions itself so that you just get an idea how it is happening. So let's see. Should we write? We should be seeing what all balances we have received, and it's your wish either to make it public or private. And just to deposit money, and the same way like we have earlier added for the rent itself, we just make it very simple and just add it payable. And just add the balance received, whatever the money you have received inside the what do you say, whatever you have received in the transaction, you just need to add it to that balance received itself. Let's make it public as well, because we might need to check if the balance is correctly added. So this is how you use the another form of balance, and you can also check the balance smart contracts. Okay, if I can just use this. And I need the address, or not the address, actually we'll use it below itself. So we'll use the balance itself, and we'll use returns, or not returns, return address, this particular function address balance. So this is the function that is the first function which is used to fetch out the balance of address and ways itself. So when you will see, we'll call this message, it will actually give us the balances of it. So contract simple wallet is deployed, right? We just deployed the contract. Sorry. We'll just deploy the contract, and once the contract has been deployed, we can see we can provide like 10 way value. You can just provide it as ether and deposit money, and you can see balance received as 10 ether. Yes, sorry. So now you can see that message value is getting added as soon as you provide it here, which is a bit confused why it was not showing earlier. So now if you see in the input itself, it is calling the deposit money function with the input as this input as 10 ether, which you can see it inside the input. As of now, I'm not sure exactly why it is not showing, but this is what the value is inside the decoded input. And yeah, and the output is like it has received this value. So if you will just go inside the balance received that we have got earlier. Oh, sorry, I think so I'm showing the wrong transaction. Okay, I think this is also not getting shown. So the message value, you can see it's actually in this. It's like 10 and leading number of 18 zeros, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 15. Okay, I think 16, 17, 18. Huh. Okay. So this is the value in way that is getting called and balance is actually received. And if you see, the contract balance will also receive the value as 10 itself. So message dot send at the balance, it is actually fetching the current balance of what it is. Okay, now what was it? The send function also. Let's see how we'll just first call the transfer to the transfer. Just transfer as well to send out the money to or sweep out the money from the this particular smart contract to a particular function, and we can just type it as a function withdraw all, sweep out the complete money, whoever is actually trying to call this. Just public, and whoever makes the first call. This is actually for demo purposes. Please don't add it, because this is not an audited contract and it's very has some kind of vulnerability. So make sure you don't add it. And we'll just do it as payable dot message dot sender, and in this we do it as to dot transfer. Get contract, whatever the balance is, we'll just sweep it out completely. Okay, let's just deploy it again. Deposit maybe like 1 ether. It seems like a lot of value. Deposit money, we'll see the balance received as 1 ETH. You can see here, see it at the contract balance all. And now we want to be swept out, let's say by this particular guy. So what we can do is we can just call from this particular function and call this withdraw all. So you see the balance is actually 0 and this value has been added to 100. So has added to that particular function itself. So that is how the to dot transfer is working, and that is how similarly the to dot send can also be done. So you can send the given amount of way to addresses, and these are mostly like the same function itself. So I hope like you guys got an idea of how this is working, right? Write down the chat, please, guys, if you have an understanding of what I'm doing right now. Guys, are you following me? Were you able to follow? Mahesh Prabhu, Preeti, Ramakrishnan. So I hope now you are clear with the internationally available variables and functions, and as well as address related functions. Also, I've showed you like this require condition as of now in the above given smart contract. And assert is similar to it, but it is like if the condition is not made to be used for internal errors. So it is actually a condition given for true or false itself, and the condition throws if the action is not meant, which is very much similar to what a require is. And a revert is like another form of error handling wherein the execution is just dropped and everything is sent back to the normal state it was, the previous state itself. So what are the operators and functions in Solidity? So let's learn about the operator and functions. So we have the same things like we have in other languages as well: arithmetic, logical, and bitwise. Incremental and yeah, so arithmetical is like plus minus, multiplication and division and modulus. Similarly, we have incremental is either plus plus, it's like increasing a value by one, and minus minus, which is decreasing the value of one from the variable itself. So yeah, it's very much similar. I think this we can skip because there's like you guys might already know. And for Mahesh, it's like these are certain operators for which we use certain types of operations on the operands itself. When we say operands it's like this one and this. So these are the operands, and the operations are the addition, subtraction, multiplication, and division that we do on the operators as well. And besides this, we have two other operators, which is like or. So it's like a condition which is given either this or that. So it's like something similar to that. And the negation is like the value is actually not equal to something like that, which is just shown us with the tilde. And we have the right shift and left shift, which is also possible in Solidity as well. So logical operators is also there for the negation part, which is like from the exclamation mark, we can just mention that it is not an correct value. And percent ampersand is for logical and logical or. And this is for double equals to is for make sure that the value is very equal, like similar to what we are trying to compare it with. And not equals to is like this exclamation mark equals to. So this is another small smart contract that has been written by the guys, and you just have to do like some kind of value. So a equals to 10 is like assigning the 10 value to a, and plus plus is like just adding the value from a plus plus, it's like 10 to 11, adding one increment value. Programming languages, bitwise refers to the operations perform like on the binary level itself. So it's like manipulating the bits. It's like this operands, one and zero. It's like that's what we are trying to manipulate. So bitwise operations work on the binary representation of the integers and are used for tasks like setting, clearing, or checking if the state value is equal to, or maybe is like this or uh, the other value. So it's like something related to uh, manipulation of binary level uh, operations. So it's something like that. Something like that, but exactly that. And when I say binary, it's all about zeros and ones. So it's like to represent one, it's like 0, 1. That's altogether computer terms you need to have actually beforehand to understand this. If you want, you can go in here just to understand what the bitwise is. Okay, moving ahead, we have seen that this is some kind of smart contract with the values representing the above operators as well. So like a equals to 10, a plus plus, so it will increment the value by 1 after the execution, like plus plus a, so it will increment the value first and then show it in the a part. And certainly we have ampersand or double equals to, which is value. It will check if the value is equal to that particular previous operand or not, and not equals to, so it will make sure that it is not equal to it. It will either returns true or false. And yeah, so that's pretty much what the operators are doing. Then we have the control structure as well, and it has like similar to other control structure like if else, while, do while, for, break, continue, return, and the ternary operations as well that can be used in the smart contract itself. So it is more or less what JavaScript has to offer, and are available in Solidity except the switch and goto. So you cannot use switch as of now, but I think so in future that will also be implemented in Solidity. And yeah, so these are the state semantics that can be used, and parentheses cannot be omitted for conditional, but curly braces can be omitted for the can be omitted from around single statement bodies. So that is one thing you need to understand. And there's no type conversion from non-Boolean to Boolean types as there is in C. So it will just keep on throwing you these errors that explicit conversion is not allowed, and you cannot do these types of conversions. So if you try to do that, it will just throw you errors. So scoping and declaration, a variable which is declared will have an initial default value whose byte representation is all zeros, and the default value of every boolean is false, and the value of uint and int type is 0, which is very similar to what other language has. And since this is being like a statically typed language, the statically sized arrays and byte 1 to 32, each individual element will be initialized to the default value corresponding to its type. And in dynamic size arrays, bytes and string are the default value in an empty array. So yeah, that is an examples for the scoping and declarations inside Solidity. And declaration, a variable declared anywhere within the function will be in the scope for the entire function, regardless of where it is declared. So that particular function will be only available in that local scope itself, not globally available until it's a state variable. So input parameters and output parameters. So in Solidity, functions may take parameters as the input, but it also returns arbitrary numbers of parameters as the output. So input parameters are declared in the same way as variables. So if you see, this simple is a contract, and this is how you will be just providing the input the same way we have been seeing in the earlier contracts as well. And these are the input parameters, and for the output parameters you can just see that these are the output parameters that you need to predefine firstly tell Solidity what exactly you are expected to be returning, and can be declared in the same syntax after the return keyword. So you just need to let them know that this returns is actually the thing that we are trying to fetch, and then you can do your operation inside that function and return that value which you're expecting. Okay, so one thing For the slide number 81, actually constructor is not called like it is called with the same name of the function. It is called like this with the constructor keyword itself. So this is how you call a constructor instead of function name, which was earlier a part of it. Like if you just use this 0.4.0 version and above, then you will be able to call these constructor with the same name as the contract name. But from I think so version 6 or 7, this was updated, and you now need to call the constructors like this. So constructor are the first function that are executed when a contract is actually deployed, as it is like in classes in the other languages. So yeah, so it is very much similar to other languages as well. And these are the function call and return types which you can see also, but I would suggest you to avoid this because this is written according to this version itself, which is like a very old version. We'll ask the Intellipaat team to update this particular thing, but make sure that you just deploy these codes like this itself, as I've shared in the chat. Okay, now we have the function modifiers, which we already shared. So it is like modifiers can be used to easily change the behavior of the function. For example, they can automatically check a condition and prior to executing a function. So say suppose if I wanted like this particular contract had an admin, and I wanted that particular admin to only be able to call that function, or maybe only that admin is responsible for calling the function itself for like withdrawing of the funds, let's say suppose. So for that, we can just add out this modifier keyword and add this function wherein we just add the condition of what exactly the admin can do, and that can be added as a modifier inside the function that we have done here itself. Sorry for that. So yeah, this is how you call a modifier, and these conditions can be checked even before making the function calls because they have been declared in the function definitions in the smart contract, as we have already been seeing. And modifiers are inheritable properties of the contract and may be overridden by the derived contract. So these are like values that is inherited by the contract itself and can be overridden in the derived contract, wherein will see the concept of inheritance. So that is how the contracts can be modified with the in the derived contract itself. Okay. So this is an example. If you want to call a kill contract function through the only owner or the creator of the function, then this is how you can do it. You can just call out a function modifier contract, then just take the address. Function modifiers will be equals to this message sender, whoever is the creator of this contract, and then you can just add this modifier like this. If message sender is not equals to creator, then throw error, and it will just provide that error. And once you call that function kill contract, you can provide this only creator modifier. This function will not execute if an exception occurs. So yeah, if the creator won't call it, then it will not execute. But in the derived contract, if you just call out in the another contract, let's say suppose contract function should modifier, and in that particular only modifier, you can update or override its value to whatever function you're calling. Okay, there are also fallback functions in Solidity, and it's like a contract can have exactly one unnamed function which is deployed in the end. And if you want to deploy like say suppose fallback function, it should be only be call like this receive uh external variable, and yeah, so this is like a function, fallback function. So if like no other function is this function cannot have any arguments and cannot return anything, it is only executed on a call to the contract if none of the other function match the identifier. So you say suppose some person is trying to call withdraw only withdrawal, and but he is mentioning it as withdraw, so there's no function like that, so it will just re- uh, run this particular function itself as it is a fallback function, and will execute the transaction and nothing will happen. It has to check. We can also give like some kind of conditions inside it, uh, wherein we can tell that mm, this function does not exist in the smart contract. Some kind of condition we can give in here. Either it can be with require or assert, or with yeah, require and assert also you can just give that no function is existing. Okay. Furthermore, this function is executed whenever the contract receives plain ether. So when it receives either way or any other kind of denomination, it won't occur. But when he calls with the plain ether itself, like 1 ETH, 2 ETH, then only it will be executed. Otherwise, it will just revert back to the original state. Contracts that receive ether directly without a function call that is used for send or transfer, but do not define fallback function, throw an exception, sending back the ether. So if the fallback function is not there, it will just throw an exception that throw an exception and return the transaction into the state that it was originally on. So if you want your contract to receive ether, you have to implement a fallback function. So this is like a make sure thing to and make sure thing that your contract, if anyone tries to call, we should receive ether for that particular contract. When are we going through blockchain practical after this module? Everything is like practical from that state. Today also you saw some practicals, I think so. How was the like information in that practical? Like, did you get it? What I was doing? If you like guys were getting like understanding what I was doing on the remix editor, just give me a thumbs up on the chat or like something. Yes, okay, no. So that from the next time onwards, I'll just get to know like how you guys understand well. So if some kind of feedback, you can just provide it to me on the chat. So yeah, so we have seen the example for fallback function as well. Uh, and we now come to the part of inheritance. So inheritance is also like, as we have learned earlier, inheritance was also like a part of a solidity, like object oriented OOPS principle are also available in solidity, And Solidity supports multiple inheritance by copying the code, including polymorphism. All function calls are actually virtual, which means that the most derived function is called except when the contract name is explicitly given. And when the contract inherits the multiple contracts, only a single contract is created on the blockchain, and the code from all the base contracts is copied to that particular created contract. So you can see this is how we call the contract using the is keyword, and the contract owned is actually getting copied to this particular contract. So all the properties from the derived from the base contract is actually inside the derived itself. So you can call out this function owned, and yeah, so you can do whatever you want to do with the help of this in type of inheritance. And if you want to call both of these contracts, you can just mention as contract user is owned comma mortal. So it will copy the values of owned and mortal's contracts and will have you to access in this particular contract itself. So username function, and you can just try to maybe call this own function kill function in here itself. Okay, abstract contracts, and in Solidity, an abstract contract is a contract that cannot be instantiated on its own, but like it serves as a blueprint for the other contracts. And abstract contracts define a set of functions that must be implemented by any derived contract. These contracts are actually declared without an implementation in the abstract contract, leaving it to the derived contracts to provide the actual implementation. So this is like a example. If you can see, this contract fill-in is actually calling the function utterance return. Such contracts cannot be uh, compiled as we just talked about, but they can also be used as a base contract itself. So if you see here, the contract cat is fill-in, so it is just actually providing the abstract contract itself, and it is on the derived contract how it wants to use it. So yeah, it's just providing like meow to it as a byte 32, and if someone else calls the utterance, it will just provide the string value as meow. So now comes the interface. Interface are similar to abstract contracts, but they cannot have any functions implemented. So you can create out interface and inherit all the values from the that particular contracts, and like there are further restrictions and such as they cannot be inherit other contracts or interfaces. So if you call interfaces, it should not be calling out the other contracts or inheriting other base contract values. It should define a constructor, define variables, define structs and enums itself. So you see, you can create out interface like this interface token, and you can declare a function wherein you have declared a function called transfer, wherein you have provided an address receive address for the recipient and the amount itself. So this is how you can create an interface, and you can then call it to the other smart contract and just call it as, just make sure you have imported on the top as the interface, and then you can just start to use that particular interfaces. Okay, so event is also there, and it allows like the convenient usage of EVM logging facilities, which in turn can be used to call JavaScript callbacks in the user interface of a app. So events is nothing like, it just tell you that it has something has been emitted. So earlier, like before Hard Hat introduced, the concept of console.log or maybe printing was not like available on the smart contract itself. So what we used to do is we used to use this events basically to and trigger emit it as soon as the functioning was done to make sure that the logs were implemented and we knew that how the that function has been executed or not, because earlier it was very hard for us to debug, so we used to call out these events particularly, use these events as the printing statement to just get an idea how the smart contract is functioning. And events are inheritable and inheritable member of contracts, and when they are called they cause the arguments to be stored in the transactions. So to start with, we'll be not following this actually Testrpc.sh. This is like little bit of an old one with the help of VM, but due to some technical difficulties we might not have this VM available with us. But instead, we'll be using our local machines only, and that will be the Ubuntu as operating system. So, are you guys familiar with Ubuntu, or do you guys work on Windows only? Okay, Ramakrishnan is familiar. Prabhu works with Windows. What about the rest? So, our audience is like a 50-50. They are working with Ubuntu, and most of them are working with the Windows itself. But don't worry, it's very easy. Once you have the habit of using Ubuntu, you will be using that mostly. But let's see. For today's session, we'll be focusing on Ubuntu itself. Okay. So uh, we'll start with the. Let's just skip this because we do not have the test RPC, and the prerequisites for this is to be having a Node.js machine, in Node.js as a programming language installed, Go as a programming language installed, and yeah, so we'll be just focusing on these IPC itself, and let's start. So I'll be just sharing my complete screen now. So to make sure that our Node.js is installed, we'll just do as node hyphen v. Actually, to install Node.js, all you need to do is sudo apt get install Node.js. And once you just provide your passwords, it will directly start to install the Node.js. And since I previously installed, it will just like take a few seconds. But if you have not, it will take like 3 to 5 minutes to install Node.js, and it will also be installing your npm itself, not the npm, but yeah, it's your npm itself. And you can see the version is 6.1.4 if that is not visible. Then here the version says 6.14.8. Also, if you would like to keep these things in handy, you can just directly actually move to this NVM itself. And if you see NVM, so this is like a short guide which will help you to toggle between different version managers, and it will help you to install like node version 18 and a node version, like any node version within a Jiffy. So there's no dependency on how fast you can do it. And if you want, you can just follow this guide. I've already installed this, so I'll not be wasting your time with the installations, but I'll be sharing this on chat itself. So this is an installation guide, so which you guys should, I would request everyone to follow, so that you can just install it. So it will give you like different platforms installation, so you can install it with Linux and Mac. Also, previously you have seen that it can be also installed with Windows also. So even if you are using any operating system, you can just download and start to work with it. So since we have it, we'll just see as NVM. I'm sorry, you'll not be able to see this. Please let me know if you are able to see the screen, right? I'm currently working with the terminal. So guys, you are able to see the terminal, right? Okay. Uh, so NVM hyphen version. So if you see, I have this version installed, and if I'm currently using Node hyphen V, you can see I'm using version 10.2.3, and if I want to see what is the versions that is available, I'll use this command as just a second. Yeah, so it is NVM ls. So you see these are the versions available with it, and you can install whatever versions you want. And if you like get stuck, so you can just use NVM help, like the way I have used here, and you can just be able to see what all commands you can perform with the help of NVM itself. So if I want to like use the LTS version, so I'll be just saying this particular terminal to NVM install NVM install. Let's see what the command is. See, NVM install hyphen LTS. So it will directly install the long-term supported version. I will just say hyphen LTS. So it's directly installing the LTS version, which is version 18.18.0. And as you can see, I have just moved from version 10.0 to version 18.18.0. Sorry, I have not in using it. So it says once you have installed it, you need to use it as well. Sorry, facing with some technical difficulties with it. And facing little bit of trouble with the version 18 long-term supported. Not sure why, but we'll debug it later on. But currently now I'll be using Node version 16 as well, which is much or more latest to what we are using. So yeah, so you can now see the Node version is actually 16.20.2, and the NPM version is also upgraded to 8.19.4. Yeah, so now we have installed our node versions. Now we'll see what else is there. We'll be installing Go as well. So Go install for Ubuntu I'll be using. So this is the one that you guys should also have the link for if you want to work with Go. So I think I have Go installed in my system as previously. I'll just do Go version. And you can see I've previously installed this Go version here. You can follow the commands from this link that I previously shared. Just quickly share you the UI part as well. So this is the installation part. You can just directly go into it. Few of the commands only. If you have any previously installed Go, you can just remove it, and you can start with the exporting of the path, and then you are all set. So I think so that will be it. For Windows people, you can just directly download it if you have the UI, and then just double click on it. It will automatically be installing everything for you. Okay. So this part is installed. This is everything I think so is done. But before moving to the complete this how to set up your own private blockchain, we'll be also just quickly visiting the Remix Solidity browser. So previously also we have actually seen how to work with the Remix, and also we have learned how to write our smart contracts. So I think so 2 or 3 of the participants we were working with has not into it. I'll just quick. I'm sorry, there's a little bit of network latency for me. But I hope you guys are able to hear me, right? This is not causing anything. Okay. So these are the contracts that we were previously working with. So we created a simple wallet wherein we were depositing our money. We were checking out our smart contract balance. We were also trying to withdraw everything that we have deposited in our smart contract. And we have also seen what a fallback function is, and it is like something where you can create a function and it will accept the money even if nothing has been passed to it. But you can also provide some kind of conditions wherein you can let the contract know on what conditions to accept money and how to, if that particular person has sent it by mistake, how to retrieve it and so on and so forth. Yeah, so that was the previous part, and also we were working with the paying of the rent, as I was earlier telling. So this was the smart contract for that. This is like the version that we were working with. This was the license that we were working with for the smart contract. This is kind of an structure of a class, something related to class. And yeah, so once we have declared the smart contract name to it, we can just start to provide out the uh, variables that we want them to be working with. A constructor which will initially be which will be the first function that will be called as soon as we deploy our smart contract to the network itself. We have provided some kind of modifiers as well, wherein we have wherein it will work like some kind of restrictions for the functions to be called, and according to our conditions, the functions will allow that particular thing to be executed. Otherwise, it won't be allowing anything else to it. And you can see we have used this modifier earlier as well as only renter, and some kind of these messages for the require statements, which is like a check uh, checking of the if the particular condition is meeting. Otherwise, it will provide this kind of exceptions. And yeah, so that was it. We have also deployed like a first of every month the a random function wherein it will give out like the date of that first of the month for every for first date of every month. So you can call it with this function, and we are calling it, you can see here, to be letting it know that we can be able to, if it's only the first of the month, then only it will be allowed to deposit the money to the smart contract. Otherwise, it won't be allowing it. And you can add these other, you know, this fallback function as well. If you don't want the money to be lost, or you want the money to be actually held within the smart contract, if if he or she has tried to, execute the smart contract with the balance itself. So yeah, this is like how we write a smart contract. And in this, we can let it know remix what kind of languages to accept. If you want some kind of Python language to be accepted, you can just do it as this py, and it will include that kind of languages as well. So this is like a Solidity compiler version. What compiler version do you have? We have different, like starting from 0.1.1 to basically 0.8.21 and latest local version, whatever it is. And every version has different new upgrades. And yeah, so this is it. Whatever like you compile a version you want to compile the code with, you can add that, and you can check for the auto compile, or maybe you want the some, like, say suppose you are doing some kind of code wherein we get some kind of warnings. If you don't want to see it and it's unnecessary for you, you can just use this checkbox itself and you'll be able to do it. So it's not necessary you just want to come here and click on compile again and again. As soon as you uh, write your code, you can just check this auto compile and it will work. And if you wanted to like compile and run script, so it will just run the changes and do the stuff for you. Okay, so you can publish from on IPFS well from the from the remix itself. IPF is like a storage system wherein everything is stored in the form of hash, and you can use that particular hash to store on the blockchain, since blockchain is like very expensive to use if you want to store like a movie or maybe some kind of audio files. So it might be very expensive for you as it costs gas and the money to store it. You use these kinds of alternative to kind of send store the data on top of blockchain and make it completely on chain itself. So if you want, I've previously explained about IPFS, right, to you guys. Ramakrishnan, can you elaborate what exactly do you mean with the previously said question? So these are the sample codes that will be displayed as soon as you go into this Remix website. And yeah, so you'll be able to see that code. But these are like some custom codes that I have written for myself. And I'm been working upon other tutorials as well for learning out these marketplaces and how to deploy it. These are like a soft questions for you guys to just understand how the workings is. Okay, now we were learning about IPFS. So IPFS is nothing but you know some kind of file system wherein you can use to store your data, and it is actually free of cost. And IPFS is like most of the people who are using these NFTs and other platforms as well, they are using these IPFS itself to store their size data, high size, like more size data, and they are storing in it. They're using the hash, whatever it is given by the IPFS, and storing that particular thing on blockchain itself to make these things easy to use, and not so that no heavy kind of ethers are to be used for storing these data itself. So this is like a peer-to-peer content delivery network and is actually built around the content addressing. So you can store, retrieve, and locate data based on the fingerprint of its actual content rather than its name or location. So they kind of give you an IPFS link or hash, which you can directly use to find out your content, whatever you have saved on top of IPFS. So you can check out how it works. So I'll be sharing you this link as well. So just to get an idea, this is actually a very good tool to store large data sets on top of blockchain itself. And you can also host data and websites on IPFS to make it like completely on-chain and decentralized kind of thing. And you have different CIDs on IPFS, wherein you can be able to get those content quickly on top of blockchain itself. So we have a question, IPFS full form. So IPFS full form, I think so it is Interplanetary File System. It's might be written somewhere here. Not sure. Maybe in the docs itself. So I think so for the introduction part, you see the Interplanetary File System. If you guys want to like explore more of it, you can just go through this talks. So this is actually a very good tool. And if you want to like deploy your own marketplace sometime in the future, once you are like familiar with uh Solidity, you can just try to use these tools and you'll be able to publish your content into it and retrieve your content through it on top of blockchain itself. So yeah, you can also like do some kind of assignment with it, like wherein you can just try to install it with the desktop app basically and try to, push on some data to it and retrieve some data, some basics, nothing more to it. Because if you want like some high level, like deep understanding, you need to code it. But this will give you like a high level kind of understanding on how the IPFS is working and how the data will be stored. So try to set up like an IPFS desktop app and try to, send the data to IPFS and try to retrieve it from maybe some other machines. So we have these uh, things in details over here and you can go through it. Yeah, so this is IPFS, and so we were discussing we can deploy our code on IPFS using our remix itself. And these are also other tools wherein you can try to deploy your code as well. Okay, so this is how we'll be able to like if you want your local machine to be working with some kind of other network besides this network that is provided by Remix, you can change it from here, or you see this custom HTTP provider. This is the provider wherein you deploy your own private blockchain, and you can add this link and it will actually connect to your blockchain, and you can write the smart contract, and whatever smart contract you'll deploy, it will deploy on that particular chain itself. So this is how you will be able to connect with the Remix smart contract itself. You see it has a support for Git as well, the one we'll be learning today. And yeah, so if you want to just run a node and connect this remix to this particular node itself, you can use these commands, what we'll be learning today itself. Okay, so most famous one is the Goalie that we use, and or this one that is provided by uh this remix itself. It will give you like 100 different, like maybe 10 to 20 accounts with 100 ethers, and you can write your smart contracts and do some kind of testing, whatever you want. You can provide the gas limit, what you want to provide. So the gas limit is actually set to 3 million, and you can just adjust it however you want. And this value, if you want to say, suppose provided to like this paying of the rent itself, you can provide it here, and you'll be able to just call that function, and it will actually pick up this value and send it to the function as a parameter. You can also like say, suppose we are working on multiple contracts, you can just let it know over here what contract you want to deploy first. And if you want to see an example, let's say contract test example, and you'll be able to see that this contract needs to be deployed first, or whatever this is the contract you want to make it as a base contract, you can do it, and you can deploy it on top of this remix smart contract itself. So this deploy button is actually used to deploy the smart contract itself. And yeah, so if you have some kind of arguments that you want to provide, like in this, we have these arguments as the construction functions wants the owner's address and the rent amount that needs to be called for the smart contract to be particularly deployed. So you can add that address and the amount, and as soon as you, let's say, add this and like say 10 ethers, you'll be able to deploy it, and the deployed smart contract, I'll not just say 10, but there's a high value. So you can see you can use the deployed smart contracts here. So this will turn into, you can see these functions are written, whatever is public is actually getting displayed over here. So you see this parent is actually kind of a function here that is actually termed as public. So it is getting displayed over here. And whenever it is payable, it will turn red. And if you are like setting the values as it will turn orange. I'll just show you with the other example as well. And if you are just trying to get the value, not setting the value, then you'll be just seeing it as blue. Yeah, so that is it for just Solidity. You can also get your debuggers started with this, wherein you can just provide the hash which transaction you want to work upon, and you can just start to work with it. So if you like want to see the supported docs for it, we have this sourcify docs. You can so look with this thing. Okay, I wanted to show you an example of setter and getter functions. I can just show you with what storage. Okay, I think so. This will be a good example. But first we have a question. Hi, I'm not feeling well. I'll go through this today's session from this recording. If any queries, I'll post in a question on the remarks class. Kindly excuse. Thanks. Okay, Prabhu. So, if you see, the smart contract is a very basic smart contract wherein we have one variable called number and we have one function that will be working as something as a store, which is like a setter function. So this will work as setter functions. So whatever value you want to store will be stored here, and whatever value you have stored in this function will be actually retrieved with this itself. So this will be our getter function. So if you get it deployed, yeah, remove this. We don't need it anymore. We deploy this. We'll be able to see that whatever value we'll be able to store it here as a transaction. You see, the transaction is actually getting sent, and this is the transaction receipt for it. So as we have seen previously also, you see this is a transaction hash for whatever value we have stored here. As soon as we deployed it with the retrieve, you'll see that this value will turn into 1. So whatever number we'll be changing it to, it will override it and store this value accordingly. So this is how the setter function will work, and this is how the getter, you'll get to know this is a getter function. But in real world scenarios, this is actually not there. But we have different like kind of UI, but this is specifically for Remix for better understanding. Also, if you want to like call the fallback function, you can do a low level transaction, and the call data will be actually sending this to the fallback function itself, which is the value sent to our fallback function, which is the function that is comes into play when no other function is to be seen on the smart contract and still there's an execution. So that is how you can do a low level transaction for inside a Remix smart contract. So yeah, this is like a quick intro to what this Remix was. And do you guys have any doubt related to what related to this Remix IDE? Yeah, so as I was explaining it, this is the environment that you're talking about, the Remix VM Shanghai, which is actually the simulation environment for Solidity. So whatever is happening on Ethereum mainnet, you can mimic it here using this VM itself. So these are different kind of networks. You can choose whatever you want to work with. And yeah, so these are these latest kind of tools which everyone is currently using. But this will be like very like coming into play in very later stage once you have a grip on how the Solidity, how you write your code with Solidity. And once you have that understanding, then these are like tools which are helping you to, deploy your smart contract much more efficiently and in a very optimistic way. And these are different testnet as well, which will have its own features and different advantages over others. Can you share the link to get to the smart contracts developed so far? Uh, l- um, I have sent like the code previously. It's not actually deployed somewhere. It is like a code that is on my local machine itself, and that code I have actually shared it previously. So, what code are you looking for? The smart contract for the renting part, or this code that I'm explaining? Yeah, for that you need to like send a mail to these Intellipaat guys, and I think that will be like a headache for you. Let me just give you this example quickly, and you can just take it from today's chat and try to deploy it and play around with it. You can try to update some values or maybe some kind of other stuff you want to do with it. So just to avoid hassles, I've shared the code and everyone can use this code. I would highly suggest to take this and try to like break it or maybe some kind of add some other functionalities as well. I'll also give you like a simple wallet code wherein you can use your imagination to actually write some other contracts as well. Did you copy here? I have copied in the chat. Are you not able to see it? Hmm. Uh, in the chat, like guys, you are not able to see the code remix code, like Solidity code that I just sent. Am I allowed to send the txt file? No, I'm not. Oh, I think so. That was a mistake from my end. It was actually getting sent to the host and panels only. Okay. Hmm. So you have like got the smart contract for the simple wallet. I'll also am sharing you the smart contract for the renters now. Let me know if you have received it. Cool. So now you have both the smart contracts. You can just play around with it and try to write something of your own. And if you get stuck, then we'll just carry forward from there itself. Cool, guys. So this was Remix. We had a particular in-depth look into Remix IDE. So we have covered this topic, and yeah, so you have seen everything related to it. Later on, we'll try to maybe tomorrow, I think so. We'll try to deploy some kind of smart contract on a private blockchain, and we'll be able to deploy it on our and the transactions related to it. So whatever the transactions are here, so it is like similar to it, but not exactly like this. It is like in very detailed. That will be much more like in high level view of what is happening in the Explorer part of the blockchain itself. Okay, tool which is called the ETH Fiddle. This is similar to like our remix itself, but if you like have an idea of what is going on, like you just want to test out like one smart contract that just came into your mind, once you are just familiar with it, you can also use this ETH Fiddle itself. So you just, it's like a very simple tool. If you want, you can change your Solidity versions accordingly. Currently, we are using 4.1.18, and you see whatever we are trying to like use, we'll be able to view it here in this. This is something getting deployed by the Loom network. Let me see if I can just put it like up. Think so. I cannot adjust the screen. But yeah, this is the by the Loom network itself. And once you have like deployed these smart contracts, you can just compile and just deploy. And this is the wallet address it will get it will get deployed from. And there are other kinds of values. If say suppose you're deploying a constructor values, you can just add the values of what you want to do, and you can just do a deploy. And over here you can see the hash, what exactly is the transaction hash, which is like this, that is given to you. You can see it's here. You have the inputs as well, and the gas price and everything as a transaction receipt. And now if you want to call these functions, you can just call these functions, and you'll be asked if you want this particular for what kind of parameters do you want to provide. So if I say 23456, this is the function that I want to send. So you see it is actually updating it, and the transaction hash is this with the value set as 23456. And if you just call this get function, you see the values have been set as this. So this is like a very basic part of it. If you like feeling that remix is much more complicated, you can just come into here and start to write your smart contract. Very easy to use, no complications. You can fiddle around with it, try to use different accounts as well. For this particular smart contract only, maybe say own a smart contract here, and you just see if the message you're trying to send is actually from the owner or not. You can just try to take it as an assignment and do it on each fiddle, so that you have like two tools, basically tools of understanding on how these things are working. So I hope you guys are with me till now. Uh, just no like lot of technical details, but a very basic understanding of the tools, because these are like very powerful tools. And if you don't have like a proper understanding to it, you won't be getting your full potential out with this already. Okay, so that was the text files. So you can just remove the txt in the end, and just run the Solidity or copy paste the Solidity file as it is on the Remix browser, and then start to fiddle around with it. Try and adding like say suppose uh to maybe remove the on the every first of month, you can just try to deposit it like that itself, and try to you know uh fetch the values as soon as you have the money inside the smart contracts. Maybe try that. That's like very simple, basic one for the assignment. try to like it will be very much similar to what a simple wallet we have, like how we have executed simple wallet. It should be very much simple to that, and try to add that function and remove. Don't you be using these to get the value of every first month. Don't for first date of every month. Don't use that, but instead just add the value and just sweep out the value as soon as you execute it. I think so that will be much more easier for you guys. Okay. Moving ahead, we have MetaMask. So to download MetaMask, you just need to do go to like MetaMask and on browsers like Firefox, Brave, Chrome, whatever the browser it has. Just be quickly seeing. Okay, so let's just start. Now we have this MetaMask also, that we might need. So this MetaMask is actually available for different browsers like Firefox, Chrome, and you can download its extension, and you can also download it on your local machine itself. So you can just click on download, and it will give you like if you whatever browser you're using, if it is compatible, you can just install it like this, and it will be something like this given to you. So it will actually be working on the mainnet initially. So as soon as you enter it, you will be able to see what kind of holdings you have and what kind of assets you have. And you can move on to different other networks from here. So Ramakrishnan, actually you can uh, uh, ch- if you want to go connected to your localhost network, you can just click on localhost 8545 and actually see on which port are you running your local private uh, you know your local private chain, and you can then connect your MetaMask to it. So that is how you connect, and these are the different networks itself. If you want to see like huge chain of what networks actually it is supporting, so you can just visit this chain list. So these are actually the chains that is actually supported by Ethereum or EVM based wallets, and EVM based wallets are these wallets like MetaMask. So these are the chains that you can connect to, and mostly we work with something called as Corely. And if we click on this, so we'll see that this is like a test net. And if you click on connect, you'll be seeing that it is able to connect to this particular wallet, right? So these chain IDs are actually very crucial, and it differs from each and every chain. So the mainnet Ethereum chain ID is actually one, and different other uh, networks are different other IDs. So yeah, so if you want to see with what Polygon is also doing, actually just approve it and it will just switch to that particular network. If you want to work with uh Polygon, so by is the one you see, add to MetaMask, and you can just quickly add it to the MetaMask itself, approve, and you will be able to switch from one network to another within just a few clicks. So it will actually give you uh the current information. So this is like the chain ID for Mumbai, and you can add it custom also. So how do you do that? You can just go into like your settings, and in general, I think so it's not in general. Just a second. Yeah, sorry, it's in networks, and add a network will open this tab, and then you can either add a network manually if you have like a custom blockchain for yourself, or you can just do it from this website chain list. I'll just give out this as well to you guys. So this will easily add it to your like whatever famous networks are available. It will add it to your MetaMask easily. So this is one of like a important website you can go around and play around with. Okay, that's how you will be installing MetaMask. And once you have these MetaMask, you can do whatever you want to do with it. And yeah, so let's just see. MetaMask brings Ethereum to the browser. Let's see how to install MetaMask as a Chrome extension. We have seen this. And to like little bit of theory, wherein we get to understand that MetaMask is a bridge that allows you to, you know, visit the distributed web of tomorrow in your browser today. So you can basically inject it in Ethereum as well. If I want to show you that, what you can do is, so guys, does anyone of you want to take a guess how you can integrate the MetaMask with Ethereum? Anyone? Okay. So if you want to like connect to this MetaMask itself, you can just do this wallet connect. Not sorry, connect to a wallet. So injected MetaMask, and you see you click on next, connect, and now you are actually connected to Ethereum. It's that simple. This is how you will be able to connect to Remix. So now whatever code you write, as soon as you click on deploy, it will be connecting to whatever the MetaMask is connected, whatever network is the MetaMask connected to. So since it is connected to Goerli, so it is connected to Goerli. You can see over here it is written as Goerli 5 network. So if I want to switch it to Mumbai, you see it will switch to that particular network, Mumbai. So whatever network you want to connect with, it's actually will be connected to that particular network. And these accounts.
What are the basic steps involved in creating a private blockchain with MultiChain? Option A. Define the network participants, configure access rules, and set up the Genesis block. Option B. Choose and download the appropriate MultiChain node software for your operating system. Option C. Install and run the node, connect to network, and start creating assets and streams. Or option D, all of the above. Please do mention your answers in the comment section.
Just a quick info guys, Intellipaat offers you a blockchain certification course which will help you become an expert in distributed ledger technology, Ethereum, Solidity program and many more. Through this course, you will also receive additional courses co-created with IBM, namely IBM Blockchain Foundational Developer, and deploy a web-based blockchain insurance application. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description. Without a doubt, this course can set your careers to a new height. So visit the course page link given in the description below and take the first step towards career growth with the blockchain tech stack.
Will not be coming into like these accounts will be actually the account that are shown here. You see this account. If you move your account to this, you suppose it will and connect on click. You see, it actually changed from the old account to your new account. So you have now two accounts. And it will show as 0 Ether because we are actually working with this Mumbai testnet itself. But the value, whatever you provide, I think so it will take the value as that particular thing. So yeah, it's now updated. So you can provide these value on this Mumbai's Matic itself, and this value will be actually used in Matix, not in Ether. So that particular thing is actually pending here, or is a glitch. It's not getting properly picked up. So yeah, that's how you connect remix with the MetaMask. Are you clear, guys, with that? Yes, Mumbai is a test network, and its main network is called Matic Polygon. So you can see that here in the in the chat, I've provided one link called chain list, right? Guys, you can see that, right? So this is the Polygon network, which is like in, okay, guys, I've explained this. So anyone of you would like to take a guess what kind of chain Polygon is? What is the term that it is called? I've explained this in the previous sessions. Cool. Yeah, it is a sidechain. And we have other networks as well. You can see here. And whatever network you want to connect with, you can actually connect with. Arbitrum 1 is also similar to what Polygon is. It is actually used these network for gaming, Arbitrum 1, and was the only network which was like not sinking when we had the bear run, and it was actually moving up in price. And it is like a fast version of Ethereum, and it's making like Ethereum much more sustainable, and it's like advanced scaling solutions to it with the rollups and the zero knowledge proofs. So zero knowledge proofs is like kind of a technology wherein you don't provide the information, but you know who that particular person or this an address is. So you have an identity of it. So that is something called as zero knowledge proof. wherein you have the proof that who that particular address is. Yeah, so these has these kinds of solutions with it, and is also a very fast scalable solution, which is improving Ethereum's quality, and it's working as a side chain. And whatever you do your operations into it, and then you can just go back to Ethereum. So it will put all your transactions into a chunk and then send it out to Ethereum. And that will be registered on Ethereum as well as on the side chains itself. So yeah, that was MetaMask and everything. Now let's move ahead quickly. We have learned. So guys, do you want me to explain how do you install MetaMask on your this machine, or is it like fine? You can guys manage it by yourself. It's just adding an extension to your browser. Guys, do you want me to continue, or should I just work with this installation of MetaMask, explaining you how to add it to your browser extension? No, Ethereum is also on proof of stake. So actually, actually might be tad bit of wrong, but it is actually using PolyBFT, Polygon, which is like a consensus algorithm customized to bridge with the support of bridging mechanism that enables the passing of the random messages between the Ethereum network and the proof of stake blockchain, which is the root network itself. So it is not on POA but on POS. So I think so you have tried to, Ramakrishnan, if I'm not wrong, you have tried to set up your own network, and in that you might be working with a consensus algorithm, right? Which was, I think so, Click and Ethash. And Click is on POA, if I'm not wrong. That's what you meant. Yeah. So Click is like, in that we use Click because it is kind of a very fast setup, and it is just for understanding. And the mainnet is actually was running earlier on proof of work, has now been converted into proof of stake. I've previously also told you guys uh, that it has currently been shifted from proof of work to proof of stake. Do other guys remember that, or is it like? Yeah, I think so. There's also might. But future is proof of stake to proof of authority. No. Future is proof of stake, and it will be, I think so, that for like couple of years. We are not sure if these has any kind of limitations as of now, but it just recently shifted from proof of stake. Proof of authority is not, it's not actually like better than proof of stake. So you just, okay, I want to be sure to learn future value. Yeah, so proof of stake, we focus on proof of stake. So for custom your setting up your network, you might be using proof of authority. We'll be also using proof of authority, but proof of stake is the one that you should be using if you want to set up your own private chain. Or else you can also use the other network called Hyperledger Fabric, which is also a very good example for setting up private chains. Like, sorry, private blockchain. Okay, cool. So this is like adding the extension itself. Once you install it from the website, that I just gave you earlier. Once you click on this download option, so these are all the browsers that it supports: Chrome, Firefox, Brave, Edge, and Opera. And if you are using any of these browsers, you will be able to add it here. So all you need to do is install MetaMask for Firefox. It will just download it, and it will then ask you if you want to add it to your network itself. So that's how you will be just adding it, the extension. You see, add MetaMask. This extension will have permission to access your data for all websites, input data to your clipboard, display notifications, and yeah. So these are all the things that it will have access to. And if you don't agree, you won't be able to use MetaMask. So yeah, just agree and let it access your information. It won't be signing off your the transaction, or maybe hack it in that way. So yeah, it will just read it. It will not do any kind of write permissions from the function itself. Yeah, so that was MetaMask. And you can also follow these PPTs to create a basic this wallet itself. Is just sign up few just same as like how you create your Facebook account. Similar to that, add a password. They will give you like this seed itself. Make sure machine, or maybe write it down somewhere, and copy it. And this is like a seed phrase which will be of 12 words. And even if you like lose your password, you can get it back with the help of the seed phrase. So as soon as you add it, you will be logged into your network, your wallet itself. So you won't be losing out your uh, tokens if you even lose your password. Okay. So once you are ready, we have seen how to access the networks. We have seen it automatically creates your own account, a new wallet. Maybe say suppose for demo purposes, you don't want to use this network itself. So what you can do is make sure you are on the correct network, and then just click on accounts and add accounts. And you can name like anything to it, like testing wallet, and then you can just create it. It will name it a testing wallet and give you a new address. And now you can do whatever kind of operations you want on any website using this address. And if you want to like access its private keys, so you can show it here, add your password, and then it will actually give you out your password for this particular address. So this is like called as non-custodial wallet, wherein the complete custody of the wallet is actually with you, rather than the wallets that you get on exchanges. That is like a custodial wallet, wherein the private key is actually with the cryptocurrency exchanges, and they just give out the addresses to you with the mechanism of creating the EVM able wallets from one seed. And yeah, so it's like basically they have the control over your wallets, and they kind of have some mechanisms wherein they work with their operations and sweep out these balances from your account to their account, and just give you access to little bit of funds, whatever you want to access. So if you want to like uh, sweep out all the balances, you need to request or raise the request from your wallet itself just by doing this send function, and then add the addresses. And once you at that address, it will actually go as in a request to the cryptocurrency exchange, and the money will then be transferred from a different account. So that is like some kind of custodial wallet thing going on. You can just, if you want, if you are interested, you can look for it, how exchanges are handling their wallets. Okay, so that was custodial and non-custodial wallets. And now comes the fun part of deploying our own private blockchain. So these will be the steps. And here you can see this is the website for Geth. We have previously also seen this. Uh, so this is like a communication portal to Ethereum from your between your local machine to the Ethereum network. And using this, we will be like able to communicate with Ethereum network however you want. So this is like they have different kinds of implementation. You can just look around, but today we'll be just focusing on deploying a private network on top of our local machine. So yeah, I'll just be sharing this to you as well. Okay, this is done. This is done. This is also. So once you are installed Git, we'll be just registering an account on Ethereum blockchain. And once you have registered your account on Ethereum blockchain, you can create an autonomous private blockchain, which will be a small group of yours, and you can perform transactions internally from this particular local node itself, or whatever node you want this node, however you want to connect it with. So you have to give out the access to, or make it like public, if you want it, if you want others to also connect with it. So installing, let's start with the installation part. So as we saw previously that we need Go language to be installed, that we can see here. It's actually I'm not able to see it. Yeah, so I think so now you'll be able to see it. So now you have seen that I have this Go versions. Also, I have this Node version with me, and NPM version is also with me. Now to get started, to build our private blockchain, we need to install Git. So how do we install Git? We'll just do sudo add apt repository by Ethereum slash Ethereum. So you can see these commands here as well. Installing Git. For whatever operating system you want to install, you can install it from here. And it's using VPS that we are doing. This is the command, and we'll be just following it and adding the Git to our local machine. So let me share this link with you as well. Guys, make sure you save these links, because I don't think the team will actually be sharing it to you again. So make sure you share it, let's say, save it by yourself. Also, guys, you are able to see properly the screen sharing and everything, right? Yeah, I'm facing a technical difficulty wherein says, okay, no worries, we can just do sudo apt get update. We'll just add a force command to it. We'll be just waiting out the dependencies to get installed. I think so dependencies are getting installed, but this is kind of a hindrance, but I don't think that will cause a problem. So let's just go and install this Ethereum into our machines. It might take a little bit of time to get installed. So it's just of like 5 MB. Not sure why the speed is not coming in. But this is since this is getting installed. Okay, let's just add it as MK, some kind of name to it, and make a folder where we'll be creating out this Genesis .json, and that will be, let's say, suppose, what do we say? My blockchain, maybe. Yeah, my blockchain. So you'll just go to my blockchain, and you can just use Genesis .json. And we'll we'll just find this genesis.json, this template, which we'll copy paste into our system as well. Okay, we can find it maybe here. Genesis. Yeah, this is it. We'll just copy paste it. Here. I'll share this with you as well. So you guys also can copy it and create your own Genesis. Meanwhile, this will take a little bit of time to download. Okay, till then, we can see what all things are to be actually added to the Genesis block. I think so. This thing might need to continue tomorrow because this might take a little bit of time because of the internet speed. Uh, we might need to resume tomorrow. But for now, we'll just see what all things are there. And so inside this, as we see, this is like a config file basically in which we provide kind of one chain ID. And we know that chain ID is different for different networks. So it can be, if you want to use Goerli, you can just use it as 5. And different, if you want to use mainnet, so you can use 1. But I would suggest using this chain ID as 1, 2, 3, 4, 5 itself. So yeah, this is the thing that we'll start, and from the homestead block it's like 0. This is because we are trying to start it from the first official stable version of Ethereum protocol, and if you plan to use this lease, the attribute should be actually set it as 0. And next is actually the difficulty, that is determines the difficulty of generating the blocks, which is here. You can set it to as maybe 1, 2, 3, 4, whatever you want to set it. And the next is actually the gas limit. What is the this indicates the current network wide gas consumption limit per unit. And gas is, as we all know, the fuel that is used to uh, pay the transaction fees on the Ethereum network. So we have to provide some kind of gas to actually initiate the transaction and get the transaction confirmed. Then we have this lock as well, which is like used to start some accounts with the positive balance in the network. And at this case, we do not define it any account because this will actually be used further ahead. So the other attributes refers to the protocols and the attributes that will be used on the network. We set the default values for the Ethereum network as of now. And yeah, let's see if think so. This might take little time to download. So till now we are just actually downloading the Git, and once we have installed Git, we'll just use this command as, okay, we need to save this. And once you have created this genesis.json file in Ubuntu, you can save it with either Control plus O, or in Mac also you can actually use Control O to save it on the Nano editor. So yeah, Control O and then Control X to exit it. So once you have created this genesis.json file, all you need to do is like check if the get is installed properly. So you will be using get.-h, and it will actually be giving out an idea if get was successfully installed on your this network itself. So it will actually show the history helper command for this particular function. Okay, and once we have actually cloned this like installed this particular commands, we can just go into the tag of Edureka, or maybe we'll not be using the Edureka as of now, but this our own custom thing that has been given by the Ethereum network itself. Also, guys, do make sure that you have installed Git, and if Git is not installed, you will not be able to get this Git code also. So till then also we'll have seen that how to install Golang, and yeah, so these things we'll be skipping out. If you want, you can guys follow this PPT for installing Golang itself for only. But otherwise it's very simply given out on the link that I shared you previously for installing out the Golang. Let's see, besides this, what else we can do. Okay, chats. Questions. The steps on the slide don't match the Ethereum website. Which one should be the following? I followed the Ethereum website steps and got the private blockchain started. Yeah, so actually you guys can use that particular Ethereum website itself, because that is like updated one. I'll just share that link as well. So Ramakrishnan, if you want to share the link which you are actually using, you can share that on the chat. So this is the document we'll be following, and we'll be creating the Genesis block according to it. Okay, so that was to install this Go version, and we might have to postpone our session to tomorrow, because there's this one prerequisite that is actually might be an hindrance. I think most of you guys left. Ramakrishnan, I will be joining in tomorrow, and we might add 1 more hour for smooth versioning of adding this network. So apologies for the inconvenience. And we shall continue tomorrow. We'll take 45 minutes extra because if you guys also want to code along, so you can just add this command sudo apt-get install. I have shared these links previously also with you. Yeah, what problem are you facing? Did you try adding the network like this? The way I showed you to connect with the network. Here, go in here, and select a network, and then on what port is it actually running? Localhost 8545 or any other? I think so 8545 it will be running on. You're running the node, right? Okay, as soon as you click on here and then where do you go? Like have you settings? I got to add network, okay. You add network. Not sure if that is possible with me. Do I have the access for that? I am not sure for that. So when you run this network, did you create a wallet as well? Your first account on Git? I think so. You did import the miner. Yeah, that is correct. So did you switch to that particular network from here to just localhost 8545? Something like this. Did you try? Okay, once you have created the wallet, you like see that let's get set up and you need to import that particular wallet into MetaMask. how you can do it, like import account, add your private key from that particular account in here. And once you add the private key here, you will be able to see that account in here. And then you need to add your blockchain network with the, let's say, okay, so we'll try to do this. Support network connected sites on details. Yeah. Settings. Just stop it for a minute. You need to go to settings, networks, add network. And in this add network, you add network manually. And then you add it as my blockchain. Then you provide the network URL, that is HTTP this 127.0.0.1 8545, and then the chain ID, whatever you have added in the Genesis block to start the network. So I think so in our case it will be this, and currency symbol, whatever you have earlier if created a network. So let's say suppose you have added a, so what would you have added? My blockchain only, let's say. Verify, okay, blockchain explorer, and you just click on save. So this is not valid, maybe this. So yeah, this is like you have to add the chain ID here, and once you are be able to do it, you will just save it, and think so they'll be having your network itself. You have questions. This is the error I see as well. No error appears before that. Okay, I'll explore further and see. Yeah, this is how you add your custom network to your MetaMask itself. That's the only way. If you want, you can just try to do it in another chain ID, maybe 5, or actually you might be need to provide it in the hash. That might be the problem. So let's see. Chain list. You see the chain ID as 1, right? If I'll just go for curly to testnet, this is the one, right? Okay, for me, I think so. The error is because it is not able to fetch the 8545 since I'm not running it. So that might be the case for me.
So coming to the first question on this blockchain interview questions and answers set, it is compare blockchain with relational database. Well, whenever we think about comparing a blockchain with relational databases, 4 points are very important to be discussed. The first thing is the unit of data. In a blockchain, the data is stored in entities called as blocks, while in the relational database management system, it's stored in the form of tables. And then the second thing when we talk about is the point of failure. In a blockchain, there does not exist a single point of failure which might end up catastrophically. But then when you think about RDBMS, there are many points where if it fails, things can end up completely bad. Now, when we're talking about the third point, it's centralized control. In blockchain, there is no such thing as centralized control. The data is maintained in the form of ledgers and then it's worked on based on that. And of course, when you're thinking about RDBMS, you do have the database management system and the admin who sits as the centralized control admin basically working on the data. And then when you're thinking about editing and deleting data as per you wish, in the case of a blockchain, that is absolutely not possible because again of the ledger, the hyperledgers and the data scheme that blockchain is built upon. But then when you think about a relational database, yes, it is possible to add data, edit it, modify it, and of course delete it as and when you require. Here again, in both places, there are many authorization techniques and safety measures that are put into place, but at the end of the day, it is possible very easily to change data in your RDBMS. Now, coming to the second question, it's what is blockchain technology? Well, you do have to know the answer to this in a clear and a concise way, because if you're at a blockchain interview, there is a very good chance you can get carried away with this answer, but then try to keep it very concise. See, a blockchain is nothing but a very simple incorruptible ledger that consists of multiple transactions that happen over the web. All of these transactions actually get recorded or they get programmed, right? It doesn't have to be a financial transaction, but it can be anything that can be put down in a text editor. You can have ledgers of these, you can have all the data stored in it, and you will have multiple copies of the data across multiple ledgers to make sure that even if there is one entity that fails in a blockchain, the rest of the chain has the data backed up such that it can pick it up and begin work, and in fact continue work without having any disruptions as well. So the technology that allows for this is blockchain, and it's been one of the most revolutionary technologies of our time, and it was made very popular to us by a cryptocurrency called as Bitcoin, and more on this in the next couple of questions. Now, moving on to question number 3, it states, what do you mean by blocks in the blockchain technology? Whenever we refer to blocks, right, understand this. A block is simply a list that consists of the records of data that's present in it. Whenever these lists are combined with each other, right, when there are more than one list, they're called as blockchains. The chain of blocks, right? A block contains a list of records. There are multiple lists. These lists individually become a block and eventually becomes a blockchain. It is as simple as that. Let's say, for example, there's an organization that has, let's say, 100 ledger books, a combination of which we entirely call it as blockchain. But then with these 100 ledger books, if you start picking it up one by one at a time, right? So there will be 100 different blocks, and there's one entity that's called as a blockchain that consists of these 100 ledger books. It's just a way of naming it, but then this is how it goes. It's a very important thing that you should know at this point in time. Moving on to question number 4, it states, how is a block recognized in the blockchain approach? Well, when you think about these blocks, this list, the amount of data that gets stored into it, all of these blocks has something called as a hash pointer. These hash pointers basically link to the block, and it makes sure that it has a link between the previous block, the transaction time in case if there's a transaction that happened in the data, and of course a very clear and a concise way of stating the block. There is a transaction at this point in time, this date, up to milliseconds as well. So whenever having the recognition of a block is in concern, think about talking about a hash pointer and how it links one entity in the block to another, and any transactions performed in a block will be recorded with the timestamp of the transaction. Now, moving on to the 5th question, it states, is there any network specific conditions for using blockchain technology in an organization? But then when you think about it, right, it has to be a peer-to-peer network, and it has to have all of the wired protocols to ensure a lot of safety parameters and continuous connection from end to end. So what it really does is it validates the new block simply and helps the companies or helps the people who are willing to start up, this kind of a blockchain and bring it into their organization. It does it very easily because you really do not require any sort of third-party application. You really do not require any sort of expensive hardware to get started, to be honest. But then having the network is a basic requirement. So do talk about having the network and the protocols that govern the blockchain technology. But then do understand that there are no specific or expensive solutions to a blockchain requirement while beginning. Now, moving on to question number 6, it states, is it possible to modify the data once it is written in a block? Once a data gets written into a block in the technology of blockchain, the answer is no. It cannot be changed, because if you require any sort of customization or change or modification, all of the data that's present in all of the blocks must be removed, and then whatever modified data is there, it has to be put in to all the blocks. This is one very important reason that forms to be the entire foundational concept of blockchain, because at the end of the day, data is extremely cared for in a blockchain technology aspect. And here, when you're doing this, if you just modify it in one block and leave it, it really doesn't work, because blockchain doesn't work that way. So if you have to change something, you have to change throughout the entire blockchain architecture that exists, and then only you can have your new data or modified data to be present in a block. So when you're asked this question, make sure to present yourself this way. Now, coming to question number 7, it states, what type of records can be kept in a blockchain? Are there any restrictions for the data that are kept in a blockchain? Again, a very straightforward question. This is a very, very important question that gets asked a lot. Well, the answer is no for the second part of it. Is there a restriction to store any sort of data? No, you can store whatever is required, but then you must note, what you have stored, because at the end of the day, storage can be limited sometimes, because, technology, it works in a way where records get duplicated multiple times to make sure that your data redundancy is kept in check, and it is very much required to keep your data safe. So in that particular case, even though there is no restriction, it is always very valid to take care of the data that you put into a ledger. Now, what are the common types of records that are usually put in? Think about medical transaction, think about identity management, right? So, in India, we have something called as the Aadhaar. In America, you have something called as the Social Security. In America, you have something called as the SSN, or the Social Security number, and more. And then you have the transaction processing details, you have organizational details, management activities, key documentation events, and a lot more. So when all of these data are concerned, you might be asking a question of saying, is this all? Can I store only 6 types of data? No, because as I just mentioned when at the start of this answer, you can store whatever you want, but practically blockchain is used for this purpose. Now, with this, moving on to the 8th question, it states, what is encryption and what is the role of encryption in blockchain? Encryption, as you might know it, is a method you use to keep your data safe by changing its format, or by changing something in a way where it doesn't give out what it's meant to for the naked eye. You can have a lock-and key system, you can have multiple ciphers, you can have multiple methodologies that you can use to encrypt your data. So whenever you're encoding a data, you're converting it from one kind of a format to another, where you can have it sent out through the network then, and then having the ability to know that someone in the network can capture your data and may misuse it is very important, because if you just send the data as it is, someone sitting in the middle of it during a phishing attack or whatever it is can take up all of your data and misuse it, right? So that's not what we want. So to avoid all of this, so we encode the data in a very strict way, in a way where only the receiver knows how the original data can be obtained from whatever was sent. This process is called as decoding the data, and doing this will make sure that there's overall security, your blocks are valid, and of course at the end of the day your entire blockchain is kept secure because of this. So at this point in time, it's very important that you understand encryption and you know how it works whenever data moves around in blocks, especially in the case of blockchain. Now, coming on to the 9th question, it says, what exactly do you know about the security of a block? Here's a very important question, and the answer to it is very simple. A block cannot be customized by all of the users on a network. It's only on priority authorization is required, and this authorization methodologies and protocols that are put into place will make sure that your data security is at top notch. That is, it has an excellent level of security. And when we're thinking about every single block, right, each of these blocks can be secured using cryptography, where you can have a lot of methodologies put into place where the organization or the person maintaining the blockchain really need not break his or her head about the security of the data, because at the end of the day, if it's in a blockchain structure, it's secure. Plus added parameters for the network makes it even more secure, and then individual block level cryptography methodologies will make sure the data is almost bulletproof in the network of a blockchain. Now, coming to the 10th question, it states, why blockchain is a trusted approach? There are many reasons why one would go on to trust a blockchain, and here is why. The first thing what happens is that it is compatible straight with any other business application. One, because blockchain is open source. Second, as we discussed, it's completely secure. And third, even if it was intended originally for online transactions, developers have paid a lot of attention, especially to the field of security, because in today's world, cybersecurity, keeping your data safe, and all of these are primary concerns, right? So to make sure all of this is put into place, no matter what business you own, no matter if it's an online business, no matter if it's a medical institution, or whatever you can think of that you're planning to implement blockchain into, do understand that the data will be secure. It's open source, so you really don't have to put in a lot of money at the start. And if you have proficient developers who can handle it, then you will have a very effective chain at moving your data from one point to the other. So a blockchain is easily considered because of all of these factors, but the primary one being security, in my opinion.
Just a quick info, guys. Intellipaat offers you a blockchain certification course which will help you become an expert in distributed ledger technology, Ethereum, Solidity program, and many more. Through this course, you will also receive additional courses co-created with IBM, namely IBM Blockchain Foundational Developer, and deploy a web-based blockchain insurance application. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description. Without a doubt, this course can set your careers to a new height. So visit the course page link given in the description below and take the first step towards career growth with the blockchain tech stack.